Hello VTU students of the 21 scheme batch. If you are having 21 Math 11 backlog or Engineering Mathematics 2 earlier under the 21 scheme VTU, that is older scheme, then this video is especially created for you. That means if you are watching this video right now and if you have 21 Math 11 as an earlier, then you are going to clear 21 Math 11 once for all, this time 100% guaranteed. In the previous video, I made a 6.5 hours mega revision video for the 18 Math 11. So if you have friends from the 18 scheme, then please do refer the video to them. So today also I am going to do the same. That is a structured, strategic and complete solution package for 21 Math 11 so that you can easily clear it. So if you exactly follow what I say, exactly follow the strategies which I tell you, exactly follow the problems which I solve and practice well, then you are going to clear 21 Math 11 once for all, 100% guaranteed. And also after this video, that is before the examination, I will be updating a set of model question paper for you to practice and be more confident in clearing the paper. So please stay updated on my channel and also please do follow my Facebook and Instagram pages for the model question paper updates. And let me clearly tell you something very important. See, there is nothing called as a passing package. There are many videos and students searching for passing package for 21 Math 11. See, don't believe in shortcuts. You are grown up now. So don't believe anyone who says that just study these 10 questions and you can pass. See, engineering mathematics doesn't work like that at all. So if you write just for passing marks, then definitely you are going to fail. There is no magic formula. There is only discipline, practice and dedication. Mathematics requires only three things: practice, perseverance and patience. And also your confidence in mathematics will only improve only when your pen moves. Keep that in mind. Okay. So if you build these three things and practice, then no one can stop you from clearing 21 Math 11. So if you follow my advice sincerely, solve along with me and practice what I give, you will definitely improve your confidence and performance. See, I am not saying each and every question will come from here. Okay, no one can say that. But if you understand this concept properly, you can handle any question in the exam. See, there is still time for the exam, so use the time wisely. With consistent effort, whether you have internals or not, you can easily clear 21 Math 11. So take your pen, your notebook, your question bank, your calculator, your whatever you have, everything and get ready. Don't just watch. Solve with me. The more you practice now, the easier you will feel in the examination. So make this your final disciplined preparation. If you stay committed till the end, I assure you that you will easily clear 21 Math 11 once for all. So let's begin. So friends, now before starting with the main solution video, I have the syllabus with me, that is calculus and differential equations 21 Math 11. I will discuss in brief how easy it is to pass what? 21 Math 11. I am telling you just pass. Okay, I show you how easy it is to pass. So later on we will discuss, but this is I am just showing a briefing about. Okay, but you are not going to do this. You are not going to just pass. You are going to score above 80-90%. Fine. Now here in the syllabus, the first module 1 is polar curves. Polar curves, there are derivations. I will discuss the derivation later. These derivations are very easy. Two derivations. So I have explained in my videos in a very clear way. If you followed it more than enough, you will get full 6 to 7 marks. Say I will get 7 marks here. Okay. And these are compulsory questions. Okay. So they will ask one derivation. Next is problems. See, problems, they ask on angle of intersection. Then they ask on, radius of curvature for Cartesian or polar. Then they ask pedal equation. Pedal equation is compulsory question. See, the beauty of this polar curves is that the problems are similar. Solution, the technique is similar. If you watch the videos, my videos, even if you lack in basics, then you are clearly able to solve this problem easily. But again, it needs efforts and practice. It will not happen in one shot. Believe me. Okay. So 7 marks. Here also you can easily score 6 marks. List. And there's one more thing here. That is okay. Correct. Okay. Here also you can score say 6 marks, 6 to 7 marks. Fine. So 20 marks you can easily. 12 marks is guaranteed. Or at least 10 marks. 12 marks is okay. 12 marks is guaranteed. Derivation you will do perfectly and some problems will solve. Some may here and all you may go wrong. But if you practice perfectly, then you get full 20 marks. Otherwise, say guaranteed questions, derivations, and one problem. So you can select between the choices and get say 12 marks. Next, module 2. Module 2 is a very easy module if practiced correctly. Partial differentiation Jacobians. Here there is one problem, Maclaurin series. See, Maclaurin series, some problems repeated. I will be solving this problems here, the same problems if practice, and if you are able to get it, then 6 marks is nowhere, guaranteed. Okay. Then L'Hopital's rule, indeterminate forms. See, in L'Hopital rule, no, they repeat one question always. That is a raised to x plus b raised to x plus c raised to x. See that if that question comes, then jackpot, you are 100% going to get 6 marks. Otherwise, it is we solve some questions here. You can try it, okay, to get some marks. No issue with that. Okay, but that question comes, don't try to miss it. I don't want you to lose single marks, so I'll train in that. Don't worry. Next one is composite functions. See, composite function, there are 3 questions. This 3 question, it's a pattern series actually. They keep on repeating in every question one by. Okay, we'll discuss the 3 questions here. In that also 6 marks guaranteed. Guaranteed. Okay, then Jacobian also there are some questions. Sometimes they see, many times they give easy questions only, and it's very easy. Just make a determinant, partially differentiate and get the answer. So I in the further videos I'll solve all the 8 questions. If you master this thing, then obviously no one is going to stop you from getting 6 marks. So I'm getting 6 marks, there may be 6 or 7, depends. Okay. Then one question in extreme values. Extreme value, there are 3 questions, very easy, simple differentiation, finding a stationary points and putting a table and getting it, but it's little lengthy. But if you practice it now, you can easily get around 6 to 7 marks here. Okay, so here also totally I'll get say if you say here and there the marks goes, I'll take say 12 marks. Okay, the next one is OD. Module 3 is OD, ordinary differential equations. Here 100% jackpot question, or it may repeat it, you cannot not think of missing it. That is Newton's law of cooling. 7 marks guaranteed. 7 marks. Okay, but you need to use the calculator and calculation properly here. Then we have one more question, Clairates. See, there one question they give, 2 questions are there. That is by substitution method using Clairates form. That question also has a very high probability of repeating. So it's sorted, don't worry. There also you can score 6 marks. Okay. Then we have some questions on soluble for P. That also they ask easy questions, you can score 6 marks. And one more is they ask question on OT, orthogonal trajectory. Here you can score 6 to 7 marks easily. So there is differentiation, a lot of things here. Some people find easy. This is very easy module, okay. But some people, they have the mindset that's difficult. But it's very easy. I'll show you in the problems. Here also you can score, say 10 marks I'll catch. Say 10 marks, okay. So we have 12 to 24 and 34. Fine. That means even, see, there are many people who have less internals, or some people who don't have internals at all. So don't worry, even if you have internal, don't have, you can easily clear this paper, but follow the things I say. Okay. And also many people ask me, sir, I wrote those things but I did not get any step marks. See, there are step marks. The examiner will have the answer key with them. If the key matches to the solution what you did, then only they'll give marks. Only the first step, if you do mistake, then you will get 0 marks obviously. That you should avoid. I'll show you structured way how to do that. Okay, that's the main thing. Then module 4. See, module 4 is very important. In module 4, I cannot, suggest you this question is going to come or that question is going to come, because differential equation higher order is a very, very vast subject. I can myself standing here, I can easily frame 100 to 200 question like that only. But each and every question, the concept remains the same. Okay, you will get it if you follow my videos. I explain this concept of type 1, type 2, type 3 in a very, very easy way, that is, even if you don't know the basics, you will clearly understand it, I guarantee you. So please refer the videos. Okay, you will get it, no problem. Okay, then in this type 1, type 2, type 3, type 1, type 2, type 3 is around 6 to 7 marks. So many students, they enjoy doing it. It depends how you do it, but you should do it correctly. Okay, next one is variation of parameters. This requires integration, so only if you know integration you can do it. And one is legendary scotches. Okay, this is 6 marks. So here also you can easily score 10 marks. I'm telling you, if you practice hard, if you are very weak in maths, or if you have fair in maths, and if you follow this video and you practice very hard, then I'm telling you these marks. Okay, just passing. Then last is module 5. See, module 5, I should not tell you, this is a student's favorite module. Everyone wants to write it first, but my advice, don't write linear algebra first. I don't want to give an explanations. Start from first, second module, then you can write the module 5, third, like that. Okay, so module 5 is totally scoring. Here, no, you can easily score 20 marks here. Easily, blindly you can score, because very, very easy. Even a child can do it. But here also, seen in the exam papers, students do mistake. They won't get 20 marks here. They'll only get 5 or 10 marks here. Why? Because first they don't know how to use the calculator. Second, they use a wrong calculator, and they do mistakes in numerical calculation, because they don't know exactly how to find a rank. Okay, so that's what I'm going to teach you today, how to do it. So I'll be focusing mostly on this module for it to pass. So let it score full 20 marks. So here say 10. If you score 15 marks also, then easily 24, 34, 44, and say easily I get 15 and 16 marks. So leave it. Okay, you can catch some less marks also here. So you can easily score 40, 50 marks and pass the 21 Math M1 paper. So it's very easy to pass. But I don't want to focus on any passing package. I am going to do the strict, strategic revision here, video here, to make you 100% ready to get more than 80-90% marks. If you are going to write only for passing marks, you are going to fail. Again, I am telling you, if you write for 80 marks, 90 marks, something, just go fill up the paper, that's all. Then you are going to get somehow 50 marks or 60-70 marks, that's it. Okay, so let's start the structured preparation now for 21 Math M1 in the detailed way. Okay. And one more thing I want to tell you. See, in my 20 plus years of experience teaching engineering mathematics to engineering colleges and other colleges, I have been students leaving engineering just because of these papers, mathematics, M1, M2, so on. This is not because they were not intelligent, but these people, they gave up on M1, M2. Please don't make that mistake. One subject cannot decide your career, but your discipline can. Okay, so have a discipline, have practice, have persistence, have patience, and definitely you will clear this subject. Okay, so now let's start with the main part. So let's start this and finish M1 once for all. And I hope you are ready with your pen and paper to start practicing along with me. So I have made a complete list of all the questions which will be asked in examination. If you practice these questions, it's more than enough to pass M1. And also I will be discussing each and everything here in detail. So please pay close attention. The module 1. From module 1, see, there are two derivations where they frequently repeat in the examination for 6 to 7 marks. Remember, this is a high scoring area. Don't miss any marks here. One derivation is derive tan phi is equal to r d theta by dr, and other one is prove that 1 by p square is equal to 1 by r square plus 1 by r is to 4 dr by d theta, the whole square. Both derivations are very important, as they have been discussed many times in the question papers, and this time also definitely one problem will be there. It means your 6 marks is guaranteed. Okay, so please don't miss that. See this, both the derivation, one is for angle between radius sector and tangent, other is the perpendicular distance between the pole and tangent, that is the equation, pedal equation. I have already derived in the most simplest way, so please do refer those videos and write as it is. I have given an explanation in the most simplest form as possible, so please go through the video, take a pen, paper, whatever, write a derivation, watch the video, write a derivation yourself, practice 2-3 times. If you don't see, even though I am telling you it carries 6 to 7 marks and you will definitely get the marks, but still I have seen in the answer sheets that the students will get only 3 to 3 marks or 2-3 marks. Like why? Because first the diagram should be correct, it should be legible, it should be neat, all the values of r, theta, phi, the curve, everything should be neat. If not neat, they will cut 1 to 2 marks. Okay, write each and everything as I given here, and I assure you 100% you get full marks. That's it. I don't want anything to say. It's up to you now. The next thing is find the angle between the curves. See this question. Find the angle between the curves r is equal to a log theta and r is equal to a by log theta. Very important question, and they can ask this time. Okay, so this also I solved. So please practice it. And one more time, please lend your ears. In this module, the formulas are, one is, please listen to me, cot phi is equal to 1 by r dr by d theta. Sin theta is 2 sin theta by 2 into cos theta by 2. 1 plus cos theta is 2 cos theta by 2. 1 minus cos theta is 2 sin theta by 2. And cos plus sin by cos minus sin is tan cot pi over 4 plus theta. And also, both the cot and the tan should be, the left side is always cot phi, right side should be in terms of cot only. If left is cot phi, right is, in terms of tan theta, then how do you write tan in terms of cot? Cot pi by 2 minus theta. And if the left side is cot phi and if the right side is minus tan theta, how do you write minus tan in terms of cot? Cot pi by 2 plus theta. These things you need to remember. And also the pedal equation was p is equal to r sin phi. There are two formulas. One is p is equal to r sin phi. Phi is the angle which you find, that is angle between the radius and tangent vector. The other formula is 1 by p square is equal to 1 by r square into bracket 1 plus cot square phi. Use that formula. Okay. So all the formulas and the problems and the derivations are given in the videos which I am going to discuss now. So please do refer them. Okay. They are the gateway to your success. That's it. Fine. So find angle between the curves r is equal to a log theta and r is equal to a by log theta. I already discussed it. Please refer the video and practice this, because this is the very important question which they frequently ask in examinations. Next, one more. I predict this question they may ask this time. The question is, show that the curves r is to n is equal to a is to n cosine theta and r is to n is equal to b is to n sin theta intersect orthogonally. Very important problem. One more. This problem also I discussed. Please check the video here and solve it. Okay. The next is find the angle between r is equal to sin theta plus cos theta and r is equal to 2 sin theta. One more important question. So I am giving these questions now. I am not giving the whole textbook. I am giving these questions. So there are hardly few questions are there. So if you practice this, it will help you. So please do that. Find the angle between r is equal to sin theta plus cos theta and r is equal to 2 sin theta. This question also important. They ask this time. Okay. And one more question. See, if the paper goes to be very easy, and I expect the paper will be easy this time. So find the angle between the curves r is equal to a into 1 plus sin theta and r is equal to a into 1 minus sin theta. This question also is solved here. So please do refer that. And one more problem. Find the angle between the curves r is equal to a into 1 plus cos theta and r is equal to a into 1 minus cos theta. This is also very important. This question, no? Find the angle between the curves r is equal to a into 1 plus cos theta and r is equal to a into 1 minus cos theta is very easy. Apply log on both sides, differentiate, cot phi is equal to, then use the formulas which I discussed just now, and you get phi 1, phi 2, subtract it, you get the angles. But this problem, find the angle between the curves r is equal to a into 1 plus sin theta and r is equal to a into 1 minus sin theta is a little tricky. So I need you to practice that from the solution which I given here. Okay. The next is very important part, the pedal equation. Find the pedal equation for the curve r square is equal to a square secant 2 theta. Important problem. This also I solved it. Please do refer that. Next is find the pedal equation for r raised to m is equal to a raised to m cos m theta plus sin m theta. Again, please do refer the solution for it. It's very, very important. And this pedal equation is a scoring area, but you need to practice it. I know many of you fail here because you lack in basics. So one thing I guarantee you, if you refer the videos which are solved here, you will not face that difficulty at all. I guarantee you, assure you that. So please do watch the videos and rectify your basics. Find the pedal equation for the curve r is equal to m is equal to a raised to m cos m theta plus sin m. Very important. Okay. Next, there is one more problem. Find the pedal equation for r is equal to a into 1 plus cos theta. I have not solved it. Let me solve for you now. See, find the pedal equation for So before that, I'll do one thing. I'll solve a question on find the angle, show that the curves r raised to n is equal to a raised to n cos n theta and r raised to n is equal to b raised to n sin n theta intersect orthogonally, because I had doubt on this question that they may ask this question. The problem is, I write here, show that r raised to n is equal to a raised to n. Obviously, I solved this question, but I want you to again watch how to find angle of intersection, because after derivation of the polar curve, one problem 100% will be from angle of intersection between two curves. Okay. See, and many people they ask me, I have written but I did not get the step marks. See, step marks will be 100% there, but the step should be correct. If your first step is wrong, then who is going to give marks? Please understand that. It's not the fault of the evaluator, it's your fault, because you don't know the basis properly. Now see this question. Show that r raised to n is equal to a raised to n cos n theta and r raised to n is equal to b raised to n sin n theta intersect orthogonally. So how do you solve this first? We have r raised to n is equal to a raised to n cos n theta, right? So in any polar curve solution, we first apply log on both sides. Okay, so we have log of r raised to n is equal to log a raised to n into cos n theta. This is the way of writing it. Apply log on both sides, bracket. Now see, log r raised to n is equal to, see, log a into b. The three relations in logarithm are log a into b is log a plus log b, log a by b is log a minus log b, and log a raised to k is k log a. Okay. Now here, log c, this will be a raised to n into cos n, a into b. So to apply the logarithm principles correctly, log a into b is log of a raised to n plus log of cos n theta, right? Now again, log r raised to n, the very important property of logarithm, the power of logarithm which we call is log r raised to n is n log r, log r raised to k is k log r, log a raised to k is k log a, raised to power comes down. So we have log r raised to n is n log r is equal to n log a plus log of cos n theta. If you write like this, no one is going to cut marks, they are going to give just step marks. Okay. Next, we have here now differentiate. So n into differentiate with respect to theta. So n differentiation log r will be always in any problem you see 1 by r dr by d theta. And this is 0. Why? Because see, a, b, c, d, m, n, o, p, everything is 0 only. Log a is a constant 0. N as it is, log a is 0. Plus again, log chain rule, differentiation of log of x is 1 by x. Correct. So 1 by cos n theta, but instead of x it is cos n theta. Again differentiate, it's called chain rule. Again cos n theta is minus sin n theta, because differentiation of only sin x is cos x is only minus sin x. Apart from that, again you need to differentiate, it's called a chain. Log of x is 1 by x, cos n theta is 1 by cos n theta. Again, it's not plain x in place of x or theta, it's cos n theta. Again, differential cos n theta is cos is minus sin x, minus cos, but it's not plain theta. Again, n theta is there. Again, differential n theta is into n. So n cancels here. So we have cot of phi is equal to minus sin by cos is tan of n theta. correct? Tan of n theta. Fine. Now we can write this as cot of phi is equal to what is, as I told you, left side is always cot. If the right side is minus tan, how to make it cot? Cot of pi by 2 plus theta is minus tan theta. This is simple rules of trigonometry. So now this will be cot of pi by 2 plus, in place of theta is n theta, so n theta. So cot cancel, so I get phi is equal to pi by 2 plus n theta. I will take this as say phi 1, the first angle, okay, because I will need to find the angle of intersection here. The second angle similarly is r is Tn is equal to b is Tn sin n theta. So we have n log r, I will do directly, is equal to, okay, I will apply log on both sides first. So log of r is Tn is equal to log of b is Tn into sin n theta. So now I will do it like this, n log r is equal to n log b plus log of sin n theta, right? Now differentiate n into 1 by r, dr by d theta is equal to 0 plus 1 by sin n theta. Log of sin n theta is differential log is 1 by x, 1 by sin n theta. Again differential sin is cos n theta. Again differential n theta is into n, so n cancels here. So we have cot of phi is equal to cos by sin is cot of n theta. Cot cancels. We have phi 2 is equal to n theta. That's it. So as you find both phi and phi 2, angle of intersection is given as phi 1 minus phi 2, that is equal to pi by 2 plus n theta minus modulus, because angle is always positive, cancels, so pi by 2, that is equal to 90 degrees, and in mathematics 90 degrees means orthogonal. That's it. Understood? So like this way you can solve other problems. So each and every solution is given. Please do refer that. Okay. The next one is okay, wherever, okay, Patel equation also you can do the derivation same, the solution. Find the Patel equation for r is to m is equal to a is to m cos m theta plus sin, that is done. I think next is okay, find the Patel equation for r is to n is equal to a is to n cos n theta. Very important problem. This I think they may ask in the examination because it's repeated. Find the Patel equation for r is to n is equal to a is to n cos n theta. I have solved it. Please do refer that. The next is radius of curvature. See here, in radius of curvature, this given problem, find the radius of curvature of the volume of Descartes x cube plus y cube is equal to 3axy at the point 3a by 2 comma 3a by 2. It's a repeated question. I don't know how many times it has been repeated. So this is also an area of scoring. So please solve this 2 to 3 times. This is a high probability question. Okay. And I have solved this problem in a very simple way. Please do refer the video, practice it so that you don't miss any marks here. Again, find the radius of curvature for r is to n is equal to a is to n sin n theta. Again, very important problem. Both r is to n cos n theta and r is to n sin n theta is solid. So please do refer the videos. And also the links are given in description below. You can refer the link and practice them. Everything I will give you ready-made. Don't worry about it. And also at 7 days before the examination, I will be posting a set of 2 model question papers which have to solve it. And if possible, you can email me the solutions. I will check it myself. Okay. So that will guarantee that those model papers, if you solve, will guarantee that you will 100% clear mathematics. It's my guarantee. I will not post that. I will post 7 days before the examination or 1 week before the examination on my YouTube channel or Facebook or Instagram pages. So please stay updated. Okay. And please follow them. Next is show that for the curve r is equal to a into 1 plus cos theta, rho is constant. Rho is again the radius of curvature. Okay. So this is, I haven't solved. Let's solve this question. Okay. So now the problem on radius of curvature. Rho is radius of curvature. P is Patel equation. So Patel equation we discussed here. Radius of curvature. The problem is show that for r is equal to a into 1 plus cos theta, rho is constant. Rho is constant. Here see, rho is called as radius of curvature. Fine. So let's solve this now. So first, the way to solve here is we find the pedal equation. Because there is a formula here, I will write a formula. The formula to find a radius of curvature for a polar curve. See, this curve is polar, right? Why? Because there is a radius and angle theta. So for that, rho is r dr by dp. So here P is the pedal equation. So we'll use this relation, simple relation, to solve this problem. Fine. Now, first r is equal to a into 1 plus cos theta. Apply log on both sides. So we have log r is equal to log of a plus log of 1 plus cos theta. Now apply differentiate both sides. We have 1 by r dr by theta is equal to 0 plus 1 plus cos theta. Again differentiation of 1 is 0, cos theta is minus sin theta. So we have cot of phi is equal to, I discussed the formulas. The formula for sin theta is nothing but 2 sin theta by 2 into cos theta by 2 upon 1 plus cos theta will be 2 cos square theta by 2. Cos and cos 2 cancels. We have minus sin by cos is minus tan theta by 2. Please verify it. Hope you are solving with me. Okay, it's correct. See, cos cancels, sin by tan. Now how do I write minus tan in terms of cot? We write it as, so that implies cot of phi is equal to cot of pi by 2 plus theta by 2. Correct. So cot cancel. So the angle between the radius and tangent vector is pi by 2 plus theta by 2. Okay, this is main. This step you will get the marks. Now for this we need to find a pedal equation. Once you know the pedal equation, we can differentiate and get the answer for ROC, radius of curvature. So we have here P is equal to r sin phi, that is the pedal, where P is the pedal. So P is equal to r into sin pi by 2 plus theta by 2. That is, what is sin 90 plus theta? It's cos theta. Sin of pi by 2 plus theta is cos theta. So it will be r cos theta by 2. Now pedal equation is always a constant. It's always what? Constant. We don't need this theta by 2, cos theta by 2. We don't need this. So where to get the value of this? From the question. So we have r is equal to a into 1 plus cos theta. As you know, 1 plus cos theta is 2 cos square theta by 2. Correct. So we have cos square theta by 2 is equal to r by 2a. So cos theta by 2 will be root of r by 2a. See, I got the value for what? Cos theta by 2. Now why do this? Tell me. Because pedal equation is always a constant. I don't need this cos theta by 2. So for that I use the question given. What's the question? R is equal to a into 1 plus cos theta, where from the basic formulas of trigonometry, which are very much required for polar curves, you can just see the videos which I discussed there. I discussed each and everything. Please go through that. So now here r is equal to a into 1 plus cos theta. R is a into what is 1 plus cos 2 cos theta by 2. From here we need to find the value of cos theta by 2. So cos square theta by 2 is equal to r by 2a. So cos theta by 2 is root of r by 2a. So the pedal equation P is equal to r into root of r by 2a. That is 1 by root 2a. Okay, into r into root r. See, r into root r. R is to 1 by 2 will be r is to 3 by 2. Fine. Am I right? R into root r, right? R into r is to 1 by 2 plus 3 by 2. Yeah, perfect. So I have the pedal equation here. So we have P is equal to 1 by root 2a constant, r is to 3 by 2. That implies what I'll do here, see, rho is equal to r dr by dp. I need what? Dr by dp. I have P. So simply what I'll do, I'll first find dp by dr. Ulta and put it here. I get rho. That's it. As simple as that. So dp by dr will be 1 by root of 2a as it is. Differentiation of r is to 3 by 2 is 3 by 2 r is to 3 by 2 minus 1. That will be 3 by, this will be nothing but 3 by 2 root 2a into C. Am I right? 3 by 2 minus 1 root 2a into 3 by 2 minus 1, 3 by LCM is 2, 2 minus 1, 2, 3 minus 2 is 1, r is to 1 by 2, that is root r, correct. So p is equal to, we have 3 whole divided by 2 root 2a into root of r, sorry, dp by dr is equal to dp by dr. Therefore that implies the radius of curvature rho is equal to r into dr by dp, ulta, dp by dr is 3 by 2 root 2a into numerator root r. So dr by dp will be inverted, we will get into 2 root 2a by 3, correct, and root r. Am I right? That means here r by root r is again root r only, correct. So this will be again root r, because see r I will first write it here, therefore we can write nothing but 2 root 2a by 3 and see 2 root 2a by 3 r by root r. So r by r is to 1 by 2. So r is to 1 minus 1 by 2. So r is to 1 by 2. So it is root r. Therefore we can write rho is equal to constant into root r. That's it. This is how we solve it. So the radius of curvature here is a constant. Okay. See, so that is, I think this problem, oh sorry, it's a show that for the curve r is equal to a into, okay, so rho square by r is constant, sorry, it is rho square by r is constant, I show it's constant, right? Okay, fine. Now therefore we have rho square, therefore I have rho is equal to this much, that implies rho is equal to 2 root 2a by 3 root r. That implies rho square, square it, when I square it, so sorry I wrote the problem wrong here. The problem actually is show that for r is equal to a into 1 plus cos theta, rho square by r is constant. So I found rho has to be 2 root 2a by 3 root r. So if I square it, I get 4, see 2 square is 4, 4 to the 8, 8a by 9 into r. That means take r down, that implies rho square by r is equal to 8a by 9, that is equal to constant. That's the solution. Interesting problem. They may repeat this question. So please practice this question and go. Okay. Apart from this, the other questions which I discussed, those also. That is, which are they? Yeah. Next is, show that the radius of curvature of r is to n is equal to a is to n cosine theta, where is inversely as r is to n minus 1. This also problem I will solve and show it now. Okay. So this problem I haven't solved. So let's solve this now. Show that radius of curvature of r is to n is equal to a is to n cosine theta varies inversely as r is to n minus 1. So I solved different questions like this. So please do refer the videos on my playlist. Everything is important in mathematics. Okay. But what I am doing now are very much important. Okay, because this video is designed so that everything I have planned perfectly, so that by practicing this total video and the problem given, as I told you, each and every solution is given in description below. Also the whole PDF for this questions I am doing will also be given. So please check the description and my Facebook page and my Instagram page, okay, for further updates. So inversely as r is to n minus 1. So here the same process what we did in the previous problem. So we have r is to n is equal to a is to n cosine theta. Apply log on both sides. We have n log r, I am writing directly here, is equal to n log a plus, I have already discussed for this the phi in the previous question, that is show that the curves r is to n is equal to a is to n cosine theta and r is to n is equal to a is to n sin theta intersect orthogonally. The same process we do here. So n log r is equal to n log a plus log of cos of n theta, n into 1 by r dr by d theta is equal to 0 plus 1 by cos of n theta into minus sin n theta into n cancels. So we have cot of phi equals minus tan of n theta. I write it here itself. So we can write minus tan as cot of pi by 2 plus n theta. So we have phi is equal to pi by 2 plus n theta, and next after this please underline, we need to find the as you know the simple formula to find the radius of curvature for a polar curve. As this is a polar curve, r and theta is rho is equal to r dr by dp. So we need to first find Patel equation. So p is equal to r sin phi r into sine of pi by 2 plus n theta, that is equal to r cos n theta. And I think this problem is very simple. Okay, see, there is one more problem I discussed, that is I think it's find the Patel equation for r is 10 is equal to a is 10 cos n theta. That same question occurs here. See that? Okay. Now p is equal to r sin phi r cos n theta. Now what I told, Patel equation is always a constant. So where to find the value of cos n theta? See, from the problem itself, from the question itself, r is 10 is equal to a is 10 cos n theta. From here we can write cos of n theta is equal to what? R is to n by a is to n. As simple as that. Simple mathematics. Okay, r is to n, and that value which you found here, we have to put it here and get a solution. So therefore p is equal to r into what is cos n theta from here from problem, because Patel equation is always a constant, it cannot, there need not be any theta involved here. So is equal to r into what is cos n theta? R is to n by a is to n. That implies the Patel equation is p is equal to r is to n plus 1 by a. That's it. Sorry, a is to n. Okay. Now the formula for the radius of curvature rho, ROC, rho is equal to r dr by dp. That implies dp by dr is equal to 1 by a is to n, as it is. Differentiation of r is to n plus 1 is n plus 1 into r is to n plus 1 minus 1 n only. Okay. Therefore rho is equal to r into dr by dp, ulta. So a is to n by n plus 1 into r is to n, that is a is to n by n plus 1 constant as it is, and this will be 1 by r is to n minus 1. That means this is constant into 1 by r is to n minus 1. So what they are asking, show that the radius of curvature of r is to n is equal to a is to n cos theta varies inversely as r is to n minus 1. See, 1 upon r is to n minus 1, very inversely. Therefore rho varies inversely as r is to n minus 1. That's the solution. I hope you got it clear. Okay, fine. The next one is one more problem. See, sometimes no, they discuss this problem, that is find a radius of curvature of the volume of Descartes x cube plus y cube is equal to 3xy at point 3a by 2 3a by 2 on it. I already discussed this question, the solution is there. But apart from this, there is one more question they have asked twice or thrice in the papers, that is show that the radius of curvature for the curve y square is equal to a square into a minus x by x at the point a minus, or find the radius of curvature for the curve y square is equal to a square into a minus x by x at the point a comma 0. So this I haven't solved, I will solve it for you. Fine. Find radius of curvature for y square is equal to a square into a minus x whole divided by x at a comma 0. They gain a point. So let's for see, for a polar curve we discussed was different. For a Cartesian curve, the radius of curvature is always rho is equal to 1 plus dy by dx the whole square raised to 3 by 2 upon d square y by dx square. This is formula. That means we need to find dy by dx, again differentiate, find d square by dx square, put here in this formula and get the solution. Let's see what happens here. So write it here, y square is equal to a cube by x minus a square. I think this will be easy for differentiation, correct? I open the bracket here, a cube by x minus a square. Now differentiate, so 2y dy by dx equals a cube as it is, differentiate 1 by x is minus 1 by x square, and a is 0. So that implies we have dy by dx will be nothing but, this will be how much? Minus a cube by 2 x square y. Am I right? correct? So dy by dx will be minus a cube by 2x square y. Therefore, dy by dx at the point a comma 0, at the point a comma 0 means whenever you give some points, order pairs, x is a and y is 0. Simple, that's it. In place of x put a and y put what? 0. So that will be how much? We put a cube by, see, in place of y put 0. Anything by 0 is what? Infinity. Infinity. That's the problem here. Now, if this is infinity, okay, if this is infinity, then what to do? If dy by dx is infinity, right here, if dy by dx at say x comma y is equal to infinity, then we use one more formula to find the radius of curvature, that is rho is equal to 1 plus, just ulta it, infinity, 1 by infinity 0. That's why d square x by dy square, sorry, dx by dy the whole square, whole raised to 3 by 2 upon d square x by dy square. Use this relation. So from here that implies we have dx by dy will be, see, dy by dx is minus a cube by 2x square y. So this will be minus 2x square y by a cube. It implies dx by dy at the point a comma 0 will be. Now here, as I told you, anything into 2 into 0 is 0, 0 by 0, anything is 0 only. Okay. Again, that implies d square x by dy square. That means you differentiate one more time. But here be careful, you are differentiating here with respect to y. Minus 2 by a cube as it is into constant. See, you are differentiating with respect to y. So x square y will become product tool. Be careful, x square as it is. Differentiation of y with respect to y is 1 plus y as it is into again differentiation x square with respect to y is 2x into dx by dy. But dx by dy, you know, it's nothing but 0. This 0, whole thing cancels. Therefore, d square x by dy square at the point a comma 0 is equal to minus 2 by a cube into, as you know, this whole thing is 0. Okay, x square means it is, x means in place of only x get put a, so a square into a square, that is minus 2 by a. Therefore, rho is equal to 1 plus 0 raised to 3 by 2 upon, sorry, upon minus 2 by a, that is 1 upon, this will be minus a by 2. Therefore, rho is equal to a by 2, because radius of curvature is always positive. Therefore, you can write radius of curvature for the curve rho is equal to a by 2. That's the final solution. That's it. Please practice it. So even if it doesn't, also means you will know how to solve the problems. That's very important. So steps carries marks. So don't lose, whatever you do, I want you to solve the entire paper and come. So don't lose any marks. Okay, fine. That's so, please, and practice is very important. Understand the pattern, don't memorize anything, please do practice. Hard work is very much important, because you are at this critical juncture that you need to, it's like do or die. Okay, and you have such valuable resource in front of you. I am, you know, in spite I am having some critical illness, I am going through cancer treatment, obviously I am having pain, but see, I was receiving a lot of calls, dozens of calls daily from parents and students of people who have not cleared their engineering mathematics of the 18 scheme for physical classes and online classes. So it's difficult for me to take offline classes, but what the least I can do is I can make such a video which will help you to pass. That's what I can do. So please, I am doing my work, you have to do it work. That means you need to practice, practice and practice more. That's it. Okay. So now we are done with this. Now let's move on to the next problem. And apart from that, there are some other very, very important problems for the 21MAT11 scheme. See, the question paper pattern of the 18MAT11 and 21MAT11 are a little different. So some of the problems I am going to solve from the polar curves to make it more perfect. The first one is, show that 2a by r is equal to 1 plus cos theta and 2a by r and is equal to 1 minus cos theta intersect orthogonally. Intersect orthogonally. Okay, this question is not discussed in textbook. Let's solve it. So first, we have seen in previous problems also, the first thing what you do in polar curves, you apply log on both sides. Okay, so we apply log here. So we have first one, 2a by r is equal to 1 plus. So please practice along with me. Take a pen and practice. Apply log on both sides. Log 2a by r is equal to log of 1 plus cos theta, step by step. Fine. Then log of a by b is log of a minus log b is equal to log of 1 plus cos theta. Again, everything should be plain on the ground. Then only you can differentiate. No multiplication power is allowed in mathematics. Now you can differentiate with respect to theta. Differential log is 0 minus log r is always in polar curves. With respect to theta is 1 by r. dr by d theta equals to 1 plus cos theta, because see, log of x is 1 by x. Again, listen carefully. Log of 1 plus cos theta is 1 by 1 plus, again 1 plus cos theta, again differential of 1 plus cos theta, chain rule. 1 is 0, cos theta is minus sin theta. Minus minus cancel. So this will be now cot of phi is equal to, so what's the formula? See, you can refer the videos. Sin theta is nothing but 2 sin theta by 2 into cos of theta by 2 upon 1 plus cos theta is 2 cos square theta by 2. Once again, lend your ears to me, it is very helpful during examination. The formula for sin theta is 2 sin theta by 2 into cos theta by 2. 1 plus cos theta is 2 cos square theta by 2 plus means cos square, and 1 minus cos theta is 2 sin square theta by 2. Keep in mind. So we have this much. So here 2 cancels, cos cancels. We have cot of phi is equal to tan theta by 2. So how do we write tan in terms of cot? In trigonometry, cot of 90 minus theta, so pi by 2 minus theta by 2. Cot cancels, so I take this as phi 1 is equal to minus theta by 2. Similarly, let's solve for this. In the second one, step by step. So 2a by r is equal to 1 minus cos theta. Apply log both sides. Log 2a minus log of r is equal to log of 1 minus cos theta. That is, differentiate now, minus 1 by r dr by d theta is equal to, again see, log of x, differential log x is 1 by x, log of 1 minus cos theta is 1 by 1 minus cos theta. Again 1 is 0. Differentiation of cos theta is minus sin, so minus and minus become plus. So we have minus cot of phi is equal to, again what is sin theta? 2 sin theta by 2 into cos of theta by 2 upon 1 minus cos theta is 2 sin square theta by 2. 2 cancel, sin cancel, cos cot. So cot of phi 2 is equal to minus cot theta by 2. That is, phi 2 is equal to, take it as minus theta by 2. Therefore, see, angle of intersection is given as, write it, write everything step by step, because your aim is to get the, see, if this question is for 6 marks, you need to 100% get the 6 marks. Okay, so that is intersection phi is equal to phi 1 minus phi 2. So write it, angle of intersection is equal to modulus of phi 1 minus phi 2. Why? Because angle is always positive, so it is pi by 2 minus theta by 2, minus or minus plus theta by 2 cancels, it is pi by 2. Pi by 2 means 90 degrees. 90 degrees what? Orthogonal. That's it, finished. Next also very easy question. Find the angle between, this question has been also asked in examination, between r is equal to a theta and r is equal to a by theta. See, this question also let's solve now. Okay, a theta is and r is equal to a by theta. Fine. So r is equal to a theta and r is equal to a by theta. See, same process. What to do? We apply log on both sides. So first we have this as r is equal to a theta. So better you solve with me. Okay, I hope you're doing it. Just don't simply watch the video, solve with me, because when you're solving it, giving some time for this, then obviously the things are going to retain here. Okay, and this is correct time, very less time for exam is left. So if you solve in this period, your memory is fresh now, you'll be retaining it for the exam. Now what to do? First apply log on both sides. So we have log of r is equal to log of a into theta. That is log of r is equal to log of a plus log of theta. 1 by r dr by d theta is equal to 0 plus 1 by theta. So cot of phi will be 1 by theta. Am I right? Correct, no? Cot phi is equal to log is 0. Perfect. Then we have again log of r is equal to log of a by theta. That is log r is equal to log of a by b is log a minus log b. It means when I differentiate it directly now, it is 1 by r dr by d theta is equal to minus 1 by theta. So this is cot phi 1, I will take this as what? Cot phi 2 theta. Okay. So in this case, we need to find an angle. So I cannot leave it as it is. See, let us find a value of theta. From where? From the question. So from the question we have r is equal to a theta and r is equal to a by theta. Implies a theta is equal to a by theta. A cancels. Theta square is equal to 1. So theta is equal to 1. I think it's plus or minus 1. So I take it 1 only. Plus. Okay. So when theta is equal to 1, so what is cot phi 1? 1. What is cot phi 2? Minus 1. So obviously see, tan 45 is 1. Cot 45 also 1. So we have cot phi 1 is equal to cot inverse 1. So 45, that is pi by 4. And similarly phi 2 is equal to minus pi by 4. So angle is modulus of phi 1 minus phi 2 is equal to pi by 4 minus plus pi by 4. 2 pi by 4, it is pi by 2, that is equal to 90 degrees. Again in polar curves, 90 degrees means what? Orthogonal. That's it. Okay. Radius of curvature, I write ROC of curvature for r square secant 2 theta is equal to a square is a square over 3r. So let's solve this problem here. This problem has been asked twice in the 21MAT11 paper. So please do it and go. So apart from the previous problem which is solved, this question also, okay. Because I don't want to take any risk here, I want to give a complete solution here. Fine. Now, how we find the radius of curvature? This is a polar curve. So first what we do is, see the radius of, I write a formula here. In polar form, the radius of curvature is given by, I write here, radius of curvature is given as rho is equal to r dr by dp. Here this p is what? Pedal equation. Okay. So first what I'll do the same circus, that is for polar curves we apply log on both sides, differentiate, same thing I'll do. So first what? We have r square secant 2 theta is equal to a square. Simplest way of solving it, apply log on both sides. Log of r square into secant 2 theta is equal to log of a square. It implies log a into b is log a plus log b. So log of r square plus log of secant 2 theta is equal to log of a square. 2 log r, because when you apply log on both sides and we are differentiating, everything should be plain. No power, no multiplication is allowed in mathematics. For that reason, apply log. This is okay as it is. Log of secant theta is equal to 2 log. Now let's happily differentiate it. 2 into log r is 1 by r. We are differentiating with respect to theta here. So always the derivative of log r is 1 by r dr by d theta, that is cot phi. So plus again secant, log secant is 1 by secant theta. Again derivative secant theta is chain rule. Secant theta into tan theta is equal to 0. Secant cancels, and we have sorry, my bad. It is secant 2 theta, right? Yeah, secant 2 theta. Sorry. So this will be now derivative of secant 2 theta will be 1 by secant 2 theta into again differential of secant 2 theta is secant x into tan is secant 2 theta into tan 2 theta into 2 chain rule. So secant cancels is equal to 0. So 2 also cancels here. So we have cot of phi equals minus tan theta goes that side to become minus tan 2 theta. Now to find the pedal equation, you need to find phi. So we write minus tan in terms of cot as cot of pi by 2 plus 2 theta. See, the angle is 2 theta here, that's why. So cot cancels. The angle phi is equal to, this is the angle between the radius vector and tangent. From this, first we need to find Padel equation, P. So the Padel equation is given by P is equal to R sin phi. That is equal to R sin of phi is direct here, pi by 2 plus 2 theta. So what is sin 90 plus theta is cos theta. So P is equal to R cos 2 theta. Now, Padel equation is constant, as you know. We have solved some problems also previously. We don't need theta here. So where do you find the value of theta? From the question. See carefully. Everything will be hidden here only. From the question we have, see, R square secant 2 theta is equal to A square. Okay. That means secant 2 theta is equal to A square by R square. Am I right? Correct. But I need here cos 2 theta. So cos 2 theta will be ulta. Cos 2 theta will be R square by A square. That's it. As simple as that. So we have this as P is equal to R into R square by A square. So P is equal to R cube by A square. That implies I want rho is equal to R dr by dP. The formula. I have P here. So first what I'll write, I'll find dP by dr. So dP by dr is equal to, differentiate P is equal to R. So it is 1 by A square into 3R square. Correct. Therefore, the radius of curvature will be nothing but rho is equal to R dr by dP. That is R into, see, dP by dr is 3R square by A square. So that means dr by dP be ulta of that. That is A square by 3R square. 3R square. R cancels here. That is how much? A square by 3R. That implies radius of curvature rho is equal to A square by 3R. That's the solution which we have proved here. That's all. Okay. So this is how we do. But again, you need more and more practice. If you get to practice, then you will get hands on it. You can solve any question given in polar curves. I hope you clearly understood this. Now let's move to the next question. It is find the radius of curvature. This is Cartesian curve. Okay. It says find the radius of curvature. Find radius of curvature of x raised to 4 plus y raised to 4 is equal to 2 at a point 1, 1. One more important question. There are two questions like this. One question already solved. You can refer it. So I'll solve this first. Okay, we'll see the later next. We have the formula for radius of curvature rho is equal to, for a Cartesian curve, polar means this formula, rho is equal to 1 plus d square y by 1 plus dy by dx the whole square, whole raised to 3 over 2 upon d square y over dx square. Okay. That means we need to find dy by dx and d square by dx square, put it and get the solution. Let's see. The question is x raised to 4 plus y raised to 4 is equal to 2. So let's differentiate. We have 4x cube plus 4y cube dy by dx equals to 0. That implies dy by dx will be nothing but, if I take it this side, it will become minus x cube by y cube. Am I right? Yeah, 4 cancel, perfect. Therefore, that implies dy by dx at the point 1, 1 means, see, when they give some point means in place of x put this x and y. X put 1, y put 1. Simple. So minus 1. That's all. Now, d square y by dx square means you differentiate this with respect to again x. It will be a quotient rule here, minus outside. So this will be y cube whole square, correct? So it's quotient rule, denominator square, I am differentiating with respect to x again, perfect. So this would be now y cube square, then y cube as it is, differentiation of x cube is into 3x square minus x cube as it is. Again, differentiation of y cube will be 3y square into dy by dx. Correct? This is what I have. Therefore, d square y by dx square at the point 1 comma 1 is equal to minus bracket. So let's put all the values here. So this is 1 square, 1 only. So 3 minus 3 into dy by dx is minus 1, correct? Minus 1. So this will be minus 3 plus 3, 6. This is nothing but minus 6. Am I right? 3 plus 3, 6 minus 6. Therefore, it implies the radius of curvature rho is equal to 1 plus minus 1 the whole square raised to 3 by 2 upon minus 6. That is 1 plus 2 raised to 3 by 2 upon minus 6. So 2 raised to 3 by 2 can be written as 2 into root 2. Am I right? Correct. 2 into 2, correct, 1 plus 2, 3 by 2, and I can write this as 2 into 3, 2 cancels, so we get minus root 2 by 3. But the radius of curvature is always positive, so the radius of curvature we can write it as modulus of rho is equal to nothing but modulus of minus root 2 by 3, that is nothing but root 2 by 3. That's all. That's the solution for this. I hope you clearly understand, because the radius of curvature is always positive. So the solution is root 2 by 3. That's the answer here. That's it. Okay. Okay, I hope it's clear. So next question is find the radius of curvature for root x plus root y is equal to root a at a by 4 comma a by 4. This also problem, very important problem. I already solved it, so please you can check. The link is given in the description below. Also, for all these questions which I am doing now, the PDF format is given in the links. You can please download it or you can use it as a reference. Okay. So moving on to the module 2, we have the scoring parts are Maclaurin series, L'Hopital's rule, the chain rule, Jacobians, okay, and some questions on maxima, minima. Fine. So now the first question is obtain Maclaurin series of log secant x up to x to 4 terms. I predict that this question may be asked in this term examination. The problem I solved already. Please do refer that and practice it. And the link is given in description below. Using Maclaurin series, prove that root 1 plus sin 2x is equal to 1 plus x minus x square by 2. This also is a very high probability question. It was asked last time. Depends. Okay, we cannot say. So please practice this question also. Then obtain Maclaurin series of log 1 plus cos x. This I will solve you and show it to you here. This is a very important question. I see it has been asked, I think previous year or before that on paper. So I don't expect this to be asked, but still I will solve this for you. The next problem is expand log 1 plus e raised to x up to x to 4 terms. That is that. Expand log 1 plus e raised to x up to x to 4 terms. So I will solve this for you. So we have, that is when they give simple expand, it is nothing but Maclaurin series. So expand. This is also a very important question. They may ask 1 plus e raised to x. See, the concepts is same here. Only you need to know some bit of differentiation and put in the values. So I solved this couple of questions for you here. So expand y is equal to log 1 plus e raised to x up to x to 4. So what we do is the Maclaurin series. First, please do write the Maclaurin series to get the 1 marks. Y is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial y2 of 0 plus x cube by 3 factorial y3 of 0 plus x raised to 4 by 4 factorial y4 of 0. That is what they are asking, up to 4 terms. So we need to find only y of 0, y1 0, y2 0, y3 0, y4 0, put it here and get the solution. That is it. Okay. Now let us solve this. We have y is equal to log of 1 plus e raised to x. So y of 0 will be equal to log of 1 plus e raised to 0 is 1. It is log 2. Please do underline. Okay. The second part is y1 is equal to. 1 by, see, differentiation of log x is 1 by x. So log 1 plus e raised to x is 1 by 1 plus e raised to x into again derivative of e raised to x is e raised to x chain rule. Okay. So we have y1 of 0 is equal to 1 by 1 plus 0, 2. Yeah, 1 by 2. Fine. E raised to 0 is 1 and e raised to 1, so 1 plus 2. Fine. In place x put the value 0. Next we need to differentiate. So we can differentiate directly here using the quotient tool, but best is to use product tool, because using product tool is more easier than quotient tool in this series. Okay, expansions. So I'll take this side, 1 plus e raised to x into y1 is equal to e raised to x or minus e raised to x is equal to 0. I hope you got it clear. I took it this side and took it this side. So minus the equation. Now let's differentiate this. So it will be product tool now. 1 plus e raised to x into y1. So what does it say? 1 plus e raised to x as it is. Differential y1 is what? y2, y1, y2, y2, y3, so on. Plus y1 as it is, because the product tool is differentiation of or derivative of first into second function is keep first function as it is, differentiate second function plus keep the second function as it is into derivative of the first function. So we have first as it is derivative of y1 is y2, y1 as it is into e raised to x minus e raised to x is equal to 0. Now put the value of x is 0. So 1 plus e raised to 1, so 2y2 of 0 plus y1 is, as you know, 1 by 2 into 1 minus 1 is equal to 0. Fine. That implies we have 2y2 of 0 is equal to, see, I think 1 by 2, right? Yeah, 1 by 2, because 1 by 2 minus 1 is minus 1 by 2 that side. That implies y2 of 0 will be 1 by 4. That's it. I hope I am correct. Please verify it, your answers. 2 minus it will be 1 minus 1 by 2. 1 by, yeah, perfect. Next again differentiate it. So till the fourth term, again 1 plus e raised to x as it is, differentiation of y2 is y3 plus y2 as it is, again derivative of 1 plus e raised to x is e raised to x only, again product tool for this function, y1 into e raised to x as it is plus e raised to x as it is into derivative of y1 is y2 minus e raised to x is equal to 0. Okay, correct. Now this product tool for this and this two, couple 1 plus e raised to x as it is, derivative y2 y3 plus y2 as it is into differential 1 is 0, e raised to x plus y1 as it is, e raised to x only, and plus e raised to x as it is into differential y2 minus e raised to x as it is. Now I think they add together. Okay, so we have 1 plus e raised to x into y3 plus e raised to x 2 e raised to x y2 plus y1 e raised to x minus e raised to x is equal to 0. So I can find the value of y3 of 0. Again 1 plus, in place x put 0, e raised to 0 is 1, so 2 y3 of 0 plus 2 into 1 is into what is y2? Y2 is 1 by 4. Fine. E raised to 0 1, y2 is 1 by 4, we got it, plus y1 is 1 by 2. See, y1 of 0, y1 are all save, y2 of 0, y2 are save only. So 2 into e raised to 0 1, y2 is 1 by 4, y1 is 1 by 2, again 1 minus e raised to 0 is 1 is equal to 0. Okay, 2 1s are 2 2s are. Now see, 1 by 2 plus 1 by 2 is 1, 1 was 0. So y3 of 0 is equal to 0. That's all. Lastly, one more time, 1 plus e raised to x as it is, derivative y3 is y4 plus y3 into e raised to x plus 2 e raised to x as it is, derivative of y2 is y3 plus y2 as it is, and 2 e raised to x as it is. Am I right? This is done. 2 e raised to x as it is, first function, differential y2 is y3 plus y2 as it is, again 2 e raised to x plus y1 into e raised to x plus e raised to x as it is into derivative of y1 is y2 minus e raised to x is equal to 0. That's it. Now put the values here. If you put the values, I will put directly because this is the last term. So 2y4 of 0, 2y4 of 0 plus y3 is 0 plus 0 plus what is y2? 1 by 4 into 2, y2 is 1 by 4 into 2 plus y1 is again 1 by 2 into 1 plus again y2 is 1 by 4, correct, minus 1. Again this will be, see, 2 and 2 2s are cancels, so only 1 by 4 remains, So y4 of 0 is equal to minus 1 by 8. Am I right? Because see, 1, 2 and that 2 2s are 1 by 2, 1 by 2, 1, minus 1, 0. 1 by 4 go that side, it becomes minus 1 by 4, 2 go this side, it minus 1 by 8. Therefore, log of 1 plus e raised to x in the series expansion is written as y of 0 is log 2 plus x into 1 by 2 plus y1 plus x square by 2 factorial, that is 2 factorial is 2 itself, right, as it is 2 into y2 of 0 is 1 by 4, correct, plus 0 because right, x cube by 3 factorial, x cube by 3 factorial 6 into 0 because y3 is 0, and lastly plus x raised to 4 by 4 factorial is 24, correct, into y4 of 0 is minus 1 by 8, so on, correct. So this is the answer what we get. If you further simplify it, this will be log of 2 plus x by 2 plus x square by 8 minus x raised to 4 by 8 4 is 32 192. That's the answer, correct. 8 4 is 32 into 16 19. Yeah, that's the answer. Okay, so I don't expect them to ask this question, but anyhow you practice this, it will help you. Other questions, no, log secant x I doubt they may ask this time, or root of 1 plus sin 2x, fine. One more is find a Maclaurin series of tan x after x to 4 is of question paper, goes to be very easy. They can ask this question, they ask this once, so I'll just this question also I'll write it for you, then we'll move on to the Lapidus. Find Maclaurin series for y is equal to tan x. Okay, so very simple question, up to x is to 4. Fine. So again we have y is equal to y of 0 plus x into y1 of 0 plus x squared by 2 factorial, y2 of 0 plus x cubed by 3 factorial, y3 of 0 plus x raised to 4 by 4 factorial, y4 of 0. Done. Now let's solve this. We have y is equal to tan x, that means y of 0 is equal to 0 because tan 0 is 0. Then we have y1 is equal to tan differential tan x is secant square x. So little bit of differentiation you need to know. Okay, simple differentiation is required here. So we have secant square x, so y1 of 0 is equal to secant 0 is obviously 1 because cos 0 is 1. Now remember one thing, when you are doing for log secant x also, you can refer the example. Here also see secant square x, always when you are differentiating 3 to 4 times more, when they give secant square x, simple trick is what, write secant square x, 1 plus tan square is secant square, sin square plus cos square is 1, 1 plus tan square is secant square, 1 plus cos square is cos secant square. So secant square is 1 plus tan square. Why I am doing it? Because see, tan x is y, so I can simply write y1 is equal to 1 plus y square. This will become more easier for me. I have y of 0, I have y1 of 0. Now y2 will be very easy for me. Differential 1 is 0, differential y square is 2y into y1. So y2 of 0 will be what? So it becomes so easy. All the otherwise again different secant square will be 2 secant x into again secant x tan x, secant square tan x. It will be very confusing differentiation. This makes it easy. Y square is 2y into y1, that's all. Okay, so y2 of 0 will be 2 into y is how much? 0 into y1 is, so that will be 0 only. Again differentiate, y3 is equal to it will be now product rule. So what is the product rule now? It will be 2y into derivative y1 is y2 plus y1 into 2y1. So y3 will be equal to 2y y2 plus 2y1 square. That means y3 of 0 will be 2, obviously y 0. What is y1? 1. So it is 2. So it is equal to 2. That's it. Okay. And the last differential now is y4. So y4 is equal to 2y into y3. See 2y as it is, product rule for this. Derivative y2 is y3 plus y2 as it is, derivative of 2y is 2y1 plus differential of 2y1 square is to the 4, 4y1 into y2. Okay, that means y4 of 0 will be equal to, where y is there, it will be 0 only, plus 2y2 is again, see y2 is 0, so 0 only, plus 4y1 into y2 again 0, that is equal to 0. That means tan x is equal to y of 0, 0 plus x into 1 plus x square by 2 factorial is 2 into y2 of 0 is 0 plus x cube by 3 factorial is 6, what's 3 factorial 6, right, into 2 plus x is to 4 by 4 factorial is 24 into 0. That means I can write tan x as equal to x plus x cube by 2 into 2 3s are. This is the series up to 4 terms. That's how you expand it. I hope you clearly understood the solution here, but please practice the other problems also, like secant x, log secant x and root 1 plus sin 2x. Very important for examination. Okay, so let's move ahead with the next problem now. See, the next problem is on L'Hopital's rule. Simple questions, okay, but still student make mistake. The first problem is evaluate limit of x raised to 0, a raised to x plus b raised to x plus c raised to x upon 3 raised to 1 by x is equal to, find a solution. See, this problem, I imagine, I don't know, since I am teaching from past 20 years, how many times they have been asked in the examination. And I think previous also paper they asked the same question, and this time also they might repeat the same question. It is limit of x change to 0, a raised to x plus b raised to x plus c raised to x upon 3 raised to 1 by x. I solved this question already, so please do refer that. And I will show you one more question like this, taking upon 4. See here it is a raised to x plus b raised to x, c raised to x upon 3. I take plus d raised to x and show you. So please watch carefully. Very important solution. Might be they ask the same question this time. Okay. So practice along with me. So we have evaluate limit of its as x tending to 0, a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 by x. Okay. Now, when there is a power to a limit, what we do, we apply log on both sides. So first, we apply assign k is equal to, always in any limits assign k step by step. A raised to x plus b. So okay, I take this question as, since this problem already solved, I take it as plus d raised to x upon 4 whole raised to 1 by x. Okay, plus b raised to x plus c raised to x plus d raised to x whole divided by 4 whole raised to 1 by x. Now, always when I apply limit to it, it will be a raised to 1 plus 1 4 by 4. So 1 raised to 1 by 0 is infinity. Whenever we have the type as 1 raised to infinity or 0 raised to infinity, infinity to infinity, we apply log on both sides. So log of k equals limit as x tends to 0, log of a raised to x plus b raised to x plus c raised to x plus d raised to x upon 4 whole raised to 1 by x. Now when I apply this log, see there is a property of logarithm. Log a raised to k is k log a. Log a raised to k is k log a. That means this will be log k is equal to limit of x tending to 0, 1 by x into it is log a raised to x plus b raised to x plus c raised to x plus d raised to x upon 4 into 1 by x, it will be upon x. Because to solve any L'Hopital rule, the problem should be a fraction, numerator by denominator. Now, here if you see, okay, now here if you see, when I apply the limits here, again it will be same. So see, a raised to x, it will be log a raised to x plus a raised to 0 is 1, b raised to 0 is 1, c raised to 0 and d raised to 1. So 1 4 by 4 is 1, log 1 is 0, so 0 by 0. So let's apply the L'Hopital's rule here now. Now how do you apply L'Hopital's? Differentiate numerator separately, differentiate denominator separately. So we have log of k equals limit as x tending to 0. Okay. So differentiation of, see this whole thing separate, log, understand this clearly, okay, this whole and this separate. Differentiation of log of x, what's that? 1 by x, am I right? So it will be 1 by x, that means this will be 1 whole divided by a raised to x plus b raised to x plus c raised to x plus d raised to x by 4. 1 by. Again into chain rule. It's not plain x, only differential log x is 1 by x. So log of this thing is 1 by x into again differentiation of upon 4 as it is differentiation of a raised to x is. See, this is a very standard differentiation which we miss out to memorize. Yes, this is differential, right? Derivative of a raised to x is always a raised to x log a. Listen carefully. Derivative of a raised to x is a raised to x log a. Remember it always. It's used only in this problem. So it will be a raised to x log a plus b raised to x log b plus c raised to x log c plus d raised to x log d upon 4. Okay, whole divided by differential x is what? 1. Then now this will be, I think I can apply the limits over now here. So when I apply the limits here, okay, we'll get, so that implies log of k is equal to, so when I apply the limit, this limit goes, so let's apply limit everywhere 0 because we cannot differentiate anything, differential x is 1, again 1 is 0, so it's end. So when I apply the limits now, this will be, see, 0, a is 0 is 1, so log of a plus b raised to 0 is in place x put 0. Applying the limit means wherever x is there put 0, b raised to 0 is 1 plus b raised to 0 1 log b plus c raised to 0 1 log c plus log d whole divided by 4, and this again 1 by, okay, 4, and this will be again, see, in apply here 4 by 4, correct now. So a raised to 0 1 4, this will be upon 1 only because this will be again 1 divided by, right here. So this is bracket 1 divided by 4 by 4. Why? Because see, a raised to 0 1, b raised to 0 1, c raised to 0 1, d raised to 0 1, 1 plus 1 plus 1 plus 1, 4 by 4, 1 cancels. This is what you get. So that implies log of k is equal to, see, log a into b is log a plus log b. It is log a plus log b is log a into b. So log a plus log b plus log a, c d is nothing but log of a b c d into 1 by 4. Again I can apply the property here. Which property? Log a raised to k is k log a. See here, right here. Log a raised to k is equal to k log a. So based on that property here, this will be nothing but log of k is equal to log of a b c d raised to 1 by 4. Am I right? Therefore this log and log cancel. The value of k is a b c d raised to 1 by 4. This is the final answer. Beautiful. This is how to solve. So for if the problem is 3 terms a b c, then it will be a b c raised to 1 by 3. That's how we do it. Okay. I hope you clearly understood. Very important question. They can ask this or that question. They may ask this type D because past 2 years no, they haven't asked 4 terms. They may ask this time. So please practice it and go. It's a high probability question. Please practice it. Fine. Next, see, VTU keeps on rotating the questions many times in the examination. That is a plus point for you. One more L'Hopital rule which I haven't solved it. It is question number 7th. First one is limit as x tends to 1, x raised to 1 by 1 minus x. Again, if I apply k to it, k is equal to limit as x tends to 1, x raised to 1 by 1 minus x. So this yields 1 raised to infinity. Again 1 raised to infinity. So we'll apply log on both sides. We have log k is equal to limit as x tending to 1 log of x raised to 1 by 1 minus x. Okay. That will be now again limit as x tending to 1 log x by x 1 minus x, because the property applies log a raised to k is k log a. So write clearly here log x raised to 1 by 1 minus x. Okay. So log a raised to k is k log a. So it comes down 1 by 1 minus x comes down. So again log will be 0 by 0 only. So I can apply the L'Hopital's rule. So we have log of k equals Differentiate this. Differential log x is limit x tends to 1. See, x is tending to 1 here, log x is 1 by x upon 1 minus 1. Why? Because derivative of 1 is 0, differential x is minus 1. So we have this, so we have therefore put value here. So log of k is equal to minus 1. So k is equal to e raised to minus 1. That implies k will be 1 by e. That's all. Okay. They asked like this couple of questions for 7 marks. This will carry around 3 to 4 marks. So the next problem here is evaluate one more problem on L'Hopital's. Limit as x tending to 0 cos x raised to 1 by x square. Okay. So let's solve this. So we have k is equal to limit as x tending to 0 cos x raised to 1 by x square. So apply log on both sides because the limit here will be 1 raised to infinity. So we have log k is equal to limit as x tending to infinity log of cos x raised to 1 by x square. As I told you that when apply log a raised to k is k log a. So this will be now log k is equal to limit as x tending to 0 log of cos x divided by x square. Now again cos raised to 1 log raised to 1, so it will be 0 by 0. So I can apply the L'Hopital's rule here. So we have log of k is equal to limit as x tending to 0. Differentiation of log cos x is 1 by cos x into minus sin x whole divided by 2x. That would be limit as x tending to 0 minus tan x divided by 2x. Okay. Now there is an interesting thing here. You see, there is a limit, right? The limit says that limit as tan x by x as x tends to 0 is equal to what? 1. Using that limit, see x is tending to 0 here and tan x. So we can rewrite this as, this is nothing but log of k is equal to limit as x tending to 0 minus 1 by 2 into tan x by x. And obviously according to formula tan x by x is equal to 1. Therefore log k is equal to minus 1 by 2 implies log k is equal to minus 1 by 2. So k is equal to e raised to minus 1 by 2 is the answer, or it is equal to 1 upon root of e. That's it. That's how it is done. Okay, this is a solution for it. Fine. So one more problem we will solve here. The last problem in L'Hopital's. So I'll solve it here itself. I hope you taken on this. If not, then please rewind the video back and write it down. I'll solve it here. So the next problem here is, it says evaluate limit as x tends to pi by 2, limit as x tending to pi by 2, 90 degrees, pi by 2, secant x whole raised to cot x. Okay, let's solve this question. So again, if we apply the limits here, we have, this will be, see secant pi by 2, cos pi by 2 is 0, so secant pi by 2 will be infinity. Tan pi by 2 is infinity, so secant pi by 2 is 0. So we apply log on both sides here. So first apply k is equal to limit as x tending to pi by 2, secant x raised to cot x. So apply log on both sides. Log of k is equal to limit as x tending to pi by 2, log of secant x raised to cot x. Now as you know, log a raised to k is k log a. So we can write limit as x tending to pi by 2 cot x into log of secant x. Now the condition for L'Hopital's is the given question should be fraction. So it's very simple. I can write cot x as 1 by tan x. That's it. So let's see what happens here. So log k is equal to limit as x tends to, and see the limit here. What takes place? Log of secant x by tan x. Fine. Secant see, cos 0 is 1, secant cos pi by 2 is 0, secant by infinity, so it will be tan, so it will be okay. I can apply it, the L'Hopital's rule here. So now apply the L'Hopital's rule here. This becomes, that implies we can write log k is equal to limit as x tending to pi by 2. Am I right? This will be now differentiated. Differential log secant x is 1 by secant x into secant x tan x whole divided by tan x is secant square x. Secant cancels. So we get this much again. So we have log of k is equal to limit as x tending to pi by 2 and tan x upon secant square x. Am I right? Please check it. So I have the question problem here. This problem has been asked one time in the examination. We check the limit, we apply log on both sides. So log k is equal to limit x into pi by 2, log secant x into cot x. Log e raised to k log a, it came down, and since it should be fraction, I wrote it as log secant x upon tan x. Okay. So we have this, so 0 by this thing. Now log k is equal to, we apply the L'Hopital's rule here. 1 by secant x into secant x tan x, secant cancels upon differentiation of tan x secant square x. Again let's differentiate this. We have this as, again it applies. So again this becomes infinity by infinity. So what we can do here is, I will rewrite this as, see what I am doing here, I will rewrite this as log k is equal to solve this problem, limit as x tending to pi by 2, tan x is sin x by cos x, correct, and 1 by secant square x is cos square x. So cos and cos cancels. Again this becomes log k is equal to limit as x tends to pi by 2 sin x into cos x. So what I'll simply do, so wherever we get sin x cos x, this formula, sin into cos, this formula, sin 2x is 2 sin x cos x, correct. So I'll multiply by 2 and divide by 2. So this becomes, that implies log k is equal to limit as x tending to pi by 2, 1 by 2 into, what is that, sin 2x. Now we put the value, so in place of x put pi by 2, sin pi is 0, so log k is 0. It implies, I write here, log k is equal to 0, so k is equal to e raised to 0, that is equal to 1. That's the answer. What's k? Okay, so k is equal to e raised to 0, that is equal to 1. That's the solution for this problem. That's all. I hope you understood it clearly. So these are the problems from L'Hopital's rule. So please practice them, but the most important is that this one, a raised to x plus b raised to x, there are 3 terms or 4 terms that may be asked in the examination. So please, I am again telling you, this is a high probability question. Please practice it and don't lose any single marks in it. Okay, so let's move on to the next question now. Now see, the next problem is, there are set of 2 problems are there, very interesting and highest probability problems. If u is equal to f of x minus y, y minus z, z minus x, show that dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 0. And if u is equal to f of x by y, comma y by z, comma x z by x, show that x u x plus y u y plus z u z is equal to 0. Out of these 2 questions, 1 question may be asked in the examination. So I solved this question, so please practice them. The link is given in the description below. The next one is from Jacobians. Jacobians is, the first one is very simple question. If u is equal to x square plus y square plus z square, comma v is equal to xy plus yz plus zx, w is equal to x plus y plus z, find dou u by w by dou x y z. This is also a very simple question. I solved it, and Jacobian is considered to be simple. See this question 12. They might ask this question. It's a nice, interesting question. If u is equal to x plus 3y square minus z cube, v is equal to 4xyz, and w is equal to z square minus y, find dou u by w comma by dou xyz at 1 minus 1 0. Very important question. They can repeat this question in the examination. Solve This also I solved it, so you can find a link in the description below. So refer my solutions. I solve it in a very simple way. Even if you don't know the basics, you can easily understand it. Okay. Fine. Next one is okay. Jacobian. One more problem. That is these two questions are there. If u is equal to yz by x, v is equal to zx by y, and w is equal to xy by z, show that dou uvw by dou xyz is equal to 4. Interesting question. They get repeat the same question in the examination. One more is, this also I solved. Please refer the link or find a link in the description. If x plus y by z is equal to u, y plus z is equal to v, z is equal to uvw, show that dou xyz upon dou uvw is equal to uv. This problem has not been asked since a while. So you can expect this to come in this examination. So prepare for it. Anyway, Jacobian questions are very easy. It's nothing but finding determinant. So if you practice these problems, no, see 1, 2, 3, 4, number is there. One will be asked in the examination definitely. So there is a full chance of scoring around 6 to 7 marks. Okay, remember it. Fine. Don't miss this question, please. This and this question and the which is a chain rule. It will fetch you around 12 to 13 marks guaranteed. Fine. There is one more problem here, that is if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou xyz upon dou r theta phi is equal to r square sin theta. Very, very important question. There might be a probability they may ask this question if the question is little bit moderate. Okay, if the question paper is easy, no, then they may ask simply this question, which is these first two questions, x square y square z square, or x plus 3y square minus z cube, find the value of 1 minus 0. They can ask. If the question is little moderate, then they may ask these two questions: u is equal to yz by x, z by x by y, or show that dou u v by dou x y is equal to 4, or this one, if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou x y z by dou r theta phi is equal to r square sin theta. So better I'll solve this problem for you. Who knows, this same may be asked in examination. Fine. Now, question here is, if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou x y z upon dou r theta phi is equal to r square sin theta. Okay. Now, first let's write the spherical coordinates that are given here. So we have here x is equal to r sin theta cos phi. Then we have y is equal to, easy. So let's do everything step by step, into cos phi, and lastly z is equal to r cos theta. Fine. Now we need to find dou of z by dou of r theta phi. Okay. So j, that is Jacobian, is equal to dou of x y z over r theta phi, and that will be equal to. So we have done a lot of problems here, so please refer the playlist for such problems. Now the Jacobian or dou xyz with respect to dou r theta phi will be very simple. Pay close attention here. See, dou x with respect to all r theta phi. Okay, that is dou x by dou r. Dou x with respect to all r theta phi means dou x by dou r, dou x by dou theta, and dou x by dou phi. So dou x by dou theta and dou x by dou phi. That's it. Then y with respect to all. So dou y by dou r, dou y by dou theta, and dou y by dou phi. Right. Lastly, dou z by dou r, dou z by dou theta, and dou z by dou phi. This is the determinant. Now we need to find all the partial derivatives here. Okay, and put in a determinant and find the value of determinant and see if the value comes to be r square sin theta. So let's do it now. First, see, dou x by dou r. Here we are partially differentiating x only with respect to r. See, r is multiplied. That means, how we do it? See, determinant of, watch carefully, dou x by dou r, sin theta cos phi as it is. It's very easy, so please pay close attention. Sin theta cos phi as it is. Derivative of r with respect to r is 1. Next, dou x by dou theta. See, again, r cos phi as it is. See here, we are differentiating with respect to theta. So r cos phi as it is, differentiation of sine theta with respect to theta is nothing but cos theta. That's it. And lastly, dou x by dou phi, here r sine theta as it is, derivative of cos phi, because see here, we are differentiating only with respect to phi. Phi is only here, correct? That means r sine theta, don't touch it as it is. Differentiation of cos phi is minus sine phi. I hope it's clear. Now the next row, dou y by dou r, again r is here, sine theta cos phi as it is, sine theta, oh sorry, this is sine theta sine phi, sorry. Okay, so we have sine theta sine phi as it is. Okay, differentiation of r is 1. Dou y by dou theta. So here see, we are differentiating with respect to theta here. Correct? That means r sine phi will be as it is. Don't touch it. Derivative of theta, sine theta is cos theta. That's it. Okay. Fine. I hope you remember in the previous problems I explained the concept of partial differentiation. That is, if I here, if they say apple, banana and a grape, say if r is apple, theta is banana and phi is grape, then they ask dou x by dou r, then only the apple, keep the banana and grapes as it is. That is how the partial differentiation works. So here again see, I show you dou y by dou phi. Here dou y by dou phi. Why is in the basket r sine theta cos phi? There is apple, theta is grape, and r is apple, theta is banana and grapes. Now dou y by dou phi, we need to eat only the grapes here. So r sine theta, don't touch it. That is apple and banana, don't touch it. Differentiation of sine phi is nothing but cos phi. As simple as that. Understood? Similarly here. Okay, because many students confuse this partial differentiation. Okay, here we need to differentiate only what they have mentioned, denominator, that's all. See, dou z by dou r, z is here, r. That means here only apple and banana, no grapes. Phi is upside. So dou z by dou r. So cos theta as it is. Don't touch the banana. Differentiation of r with respect to r is 1. Dou z by dou theta. So r as it is, banana. Derivative of cos theta is what? Theta, theta. Derivative of cos theta is minus sine theta. Perfect. And the last one is dou z by dou phi. We need to eat banana. But what is that? The basket is only apple and, dou z by dou phi. We need to eat only grapes. But the basket here has apple and banana, no grapes. So obviously cannot eat anything. So constant. So derivative of constant is what? 0. That's it. Finish. Now, how do you solve it? Say I can take plus minus plus here. But the most easiest way is to start from down. Okay, to find cofactor down. So plus minus plus. Why? Because series element is 0. So everything into 0 becomes 0. So the thing becomes small. Okay, the solution becomes compact. Now, first, how to solve it? That implies first plus into cos theta. We are finding for cos theta here. Cos theta into square bracket. So plus into cos theta. When you take for this cos theta, see, watch carefully. We leave this column including having cos theta and leave this row including cos theta. Then we have this into this and this into, because if you go around here in the multiplication, then you'll keep on struggling to get the answer. Fine. Now see, cos theta, I left this column and left this row, this into this. So r square sine theta cos theta into cos phi is cos square phi. Am I right? Fine. Minus, see here, minus r into r square. But there is this, how the determinant works, this into this, minus of this into this. So minus, there is one more minus here. So minus into minus becomes what? Plus. Be careful. So plus r into r is r square. Sine theta into cos theta as it is. Okay. Next, minus. Okay, done. Fine. Close the bracket. Am I right? Sorry. One more thing remaining. Sine phi into sine phi is sine square phi. Then close the bracket. Okay. Next, minus of what's the component here? Minus r sin theta. Minus into minus r sin theta is what? Plus r sin theta. Write it legibly so you won't go wrong anywhere. So now when you're taking for minus plus r sin theta, we leave this column, leave this row. Now it will be, the operation will be between these two elements. I'll show you this into this. Correct now? Because I'm leaving this column including minus r sin theta, I'm leaving this row including that. So what remains? This into this. So r into sine is sine square theta into cos into cos phi, cos square phi, minus again minus r. So minus r is there, minus of minus r plus r into sine square theta into sine square phi. I hope it's clear. Sine theta, sine square theta, sine phi, sine square phi. Done. So we are done with the determinant here. Now let's evaluate this. So that implies we have cos theta into, see here, if you see here, r square sine theta and r square sine theta is common. So if you take it common here, we get r square sine theta cos theta into bracket cos square phi plus sine square phi. Okay, and here plus r sine theta into, here if you see r sine square theta and r sine square theta is common. Okay, so we have r sine square theta is common here. Inside is cos square phi plus sine square phi. Done. Now as you know, this is 1, this is 1 because sine square plus cos square theta is 1, the trigonometric identity. That means this will be open a bracket, r square sine theta cos square theta plus r square sine cube theta. Now here again see, r square sine theta is common here if you see, because r cube sine theta is common and sine is here, and what remains here, cos square theta plus sine into sine square, sine cube theta, so sine square theta, again sine square plus cos square is 1. So this will be now r square sine square theta. I hope we have reached what they are asked in the question, that is r square sine theta. Therefore that implies the Jacobians are dou of x, y, z with respect to dou of r theta phi equals r square sine theta. A very, very beautiful solution. That's it. Okay, I hope you understood the solution clearly here. But again, such questions have the probability to be asked in the examination. This is a high probability question, so please practice it 2 to 3 times till you become perfect. Okay, I hope you'll do it. So I hope the question is clear. Now moving on to the next problem, a problem on extreme values of the function. Okay, it says find the extreme values of the function f of x y is equal to x cube plus y cube minus 3x minus 12y plus 20. Very, very important question. Again, I am telling you, this question, there are 2 problems like this. One is this one, and one more is find the maximum and minimum values of f of x y is equal to x cube plus 3xy square minus 15x square minus 15y square plus 72x. Both are very important. The first one is very, very important. They discuss it in this time question paper. So don't miss it. Okay, please practice it. If this comes, you should not miss a single marks in the examination. So which one I am telling more to do? Practice. F of x y is equal to x cube plus y cube minus 3x minus 12y plus 20 has a more probability of coming in the examination. Okay. So the videos here, the link is given in the description. Please watch the video and practice it. I explain in a very simple way, a simple partial differentiation because there is no complex terms here, and a simple table. You will clearly understand, don't worry. But you need to practice. See, as I promised you that I will help you complete this 21 maths 1 paper this time once for all. I don't want to leave any loopholes. So there are some more very important questions from module 2. So let's solve this. Practice this question also. Okay, they may ask for the examination. So the Maclaurin series one repeat question is, they may ask this time, obtain Maclaurin series for log of 1 plus sin x up to x raised to 4 term. So in this previously I discussed one more, that is log of 1 plus cos x. That is also important. This is also very important for the 21 scheme. They have been asked 2 to 3 times. Okay. So let's solve this now. So obtain the Maclaurin expansion for log of 1 plus sin x. First, again I am telling you, many people complain that I have written this question but they haven't given me any marks, step marks. See, as students I know what mistakes you do. First you need to write the Maclaurin series. If you don't write Maclaurin series, you are not going to get it 1 marks even if your further steps is wrong. Okay, so step by step. So first thing is write the Maclaurin series. So the Maclaurin series is y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial into y2 of 0 plus x cube by 3 factorial into y3 of 0 plus x raised to 4 by 4 factorial into y4 of 0. This is the Maclaurin series. If you write it, you will get 1 marks, even though solution is wrong. Now, next is, let's make everything perfect. So we have y is equal to, watch carefully, this is very easy things, okay, sin x. Y of 0 will be, I write it, y of 0 will be, y of 0 means in place of x put 0, sin 0 0, so you get log 1. What is log 1? Log 1 is 0. Here also, see, when you are getting this answer, the examiner will have this keys, answer with him. So he will give marks accordingly. If this only you are writing some log 1 or something, not writing 0, then obviously he will 0 marks. But if you written this thing, they will give at least 1 marks. Okay. Now y1 is equal to differentiation of log x is 1 by x, so 1 by 1 plus sin x. Again differentiation of sin x is what? Cos x. So we have y1 of 0 is equal to, see, cos 0 is 1 upon 1, so 1 only, because sin 0 is 0, cos in place of x put 0, cos 0 is 1 as 0, sin 0 is 0, that's all. Okay, now what I'll do, see, I can solve it in 2 ways. One is directly I can use quotient rule, but quotient rule is lengthier. More easier than quotient rule is what? Product rule. So I'll take it this side, write it as y1 into 1 plus sin x minus cos of x is equal to 0. So now differentiate. So product rule. So y1 as it is, derivative of 1 plus sin x is cos x plus 1 plus sin x as it is, derivative of y1 is y2 minus differential cos x is minus sin x, so plus sin x is equal to what? 0. Am I right? So product rule only for this. UV, first function as it is, derivative 1 plus sin x is cos x, 1 plus sin x as it is, y1 is y2 minus derivative of cos x minus plus sin x. Now put a value. So we have y1 of 0 into, so we know, see, this will be, we need to find now y2 here, correct? We got y0, y1 0. So we have y1 is, see, y1 of 0, y1 of both same. So 1 into cos 0 is 1, in place of x put 0 here, y1 of 0, cos 0 is 1, plus 1 plus sin 0 is 1 only, plus y2 of 0 we need to find, plus sin 0 is 0 is equal to 0. That implies y2 of 0 is how much? Minus 1. Done? Next, one more time differentiation here now. See, again product rule. See, carefully do it step by step, okay? Practice it. See here, product for this, product for this. y1 as it is, derivative of cos x is what? Minus sin x plus cos x as it is, derivative of y1 is y2 plus 1 plus sin x as it is, derivative of y2 is y3 plus y2 as it is, derivative of sin x is 1 plus sin x is cos x plus sin x is cos x is equal to 0. Okay, beautiful. Now again, y1 is 1, sin 0 0, late. So 0 plus cos 0 is 1. What is the y2? Minus 1 plus 1 plus sin 0 0, 1 into what is y3? I don't know. y3 of 0 I need to find out, because sin 0 0, 1 plus 0 is 1 into y3 of 0 plus y2 is again minus 1 into cos 0 is 1. Are you getting it? Plus again cos of 0 is 1. So minus 1 plus y3 of 0 minus 1 plus 1. This cancel is equal to 0. That implies y3 of 0 is equal to plus 1. Take it this side. Okay. Now the last thing, y4 of 0. I can add this together to become minus y1 sin x. See, cos x y2 y2 cos x will become plus 2 y2 cos x. Then plus 1 plus sin x y3 plus cos x is equal to 0. Am I right? Minus y sin x cos 2 cos x into y2 plus as it is plus cos. Okay. Now let's differentiate this again. Okay. This things requires patience and practice both. We have minus y1 as it is, derivative of sin x is what? Cos x, plus sin x into minus means minus sin x into derivative of y1 is y2 plus 2y2 as it is. See here, product rule, 2y2 as it is, derivative of cos x minus sin x, so write directly minus 2y2 into sin. These are very simple things. Okay, plus cos x as it is, derivative of 2y2 is what? 2y3 plus 1 plus sin x as it is, derivative of y3 is y4 plus y4 as it is, derivative 1 plus sin x is cos x minus sin x is equal to 0. I think done. Now again we have y1 is 1, so minus 1 cos 0 is 1 minus 0 because sin 0 0 and again 0 only plus 2 into cos 0 is 1, y3 is what? Again 1 plus 1 plus sin 0 1 only, y4 of 0 we need to find, plus y4 is again 1 plus sin is y4 plus y3 into cos x. Okay, y3 is 1 into cos 0 is 1 and minus 0 is equal to 0. That means we have minus 1 plus 2 plus y4 of 0 plus 1 is equal to 0. 2 minus 1 is 1, 2. So y4 of 0 will be minus 2. That's it. This is what we have. Am I right? Perfect. Therefore, log of 1 plus sin x in series expansion written as y of 0 1 plus x into y1 of 0 1 plus x square by 2 factorial into y2 of 0 minus 1 plus x cube by 3 factorial into plus 1 plus x is to 4 by 4 factorial into minus 2. Now that means I can write it as the series expansion of final answer 1 plus sin of x is equal to 1 plus x minus x square by 2 factorial is 2 plus x cube by 3 factorial is 6, and see x is to 4 by 4 factorial is 24, 2 by 24 is 12 minus x is to 4 by 12. That's the solution. Please verify your answers along with me. That's it. This is how we find the Maclaurin series for log 1 plus sin x up to x is to 4. So please, you need to practice it for getting the correct answer, because this is the main thing. The differentiation here, 3 to 4 times we do, that comes, the perfection comes only by practice. That's it. Okay. So module 4 is all about first order differential equations and applications. In module 1, the most important repeat question which students find very easy but still lose marks is Newton's law of cooling. 150% question. Okay, peace of mind, you can get the full marks. I'll solve some 2 questions here. The first question is, if air is maintained at 30 degrees Celsius and a metal ball cools from 100 degrees Celsius to 70 degrees Celsius in 15 minutes, find, just a second, sorry for it, find how long it will take for the metal ball to reach a temperature of 40 degrees Celsius. A very interesting problem. I already solved this problem, so please do refer the link given in description below. Okay, next one problem solve here for you using the calculator. Fine. The problem is a body a body in air at 80 degrees Celsius cools down to 60 degrees Celsius in 20 minutes. In 20 minutes. The temperature of air being, I am writing short form, so full question you can find in the fresh model question, this important questions. I made a PDF and shared it in description, please find it, okay. The temperature of air being 40 degrees Celsius. What will be the temperature? What will be the temperature of body after 40 minutes? So the first thing is, the previous question also you can refer to that. Here they are asking how long it will take time, and here it is the what is final temperature after a given time. So both question one may be asked, they may change the values and give. So if you practice this both questions, that's more than enough, okay. First question, do it, okay. I guess the video is there, the link is given in description, please do refer that. This also I am solving it here, see. Now the major formula, very simple formula, my formula to find this is T is equal to T1 plus T2 plus T1 minus T2 into e raised to minus kt. Again one more time say it. T is final temperature after cooling, right here, final temperature after cooling. T2 is temperature of medium. T1 is initial temperature before cooling, and T is the time, and K is a constant. We will find K, okay. So I'll solve this problem step by step. Now see, analyze the question. A body in air at 80 degrees Celsius cooled down to 60. That means initial temperature of body is what? T1 is equal to 80 degrees Celsius. Cools down to 60 T. After cooling, final temperature is 60 degrees Celsius. In 20 minutes, T is equal to 20 minutes. The temperature of air being, air is a medium, a body in air, air is a medium is T2. T2 is equal to what? Medium, that is, understand like this, 40 degrees Celsius. So you have data here, put it here. So we have 60 is equal to 40 plus 80 minus 40 into e raised to minus times 20. So let's solve it. 60 minus 40 is 20 is equal to 40 e raised to minus 20. Okay. That means e raised to minus, see the simplification, 20k is equal to 20 by 40, 1 by 2. I have to find k value. See how I am doing it once again. E raised to minus 20k is 1 by 2. That implies e raised to plus 20k will be 2 by 1. Correct. That means apply log on both sides. So if I apply log on both sides, log e raised to 20k is equal to log of 2 implies 20k. I am doing everything step by step. Log e equals log of 2 is actually is natural logarithm. You can write log or ln. Okay, both same. So log is 1. 20k is equal to log of 2. So k will be equal to log 2 by 20. So let's solve this using calculator. So remember, as the old semester students, I know you are using this FX 981 ES plus. So further also the module 5 matrices I will do with this calculator only. Stay tuned. Now see mod. As I told you, LOG log, there is no base given. So all logs are natural logs. So always press what? ln here. ln. Don't, because many people know they lose marks, they press log. It's not log log, it's natural log, ln. Unless and until the base is given, then only take log. Log to the base 10 is log. But any log is always ln only. So we have ln of 2 divided by 20 is equal to 0.0346. So it is 0.0346. So K is equal to how much? 0.0346. So please underline it. You are going to get marks for it. Okay. So the value of K you need to underline. So let's underline it here. So I found K here as 0.0346. Okay. Now therefore T after 40 minutes will be what? Nothing but after time t till 40 minutes is T is equal to, what is that? Put here as same 40 plus 80 minus 40 into e raised to, what is that? Minus kt. K is 0.0346 into what's time here now? 40 minutes. For 40 minutes you have to find. That's all. So I am using this fx 919 US plus here. See how I do it. I do it from here again. So you found K as what? Log 2 by 20, correct? As I told you, use always ln. See, ln 2 divided by 20 is equal to, I got it 0.03465 somewhat. So to get an exact answer, what you do? Simply multiply by 40. See, into I'll do minus 40 is equal to. So again this stuff, what is that? Minus 1.38629, whatever is stored in the answer. So first always solve for this, then multiply. Okay, so this will be now 40 plus 40 into e raised to minus 0.0346 into 40, whatever. Okay, so first I have this in the answer. So what I'll do? See, shift e raised to answer is equal to into 40 is equal to 10. So this is 40 plus 10. So plus 40 is equal to 50. How much? 50. That's the solution. Therefore, T after 40 minutes is equal to 50 degree Celsius. That's the solution. That's all. I hope you understood this. So both the problems you practice, you can easily solve any problem value changed. Okay, so please do practice it. Fine. Only once you practice, you will be becoming perfect. So I don't want you to lose a single marks here. Again, I'm telling you, please do practice both the questions. 100% you will get the marks, and it's very easy. Only understand how to use a calculator, and I have given a simulation. Please refer the video and the earlier video also. Both if you refer now, that's more than enough. Okay, so that's all. So let's move to the second question now. There's one more question. See, a body in air at 25 degrees Celsius cools from 100 degrees 75 in 1 minute. Find the temperature of the body at end of 3 minutes. This also question now, same as this only. So I given it for you. So please practice it. Okay. This question you'll find in the important question PDF. Please practice the same question and verify the answers. Next one is problem on orthogonal trajectories. One more very important repeated questions. Find the orthogonal trajectories of the family of curves x square by s square plus y square b square is equal to 1 where lambda is parameter. A little lengthy question. I'll solve it for you here. Please sit, but it's very important. They keep on asking this question for Cartesian curve for orthogonal trajectories. So please check how I do it and practice along with me. If you practice 2-3 times, you'll be able to clear this question also. Okay, fine. In the orthogonal trajectories, I write in short form OT of x square by a square plus y square by b square plus lambda is equal to 1. This is the question, and here given lambda is parameter. That means you have to eliminate lambda. Correct? So as the theory of the orthogonal trajectory for Cartesian curve, we first differentiate to eliminate lambda and then replace dy by dx by minus dx by dy. So let's see how can I solve this question now. So we have the problem here. So let's take it as say x square by a square plus y square by b square plus lambda is equal to 1. So I'll take this as one side. Okay, now let's differentiate this. So first thing is to differentiate to remove lambda if possible. 2x by a square plus differentiation of y square is I write 2y into y1 by b square plus lambda is equal to 0. Here y1 I take it as dy by dx. Simple. Fine. That implies here now that implies x by a square. So what's that? X by a square plus y into y1 by b square plus lambda is equal to 0. This is what we have. Fine. Okay, the lambda is not eliminated here. So what I do? Now what I do, I rewrite this as, say, x by a square is equal to, I take that side, minus y1 by b square plus lambda. I take this as, say, 2. Okay. And again, okay, what I do is the question, the given question here to find a solution. So from the question that is 1, from the question what I can write, see, I can write a square, see this, x square by a square minus 1, correct? No, x square by a square, take 1 this side minus 1 equals minus y square by b square plus lambda. Fine. This is what I have here, x square. Or that again implies, take the LCM here, x square minus a square by a square is equal to minus y square by b square plus lambda. I take this as, say, number 3. So see, I did this, okay, I took the help of the question. Why I did this? Because if I divide this 2 by 3, so 2 divided by 3 implies, if you divide it, so what do I get? See, x by a square whole divided by x square minus a square by a square equals minus y1 by b square plus lambda. What is that? Minus y1 by b square plus lambda whole divided by minus y square by b square plus lambda. So here if you see clearly, a square cancels, and here I think y and y also cancels, and b square plus lambda also cancels. So that implies now, see, this cancels, what I get? X by x square minus a square equals to, minus minus also cancels, y1 by y. This is what I get. Am I right? So y also cancels, right? Yeah. Okay. Now the theory of orthogonal trajectories for Cartesian curves says that replace, or I can write this as I write this, 1 by y, I'll take y1 as now dy by dx. It will be easy to solve. Okay. The theory of the Cartesian curve, that is finding the OT for Cartesian curve, says replace dy by dx by minus dx by dy. Very important condition. So let's replace it here. So it implies we have x by x square minus a square equals 1 by y into minus dx by dy. This is what I have here. Now we need to solve this or integrate this. The solution is we need to separate the variables, x one side and y one side. So if you do that, see, it becomes, if you take this side, see, y dy, take this side. So this will lead to y dy, okay, equals to minus, I'll take this side. See, when minus go this down, it becomes minus x square minus a square by x into dx. This is what I get now. So let's integrate this now. So the integration will be, the solution will be integration of y dy plus integration of x square minus a square by x dx is equal to c. That again implies right here. So let's separate this. Integration of y dy plus, see here, x square minus a square by x, like a plus b by c is a by c plus b by c. It will be x square by x will be x only. This will be x dx. And here minus a square by x minus a square by x dx is equal to, I'll take c. Okay. I think simple integration. So integration of y dy is y square by 2 plus x square by 2. So what is integration x? Integration x will be x square by 2. Fine. And a square as it is, minus a square. What is integration 1 by x? Integration of 1 by x is log x. Log x is equal to c. So that's the solution. Again, I can rewrite the solution as c. 2 is common here. I'll take the solution, that implies solution is x square plus y square minus, take the LCM, 2a square log x, 2a square log x equals to 2c. See, 2c, c, k, what its constant only. So I take it as simply c. That's all. So that's the solution. This problem is very, very important, as this has been asked many times in the VTU papers of previous semester also. So, but it needs a lot of practice to understand the question. But I request you to practice 3 to 4 times. This question may be asked in the examination. Okay. See, the next problem is, show that a family of curves y square is equal to 4a into x plus a is self-orthogonal. One more damn sure question for the examination. Either the previous question x square plus y square b square plus lambda, or this question out of this one will be asked in the examination. Okay. This also I'll solve this for you. So please refer how I solve it, and then we solve the next question. Okay. Or show that the family of parabolas y square is equal to 4a into x plus a is self-orthogonal. Okay. From question from orthogonal trajectories of Cartesian curves. Okay, so what we do, first to differentiate, to remove a. If you differentiate, we get 2y into y1, or divided by x, it is y1 is equal to, it's 4a, correct. So we are not able to eliminate a. So what I'll do here is, what I'll do simply first, say, I will write the question here, okay, best to solve this, okay. I write it here. So y square is equal to 4a into x plus a. Let me take this as 1. Fine. Now here, when I differentiate this, I get 2y into divided by x, that is y1 is equal to 4a, correct? Differential x is 1. But I am not able to eliminate a here. So what I'll do here, that implies a is equal to 2y y1 divided by 4. That is y1 by 2. Fine. Now this value of a, I'll put in the question. So put a in 1. So y square is equal to 4 into y1 by 2 into x plus a, that is equal to 2y y1. Okay, oh sorry, again this will be what? Forgot here. So into 4 is y1 by 2 plus x plus y1 by 2, and that will be equal to 2y y1 into if you take here, it will be y1 by 2, right? So x plus y1 by 2. Fine. Am I right? Okay. Now let's open the bracket. So y square is equal to 2x y1 plus 2 cancels, plus, so multiply here, 2 cancels, it will be y square into y1 square. Fine. Now see, I can remove y from both sides. That implies y is equal to 2x y1 plus y into y1 square. This is what we have now. Okay. Now we can, to find the orthogonal trajectory for Cartesian curve, what is the condition, what is the process? We, after removing the constant a, whatever constant given, we replace dy by dx by minus dx by dy. So right here, so replace dy, I'll take this as second, okay, this is second. So replace dy by dx by minus dx by dy. That means I taken y1 here, no? So here y1 is equal to dy by dx, right? Okay. That means, that implies y1 is equal to minus 1 by y1. Oh sorry, y1 is minus 1 by 1. So put it here now. That implies, so y is equal to 2x into minus 1 by y1, right? Plus y into minus 1 by y1 square is 1 by y1 square as it is. Okay, am I right? So y is equal to 2x into, in place of y input, minus 1 by 1, and we have y into y1 square. So this will be now again minus 2x by y1 plus y by y1 square, correct? Now let's take the LCM of it. So we have y is equal to minus 2x plus there is y1 square. Okay, 2x LCM is y1 square, fine, LCM is y1 square. So this will be 2x y1 plus y. Okay, now what you can do is, that implies y into y1 square is equal to minus 2x y1 plus y, and that implies y is equal to, what is y, tell me? Y is equal to, take it this side, so 2x y1 plus y into y1 square, that's it, am I right? So y is equal to 2x y1 plus y into y1 square. Now I take this as say 3. Now see, we got a differential equation in 2s, y is equal to 2x y1 plus y by 1 square. For that, to find the orthogonal trajectories, we replace dy by dx with minus, by applying process here, minus 1 by or minus dx by dy or minus 1 by 1. When we apply it, we get the same equation, see both. So both 2 and 3 are same. Therefore, we can write the parabola of y square is equal to 4a into x plus a is self orthogonal. That's it. This is how it's done. I hope you clearly understood how to find the orthogonal trajectories for both Cartesian curves, the important questions. Next is the OT for polar curves. First one is find the OT for r is equal to a into, so in Cartesian curve what we do? We differentiate to remove the constant, then afterwards we replace dr by d theta by dx by dy by minus dy by dx by minus dx by dy. In polar, we again differentiate and again we replace dr by d theta by minus r square d theta by dr. That's all. Okay. So next is polar curves. Find the orthogonal trajectories for r is equal to a into 1 minus cos theta. I already solved this. Please refer the link in the description and practice it. Very important question. One more damn sure question. This they repeatedly ask in examination. This or the next one. Find the OT for r is to n is equal to a is to n cos and theta. This time also they can ask. I am telling you. High probability question. They can ask it, so practice it 3 to 4 times. This is OT for polar is a scoring area. They repeat the question many times. Okay. So I have solved it. Please find the link. And one more question. Find the OT for r is to n is equal to a is to n sin and theta. I haven't solved. So let me try it here. So find the OT for r is to n is equal to a is to n sin n theta. Let me try it. So for polar curve, we apply log on both sides first. Log r is to n is equal to log a is to n, as we had done in first module, same thing. So we write directly log r is to n is equal to n log r is equal to n log a plus log sin n theta. Recall it. We have solved the previous first module polar curve problems like this. So differentiate n into 1 by r dr by d theta equal to 0 plus 1 by sin n theta, and derivative of sin n theta is cos n theta into n. So n cancels. So we have this. So we have it as 1 by r dr by d theta is equal to cot of n theta. Fine. Now in orthogonal trajectories of polar curves, what we do? Replace dr by d theta by minus r square d theta by dr. That is standard process. So 1 by r into minus r square d theta by dr is equal to cot of n theta. Okay. That means it implies minus r d theta by dr is equal to cot of n theta. Now what we do? We separate the theta and r and integrate. That's a solution. Fine. How we do it? So we get dr by r. See, dr r goes this side. We separate again. Dr r goes d theta minus become plus. I take r first, then theta as a standard form. Minus is there, so equal to, so minus plus, this will be cot of n theta. This will be, sorry, d theta by, correct now? So dr, r goes, and d theta cot comes down. So simple, d theta by cot of n theta is equal to 0. So solution is integration of dr by r plus integration of tan n theta d theta is equal to, say, k. Okay. Now integration of 1 by r is log r plus. What is the integration of tan n theta? So this will be, see, integration of tan of theta is log secant theta. So integration tan n theta will be log of secant n theta. Again there is n here, so divided by differential n theta is upon n is equal to k. Okay, that means we can write n, we can, take this as, I can take this as n log of r, see, I can take LCM, n log of r plus log of secant n theta is equal to nk. I take this as log of c. Okay, nk is a constant, I'll take it as, say, log of c. Now again, n log r will be log of r is to n plus log of secant n theta is equal to log c. Now log a plus log b is log ab. So log of, that implies log of r is to n into secant n theta is equal to log c. So log cancels, that implies c is equal to r is to n secant n theta. See, I want in this form, right? So what I can do, this will be r is to n by cos of n theta. Am I right? Correct, no? So c is equal to r is to n by cos theta. Therefore, the orthogonal trajectories is r is to n is equal to c into cos of n theta. That's it, as it is. Okay, this is the answer. This is how we solve it. Fine, that's the orthogonal trajectories. So 3 problems I solved. One is orthogonal trajectories for a into 1 minus cos theta. Other is r is to n is a is to n cos theta, very high probability question. Another is this one. So please practice these 2-3 questions. One may be asked in the examination. That's all. Okay. Now let's move to the next problem on linear differential equations. See, I have this one problem from Bernoulli, that is linear differential, is Bernoulli differential equation, which have been frequently asked in examination. This time there is a high probability of asking this question. The question is, solve dy by dx plus y tan x is equal to y square secant x. So it's a Bernoulli's differential equation. Why Bernoulli's? Because there is y square here. Y is still into something. So what I do, simply divide by y square. See, simple. So we get 1 by y square dy by dx plus y square y is 1 by y tan of x is equal to secant x. Now the concept here is always this is differential of this. Always. Okay. So we put 1 by y is equal to t. That implies minus 1 by y square dy by dx is equal to dt by dx. Now I want to replace 1 by y square dy by dx by t. That implies 1 by y square dy by dx will be minus dt by dx. As simple as that. So whatever in place of 1 by y square dy by dx, put minus dt by dx. So it implies everything we try to make it linear to t and solve it. That's solution. Okay. So minus dt by dx plus this is tan x into t is equal to secant x. So I'll try to make it linear. What is linear in y means? See, dy by dx plus pi is equal to q. So I'll take minus this side. That implies dt by dx plus minus tan x into t equals minus secant x. So this is what? Linear in t. Linear in t. See here, t, t. Okay, like for a linear in y, right here, linear in y, it is dy by dx plus py is equal to q. See, y dt. Solution is y into e raised to integration of p dy is equal to whole q into integration of p dy of dy plus c. That's the solution. So here since it's linear in what t, the solution will be t into e raised to integration of, see this is p here, p is what, tan x, this is p and this is q. Okay, so p is tan x, q is minus tan x, q is minus secant x. So e raised to minus tan x dx is equal to whole minus secant x into e raised to minus tan x dx of dx plus c. That's the solution. Now I will do it separately. E raised to integration of minus tan x dx will be e raised to minus log of secant x, because integration of tan x is log secant x. So that will be now e raised to I'll write log of secant raised to x raised to minus 1. Why I am taking, because e raised to log of something is something. So what happens, this e and this log vanishes according to important result. E raised to log of something is something, e raised to log x is x only. E raised to log of this thing is nothing but 1 by secant x. Secant x raised to minus 1 is 1 by secant x. So I'll put it here. That implies t, what is t here? T is what? 1 by y, write in y terms, x and y terms. E raised to minus integration of tan x is nothing but 1 by secant x, correct, is equal to minus secant x into again 1 by secant x dx plus c. Therefore secant cancel, integration 1 is x. So this will be now 1 by y into, see what is 1 by secant x? 1 by secant is nothing but cos x is equal to minus integration of secant by secant is 1, integration 1 dx is x plus c. That's the answer. Or I can write, that implies the solution is cos x by y is equal to minus x plus c. That's the final solution. I hope you clearly understood this. It's a very easy question. Please practice it. Okay. So if you practice it, you will get the solution. Sometime now, instead of y square, they give y cube also. You can practice with that also. Okay, but this is a high probability question. Please don't miss it. They can ask in the examination. Please do it and go. There's one more problem here. Solve x square plus y square plus x dx plus xy dx, xy dx is 0. I think this is reducible to exact form. So the solution I solved already. Please check the link in the description below and solve it. That's an easy question. See, there is one more problem here that is solvable for p. It says solve xy dy by dx the whole square minus bracket x square plus y square dy by dx plus xy is equal to 0. So here see dy by dx when solve for p, dy by dx nothing but p. So we rewrite this as x y p square minus x square plus y square into p plus xy is equal to 0. So obviously this will be the solution will be a quadratic equation form. Okay. So here p square is treated as x here. So I will write for you ax square plus bx plus c. Solution is x is equal to minus b plus or minus root of b square minus 4ac by 2a. So let's apply the solution here now. When I apply the solution, so we get x will be equal to minus b, so minus minus plus c, b is x square plus y square plus or minus root of x square plus y square the whole square, b square minus 4ac. So 4ac means it is 4x square y square, 4x square y square, correct, upon, am I right? 4ac means a is xy, c is xy, x square y square upon 2a, 2xy. That means x will be x square plus y square plus, see this will be, I will do it here, okay. x raised to 4 plus y raised to 4 plus 2x square y square minus 4x square y square divided by 2xy, and this will be x raised to 4 plus y raised to 4 minus 2x square y square. It means x minus x square minus y square the whole square. Getting it? See, plus 2x, this is x square y square will be this much. So 2x square y square minus 4x square y square is how much? Minus 2x square y square. So x raised to 4 plus y raised to 4 minus 2x square y square is nothing but x square minus y square the whole square. That is x square plus y square plus or minus x square minus y square upon 2xy. Correct now? Root of x square minus y square the whole square, root goes and this remains. We get this. Okay. This is we are solving for, p is equal to, correct? P is equal to, okay, fine, not x, p is equal to. Therefore, one value of p, that implies p is equal to x square plus y square plus x square minus y square by 2xy. Here y square cancels, this will be 2x square by 2 cancels, this will be x by y, 1p. Other p is x square plus y square. First I taken minus here, now I take plus here, now I take minus. So minus x square plus y square by 2xy cancels, 2x square y cancels, so 2 cancels, so y by x. So one is p is equal to x by y, other is p is equal to y by x. What is p? dy by dx is equal to x by y. dy by dx is equal to y by x. Now solution is integration. I take this term this side, so x dx minus y dy is equal to 0. Here also dx by x minus, separate it, dx comes here, y comes here, is equal to dy by y. So minus dy by y, or this I write it. Okay, x dx is equal to y dy, and here dx by x will be equal to dy by y. So solution is integration of x dx minus y dy is equal to, I'll take this as k, say k, and here also integration of dx by x minus dy by y is equal to k. Okay, that's it. Now let's solve for this. So integration x is x square by 2 minus y square by 2 is equal to k, or x square minus y square is equal to 2k. I will take this as say c, because 2k is a constant, c is a constant for simplification. Okay, so one solution is nothing but x square minus y square. So one solution is x square minus y square minus c is equal to 0, and the other solution will be 1 by x is log x minus log of y. I'll take it as k. Now I'll take it as log of c. That's it, or log k, yeah, whatever. Okay, because k log c both are same constant. So what will happen here is log a minus b is log a by b. So log x by y is equal to log of c. Log and log cancels, so c is equal to x by y. Okay, or x minus yc is equal to 0 is one more solution. Fine. Therefore the solution for this is nothing but x square minus y square minus c into x minus yc is equal to 0. That's the solution. That's how it is done. That's it. I hope you clearly understood the solution. It's a very important question, so please don't miss it. They can ask the same problem in the examination, as this has been repeated many times. So solution is simple only, but you need to practice here. And integration also is very simple. There is nothing high-fi. So please practice it. Okay, because when you practice, you get confident, and confidence only happens when your pen moves always. Okay. See, there is one more problem like the previous one. Only difference here is everything is same. Only this is x minus 1. Okay. This also has been repeatedly asked question. We will solve this now. And here difference is x y p square plus x minus y into p, it is different question, minus x is equal to 0. So I can rewrite this as x, sorry, this is y, okay, y. So I can rewrite this as what? Y p square plus x minus y into p minus x is equal to 0. Again, this will be like, ax square bx plus c. So solution is x is equal to, or here p is equal to minus b minus x minus y plus or minus root of b square minus 4ac, so minus plus 4xy upon 2y. So this will be minus x minus y plus or minus root of, this will become x square plus y square minus 2xy plus 4xy 2y. So p is equal to minus of x minus y plus or minus, so write directly here. So x square y square plus 4xy minus 2xy to plus 2xy, so x plus y the whole square, so it will be x plus y. Simple, right? Upon 2y. So p is equal to minus x plus y plus x plus y upon 2y. Here x and x cancels, so this will be 1 by 2. Am I right? Y cancels, 2y, no, I think, yeah, 2y upon 2y. So yes, 1. So p is equal to 1. Simple. Next here, p is again equal to minus x plus y. Now it's minus. So minus x minus y divided by 2y. So here I think y cancels. So this will be minus x by y. So p is equal to minus x by y. Fine. What is p here? As I did earlier, dy by dx is equal to 1 and dy by dx will be equal to minus x by y. So dy by dx is 1 means y is equal to integration of 1 dx plus c. So y is equal to x plus c is one solution, or y minus x minus c is equal to 0 is the solution. And here if I cross multiply we get x dx plus y dy is equal to 0, or integration of x dx plus y dy, I'll take this as equal to say k. So integration x is again x square by 2 plus y square by 2 is equal to k. So x square plus y square is equal to 2k. I'll take this as c, because 2k is a constant, c is a constant. Make it simple, okay? Therefore we have x square plus y square minus c is equal to 0. So the solution for this will be y minus x minus c into x square plus y square minus c is equal to 0. That's the solution. That's all. It's easy only. Both the previous one and this one are important, so please practice it. It will be very helpful. Next is a very important repeated question from Clairaut's equation. Solve. This has been asked many times in examination. Listen. Solve px minus y into py plus x equal to 2p by reducing to Clairaut's form, taking the substitution capital X is equal to x square and y is equal to y square. Very important question. Okay, practice it 4 to 5 times, you'll get correct. So I solved it for you here. So please check how I solve it and please do practice it. Solve the equation, that is px minus y into py plus x equals 2p by reducing to Clairaut's form, and you are using a substitutions here. U is equal to x square and v is equal to y square. Okay, so they again use x square, v is equal to y square. So what you do first, we have to write everything in terms of u and y and solve. Make it to Clairaut's form. Okay, so du by dx will be now 2x here and dv by dy will be 2y. Fine. So my small p is nothing but I have to write small p in terms of u and v. So small p is dy by dx. Now dy by dx as a chain rule in terms of u and v can be written as dy by dv into dv by du into du by dx. See, this term dv cancel and what dv cancel, dy by dx remains. But we get in form of u and v. That is nothing but again, see, what is dy by dv? See, dv by dy is 2y. That is 1 upon 2y what I'll do, this dv by du, the factors first substitution, I will take this as capital P into this again 2x. That will be 2 cancels. We will get this as P into x by y. So therefore small p is equal to capital P into x by y, small x by small y. That implies small p is equal to capital P into, what is x? U is equal to x square. Fine. So u is equal to x square means what is x? X is equal to root of u divided by y, root of v. See, I have got in terms of u and v now. So let's put this in place of small p, we'll put this here. Where are p is that put? So it implies now we can write p, right? P is capital P into root of u by root of v into x. See here, into x. Again, what is x? So I'll write here better. That implies x is equal to root of v and y is equal to root of v. Okay, better. Fine. So p into, what is p? Capital P root u by root u by root v. X is root u minus y is root v into bracket again. P is root u by capital P root u by root v into y is root v plus root u, because x is root u, equals 2 into p into root u by root v. Now here take the LCM. See, u into is u, so p into u minus, take the LCM, root v, small v upon root v into, see this v and v cancels. See what remains, p root u plus root u. So root u is common here into capital P plus 1 is equal to 2p root u by root v. Again here compare both, is multiplied, so u, v cancels. So we have capital P into u minus v into p plus 1 equals 2p. Fine. That implies now we can write p u minus v is equal to 2p by p plus 1. Fine. So again I can write this equation in v form as this, because v is basically y, uv. So v form as nothing but, we can rewrite this v form as pu, capital Pu minus 2p by p plus 1. Now this is all capital, okay, p capital. Now this is what? Clairates. This is Clairates. And the Clairates equation, general form is y is equal to px plus f of p. And the solution for Clairates is y is equal to cx plus f of c. That means when you identify it as Clairates, px plus f of p, function f of p, what we do is you simply replace in place of p put c. That's all. So here therefore this is Clairates. So this becomes Clairates equation now. This is Clairates. So once it is Clairates, so what we do? The solution is v is equal to pu p c. What solution? In place of p put c. So it will be what? I take capital Cu, c into u, okay, minus 2c by c plus 1. So I will write in the standard form, because here they are given v as y square and u as x square. So the solution here will be now for Clairates will be, what is v? Y square is equal to c into x square minus 2c by c plus 1. That's the general solution for this question. Okay, a very important question, so please practice it 3 to 4 times so that you will be able to write in the examination. So very important. Okay, they may repeat the same question this time, as it has been repeated many times in the previous exam paper. Now the next question is solve dy by x plus y cos x plus sin y plus y upon sin x plus x cos y plus 0. I don't know, I just, it's not, I think it has asked only one time, so but It's easy question only. Solution I solve it, so please refer it. And one more question from Bernoullis. This also they might ask because they haven't discussed it all these years. They might ask, as we solve one, right? Y square secant x, same on that line. dy by dx plus y by x is equal to y square secant x. So please find a link in description below and please do solve it. The next problem is z is equal to e raised to ax plus by, f of ax minus by. Prove that b dou z by dou x plus a dou z by dou y is equal to 2abz. A basic problem from partial differentiation. This problem I have already solved. You can find the link in the description. Okay. See, the next problem is from total derivative. Very important question. This has been asked one time in the 21 scheme paper. I think in 2024. Okay. The problem here is if u equals tan inverse x by y, where x is equal to e raised to t plus e raised to minus t and y is equal to e raised to t minus e raised to minus t. Okay, x is equal to e raised to t minus e raised to, x is equal to e raised to t minus e raised to minus t and y is equal to e raised to t plus e raised to minus t. Find du by dt. A classical problem from total derivative. So the total derivative rule is, it says u x t. Okay, we can write it as du by dt equals dou u by dou x into dx by dt plus dou u, the partial derivative of dou y, dou u by dou y into dy by dt, the normal differentiation. That's the chain rule. Therefore, that implies we can write du by du over dt is equal to dou u by dou x. See, differentiate partially with respect to x, tan inverse x by y. What's the differentiation of tan inverse x? Differentiation of tan inverse x is 1 by 1 plus x square. Am I right? So this will be 1 by 1 over 1 plus x square. In place of x, it is x by y. X by y the whole square. Again, it's not plain x. In place of x, it is x by y. Again, derivative of x by y with respect to what? X will be nothing but into 1 by y. That's 1 by y as it is, derivative of x is 1 because dou u by dou x. Done. Dx by dt into dx by dt will be, see, this is minus differentiation of what is x? E raised to t minus e raised to minus t. Am I right? So dx by dt will be again e raised to t minus differentiation of e raised to minus t is e raised to minus t into minus 1. So this will become plus. Done. Plus dou u by dou y. So what is dou u by dou y now? Partially differentiate tan inverse y x by y with respect to y. Again, same. 1 plus x by y the whole square. Again, derivative of x by y with respect to y is x as it is. Differentiation 1 by y is minus 1 by y square with respect to y. Okay. Into dy by dt. Y is e raised to t plus e raised to minus t. So e raised to t plus differentiation of e raised to minus t is e raised to minus t to minus 1. So minus e raised to minus t. That's all. So let's simplify this now. So we have du by dt equals LCM is x square plus y square and this y will go top and into 1 by y into e raised to t plus e raised to minus t plus again 1 over x square plus y square. Here this y square will go top, go up and minus x by y square into e raised to t minus e raised to minus t. So obviously this and this cancels, this and this cancels. What remains is 1 by x square plus y square. See here x square plus y square is common. So we can write du by dt. Make it simple here, okay? Du over dt. Because see here, see x square plus y square is common both and this addition here. So you can write du by dt is equal to whole LCM. X square plus y square is the LCM common. And in here, this is e raised to t plus e raised to minus t, correct? Okay. And I think I made a mistake here. Okay. Implies du by dt is equal to, take the LCM here, this will be x square plus y square, all y square same only, into, see this y square will go top into 1 by y whole into e raised to t plus e raised to minus t. I am simplifying it, and here this would be again x square plus y square, here also y square goes top into minus x by y square into e raised to t minus e raised to minus t. Done? Okay, therefore now du by dt equals, see y cancels, square square cancels, then LCM is x square plus y square is the LCM, and what remains, e raised to t plus e raised to minus t into y, so y into, and minus x into e raised to t minus e raised to minus t. Perfect. Now let's put a value of x and y. What is y? E raised to t plus e raised to minus t. So it implies du by du over dt is equal to, what is y? E raised to t plus e raised to minus t into e raised to t plus e raised to minus t. Okay, minus x is e raised to t minus e raised to minus t into e raised to t minus e raised to minus t. Perfect. Right, upon x square plus y square, means x square, it will be x is e raised to t minus e raised to minus t the whole square into this will be again x square plus y square plus e raised to t plus e raised to minus t the whole square. Okay, this is what we have now. So let's simplify this now and let's see what happens. Now if we multiply this, we get du by dt is equal to du over dt. Little bit of work here. I think this will be, when I multiply this, this will become, oh sorry, this is x square plus y square, right? I forgot, sorry, x square plus y square, okay, plus y square. So this will be now e raised to 2t plus 1. I am directly, obviously this is e raised to t plus e raised to minus t the whole square, or I can do whole square also, no issue. Okay, I'll do whole square. This will be now e raised to t plus e raised to minus t the whole square minus e raised to t minus e raised to minus t the whole square whole divided by, shall I square it? Yeah, I'll square it here. So e raised to 2t, first I'll write it down, then I will square it. That will be easy, more easy. So e raised to t, let's go step by step, whole square plus e raised to t plus e raised to minus t the whole square. Am I fine? Okay. Now that implies again now du by dt will be, see this whole square, e raised to 2t, a plus b the whole square is a square plus b square plus e raised to minus 2t plus 2ab. Now 2 e raised to t and e raised to minus t is e raised to 0, that is 1, it is plus 2 minus again bracket, this will be e raised to t minus e raised to t the whole square. So e raised to 2t again plus e raised to minus 2t, correct? T minus 2t, but here minus 2 whole divided by is again will be e raised to 2t plus e raised to minus 2t minus 2 plus e raised to 2t plus e raised to minus 2t plus 2. So here if you see, so du by dt will be e raised to 2t plus e raised to minus 2t plus 2 minus e raised to 2t plus minus e raised to 2t plus 4 whole divided by, again here we have 2 cancels, so what remains here, 2 e raised to 2t plus 2 e raised to minus 2t, and here also see this cancels, e raised to 2t cancels, and this also cancels. Okay, sorry, this is 2, right? Minus plus 2. So 2 plus 2, 4. So we have du by dt is equal to nothing but 4 divided by 2 into e raised to 2t plus e raised to minus 2t. This is the answer. So I can write this answer in more simplified form. How, 2 ones are 2 twos are. Now you know your formula. The formula is, see, cos hyperbolic at is equal to e raised to 2t plus e raised to minus 2t by 2. Sorry, e raised to at minus e raised to minus at by 2. Right? So based on this formula, what I can do is, this I write as, so du by dt is equal to, based upon this, 2 by e raised to 2t plus e raised to minus 2t, that is nothing but 1 by cos hyperbolic at. Therefore that implies du by dt will be, what is 1 by cos? Secant hyperbolic. So secant hyperbolic at. That's the solution for this. So the answer for this question is simple way, secant hyperbolic at. That's it. Okay. We have one more very easy question from total derivative here. This has been asked in exam. See, we find dz by dt. So the question is, if z is equal to xy square plus y square, x is equal to 80, y is equal to 80, find dz by dt. Okay. See, we have one more simple and interesting question from total derivative here. That is, z is equal to xy square plus yx square, x is equal to 80, y is equal to 80, find dz by dt. So the total derivative rule is dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. That implies we have dou z by dou t. We have dz by dt is equal to dz by dt is equal to, see, dou z by dou x means partial differentiate is 20x. Y square as it is, x is 1 plus dou z by dou x, right? So 2x5, because difference x square is 2x into y. Dx by dt, derivative of x is 80, so x is 80, so derivative is only a, plus dou z by dou y, x as it is into difference y square is 2y, 2x5 plus x square as it is into 1 into dy by dt is nothing but 2a. Now let's put the values here. So we have dz over dt equals, what is y? Y is 280. That is, this will be now 280 square plus 2 into 80, x is 80 into 280 into a plus 2 into 80 into 280 plus x square is 80 square into 2a. That's it. Okay. So dz over dt will be now, expand it, 4a square t square plus 2 to the 4 a square t square into a plus we have 2 to the 4 a square t square plus a square t square into 2a. So this will be now dz by dt will be, now open the bracket, this will be 4a cube t square plus 4a cube t square plus 4 to the 8 into a cube t square plus, open a bracket now, 2a cube t square. I think all have the same coefficients, you can add it. Therefore that implies dz by dt is equal to 8, 16, 18. So 18 a cube t square. That's the solution. So this problem has been asked for 6 marks. So if problem like this come, please don't miss it. Okay. The next one is one more very important problem from the L'Hopital's rule. It says, evaluate limit as x tending to 0 sin x over x whole raised to 1 by x square. Very important question. So let's solve it now. Okay. So first we apply k here. So k is equal to limit as x tending to 0 sin x by x whole raised to 1 over x square. When I apply the limit here, sine by 0 is infinity, so we get infinity raised to infinity. In that case, we apply log on both sides, as we have seen in previous problems also. Limit as x tending to 0, log of sine x over x whole raised to 1 by x square. Now there is a property logarithm log a raised to k log a. So when I bring this down, this will be log k equals limit as x tending to 0. When I bring this down, this will be log of sine x by x into 1 by x square, so upon x square, because to apply the L'Hopital's rule we need a fraction, numerator by denominator. Now let's apply it and see. 0 log infinity 0 only, so we have 0 by 0. Now we can apply the L'Hopital's rule happily. So we have log k is equal to limit as x tends to 0. What does it say? Differentiate the numerator upon denominator separately. Derivative of log x by x, sorry, log sin x by x. Derivative of log x is 1 by x, so log sin x is 1 by sin x by x, correct? So 1 over sin x by x into, again it's a chain rule, because differentiation only log x is 1 by x, but differentiation of log sin x by x is 1 by x, that is 1 by sin x by x, into again differentiation of sin x by x, that is quotient rule. It will be, what is quotient rule? U by v rule, u by v, denominator square, denominator as it is, derivative of sin x is cos x minus sin x as it is into 1 upon denominator differentiation, x square is 2x. Now this is only one beautiful trigonometric identity for limits. It says limit as x tends to 0, sin x by x is equal to what? 1. Okay, so see, x tends to 0, sin x by x is 1. So that's it. Now I can rewrite this as, that implies log of k is equal to limit as x tending to 0, x cos x minus sin x by 2x into x square is 2x cube. Again 0, cos 0 is 1, 0 minus 0 by 0, that is 0 by 0. Again apply L'Hopital's rule. So we have log of k is equal to limit as x tends to 0, differentiate it, x as it is, product rule, differentiate cos x is minus sin x, plus cos x as it is, derivative of x is 1, minus derivative of sin x is cos x, upon derivative of 2x cube, x cube is 3x squared, 3 to the 6, so 6x squared. Again cos cancels, sin cancels, so this equals to limit as x tends to 0, we have minus sin x by 6x. So I can again rewrite this as log of k is equal to, implies log k is equal to limit as x tending to 0 minus 1 by 6 into sin x by x. And as you know, again sin x by x is equal to 1 because x tending to 0. Therefore we have log of k is equal to minus 1 by 6. That implies the answer is k is equal to e raised to minus 1 by 6. Beautiful solution. That's all. Okay, important question. So this is one question, and there is one more, I think, limit of tan x by x as raised to 1 by x square. You can solve that also. Okay, and also please refer the playlist and solve the other videos also. Those are also very equally important. Okay, the more you practice, because L'Hopital's rule is easy, it's a high chance question, high probability question. They will definitely ask the questions in this. Hopefully if they ask that a raised to x plus b raised to c raised to, then it's a jackpot. Please practice it 2-3 times and go, and don't miss that question. Okay, and this also you can practice it. Fine. So let's move on to the next question now. The next one is the problem on extreme values. Okay, I'll solve that here now. See, next we have a problem from maximum minima or extreme values. This problem has been discussed at least 3 or 4 times in the 21MAT11 question paper. So we'll solve it now. Please check how I'm solving it. Okay. Now the problem here is find the extreme values of the function x cube plus y cube minus 63x minus 63y plus 12xy. A very interesting problem on extreme values, maximum minima. So let's solve it. We have f of xy is given to be x cube plus y cube minus 63x minus 63y plus 12xy. Now the first step, what we do, we find stationary values. For that we fx, we find fx. What is fx? Partial derivative with respect to x. So this will be 3x square and minus 63 and plus 12y. Okay, see, derivative of x cube is 3x square, minus 63x is 63 only, and 12y into derivative x is 1. Then you find fy. So fy will be equal to 3y square minus 63 plus 12x. The next step what we are going to do is we equate fx is equal to 0 and fy is equal to 0. So we equate these two, and from this we find the ordered pairs to find the stationary values. We do that implies 3x square minus 63 plus 12y is equal to 0. That is 3 is common. X square minus 3 to the 6, 3 on the 3 plus 4y equals to 0, and that implies x square minus 21 plus 4y equals to 0. This is one value. One more value here is fy is equal to 0. We get 3y square minus 63 plus 12x is equal to 0. So here also 3 is common. So y square minus 3 to the 3 1 the plus 3 4 is equal to 0. We get this equation as y square minus 21 plus 4y is equal to 0. Now as we see that we cannot find any particular value of x and y from this both. So we will use our brains to club together and find a value. So what I can do is I can subtract it. So when I subtract, I get x square minus 21 plus 4y, that implies, alright, minus y square plus 21 minus 4y is equal to 0. So here what happens, see, 4y, 21 cancels. So we have x square minus y square is equal to 0, or x plus y into x minus y is equal to 0. So we get x plus y is equal to 0 and x minus y is equal to 0. Okay. So what we'll do, we'll take x minus y is equal to 0. So you can take x plus y also. We'll better take x minus y is equal to 0, so that implies x is equal to y. Now from this we need to find equation, to find the stationary values. So what I'll do, I'll assign this as say 1 and this as say 2 for simplicity. Okay. So here also I can write 1 minus 2, 1 minus 2. Okay. Gives, implies. Fine. Now when I let's put x is equal to y in say 1. When I put in 1 here, so x is equal to y means y square minus 21 plus 4y is equal to 0. Am I right? That means we have y square plus 4y minus 21 is equal to 0. So let's use a calculator here and find the values. So we have mode equation, this is number 3. So 1 equals to 4 equals to minus 21 equals to 3 and minus 7. So we have y is equal to 3 comma minus 7, 1 point. Okay. Next we'll put x is equal to y in say second. Again we'll get the same, I think. If I put x is equal to y here, we get x is equal to, there is no or I'll put y is equal to x. Okay, let's put y is equal to x. Because x is equal to y, y is equal to x. We get the same value. So we put y is equal to x here, we get x square plus 4x minus 21 is equal to 0. I think same value only, we get x is equal to 3 comma minus 7. Okay. So the stationary points here are stationary points. So we have only 2 stationary points here. Okay. Those are 3 comma 3 and minus 7 comma minus 7. Nothing else, correct? 3, 3, minus 7, minus 7 for both. Now with this, because see, even if you take one value 3, y is equal to 3, so x is equal, y is equal to 3, so x is equal to 3, y is equal to minus 7, x, because y is equal to x. Anyhow same only. Okay. Now what we do, we first find to check the conditions. As the conditions are, we'll see the condition later. First we'll find a. What is a? A is equal to f double x. That will be fx is here. See, this is fx. We'll see, take this into consideration, fy, not the below one. Okay, fx is here. So fx is 6x. Correct. done. F B is f x y, that is f x with respect to y, so only 0 0 only 12, and C is f double y. F double y would be 6y. Now we make a table. Table is like stationary points are 3 comma 3 and minus 7 comma minus 7. So let's make a table here. Okay, this one, this one. Now here we have A. What is A is equal to? A is equal to 6x. Okay, A is equal to 6x. B is 12. C is equal to 6y. We need AC minus B square. Because why? See, for the maximum minimum for function of two variables, the condition is if AC minus B square greater than 0 and if A is lesser than 0, and then at that point the function has maximum value. If AC minus B square greater than 0 and if A is greater than 0, at that point the function has minimum value. But if AC minus B square is lesser or equal to 0, then it is irrelevant. It's don't care condition. Okay, we don't have any value at this. We don't take into account. That's all. So we check it here now. 6x, cx, y, x, y. Are you getting it? 3 means what? This is x, y, this is x, y. Okay. Now 6x, 6 3 is 18, 12 as it is 18. AC minus B square. So this will be 18 into 18 will be, I think 324, 18 into 18. Yeah, 324. So 324 minus B square, 144. Correct, 12 square is, so we have 324 minus, so 180. This is coming as 180. And 180 is what? Greater than 0. That means valid point. Okay, this is valid point. Next, again 6 7s are minus 42. X is 7 here, 60 minus 7, again 12. Again 6y minus 42. So minus 42 to 42 will be 42 square will be minus again this is 12 square, 144 is equal to 1620. This will be 1620, again greater than 0. But here see, it means I write here, this is valid condition, this is valid. Because why? AC minus B square greater than 0 is a valid condition. But here see, 18A is lesser than 0 and here, sorry, 18 is what? Tell me, it's greater than 0. And here minus 42 is lesser than 0. What's that? If AC minus B square greater than 0, A is lesser than 0, that point is what point? Maximum point. And if AC minus B square greater than 0 and if A is greater than 0, that point is what? Minimum point. So this is minimum value. This point has, minus 7 point has the maximum value. Therefore, the extreme values are two values. One is maximum, one is minimum. So we have F maximum is equal to F of minus 7 comma minus 7. That means in the question given, in place of x and y put minus 1 minus 1. So this will be now minus 7 cube plus minus 7 cube minus 63 into minus 7 minus 63 into minus 7 plus 12 into 7 7s are 49. Am I right? So minus, in place of x put minus 7, y put minus 7, minus 7 cube plus minus 7 cube minus 63 into minus 7 minus 63 into minus 7 plus 12 into 49. So let's 7 7 the 49 minus 1 minus 1. Let's calculate this and see the answer now. We have minus 7 cube equal to into 2 is equal to and plus 2 times, we can take, this is plus only, right? 63 into 7 is equal to plus 12 into 49 is equal to 784. So the maximum value here is how much? 784. So 784. You can just verify in your calculator and see. Okay. 784. Then we have the f minimum is f at minus f at 3 comma 3. That will be, I'll put a 3 cube right directly, 3 cube plus 3 cube minus 63 into 3 minus 63 into 3 plus 12 into 9. So let's check this answer here. How much you get? So it is we get 27 plus 27 minus 2 times 63 into 3 minus 2 times 63 into 3 plus 12 into 9. So minus 216 is the value, minus 216. So we have the maximum value occurs at minus 7 comma minus 7. Sometimes this question they repeat like this also. Show that for the function f for f of xy is equal to x cube plus y cube minus 63x minus 63y plus 12xy, the maximum value occurs at minus 7 comma minus 7. Okay, so f maximum is 784 and f minimum is minus 216. That's all. That's the solution. Okay, I hope you clearly understood this. That's how it works. But such problems need practice. So if you practice, you'll get a better understanding of how to solve these problems. Okay, done. So we solve many questions from the ODE, ordinary differential equation, that is Newton's law of cooling and Clairaut's and all other things. So and also solve for P and all. Apart from this, there are some more questions. So please check it out. These are also very important. They can be asked in the 21MAT11 examination. So first one is solve dy by dx minus dx by dy is equal to x by y minus y by x. Very important question. So I have done the solution here. Please check it now. Now the next problem is, see, very simple question. This also they have repeatedly asked. Solve we have it as px. So it is what solve p is equal to sine of y minus xp. Find singular solution. Singular solution. Okay. So the problem here is solve p is equal to sine of y minus xp. Find a singular solution. A very simple question, interesting question from Clairaut's differential equations. Okay. So we have p is equal to sine of y minus xp. So we'll make it a Clairaut's form. We can write y minus xp equals sine inverse p, right? So that implies y is equal to px plus sine inverse p. This is what Clairaut's. This is Clairaut's equation. So Clairaut's equation general form is what? We have y is equal to px plus f of p. See, this is f of p. Px is the f of p. Okay. Now as we found it is Clairaut's equation. So the general solution is, so a simple thing, general solution is Clairaut's is what? In place of p put c. So cx plus f of c. That is gs will be now y is equal to cx plus f of c. F of p is sine inverse p. So f of c will be sine inverse c. So let's underline this to get the marks. Up till here 3 marks. Now after finding the general solution, we need to find singular solution. To find singular solution, we differentiate with respect to c. That is 0 is equal to x plus 1 by root of 1 minus c square. That implies x is equal to minus 1 by root of 1 minus c square. So x or c whatever, so since question is directly x is there, so we found x here. So when you put a value of x here in this return in this GS, we get a singular solution. Therefore singular solution is y is equal to nothing but what is x? C into minus 1 upon root of 1 minus c square. 1 minus c square. Okay, plus sinus c. That's all. This is the singular solution. That's the answer. So this is an answer on 6 marks. Fine. This one question is there. Okay, so that's one question. One more question is that on reducibility exact form. Very important question. The question is, it says solve y into y plus x dx plus x plus 2y minus 1 dy is equal to 0. Okay. So the problem here is solve y into y plus x dx plus x plus 2y minus 1 into 2y minus 1 dy is equal to 0. So this looks like an exact differential equation. Let's check it. So we have m is equal to y square plus xy. We have n is equal to x plus 2y minus 1. So dou m by dou y is equal to 2y plus x. Dou n by dou x is equal to 1. That means dou m by dou y is not equal to dou n by dou x. So not exact. If it is not exact, then what we do? We find a difference, dou m by dou y minus dou n by dou x, and that will be x plus 2y minus 1. And this is what? Close to, near to what? Close to n. This is m, close to n. Yeah. If it is close to n, then find 1 by n dou m by dou y minus dou n by this technique here. So what is n here? X plus 2y minus 1 into, the difference also same, x plus 2y minus 1, that is equal to 1. That is taken as f of x. So from this we evaluate the integrating factor. Integrating factor is a value which when multiply the question makes it exact, and we get a solution. That is integration of m dx plus integration n y dy is n only y dy is equal to c. So we have here as integrating factor is equal to e raised to integration of f of x dx, e raised to integration of 1 dx, that is e raised to integration of x. So we have our integrating factor here. So underline it. So once you get an integrating factor, let's multiply the question. So it implies the question is now e raised to x into y square plus x e raised to x into y into dx plus x e raised to x plus 2y e raised to x minus e raised to x dy is equal to 0. So the solution here is integration of m dx plus n dy. So I'll better write it here now, because this is exact, this is what exact, and for exact the solution is integration of m dx plus integration of n only y dy is equal to c. N only y terms. See, there are no plain y terms here. 2y e raised to x is there, but only I need only y terms are constant. Otherwise, leave it. So we have, that means solution is integration of y square e raised to x dx plus, again let's separate it, y outside into x e raised to x dx plus integration of 0 dy is equal to c. Why? Because see, there are no plain y terms here. n bracket y means n only containing y terms or constant, no x terms allowed. If there is plain y to y, then I would have taken it, but x is associated, to leave it. So we have y square into integration of e raised to x is e raised to x only plus y as it is. Now see, integration of x e raised to x should be what? Integration by parts or Bernoulli's. So we have x as it is, integration of e raised to x only minus differential x is 1 into integration e raised to x only plus c. So the final answer is implies e raised to x y square plus xy e raised to x minus e raised to x into y plus c. That's the solution. So we have this as the solution. That's all. Or equals to c, sorry, equals to c, right? Yeah. Or minus c to 0 or equal to c. This is the solution what you have for this. Very, very important question. Please practice it. Now coming to the module 4, a very, very important scoring module. If you do this, 100% pass, but you have to do it, okay? Don't skip this module. And as a brief to you about from this module, now I cannot tell you what is important or not, but I can solve some questions to make it perfect. That's what I can do. So please, some question may repeat, but not guaranteed, because this, higher order differential equation is a very, very vast topic. You can frame lakhs of questions over there. Some questions on variation parameter may repeat, I will tell you that. So apart from that, I will solve some questions here. Please practice along with me so that it become perfect. So the first question is, this two questions now they have been repeated, normal CF question type, synthetic division. The question is, solve 4d raised to 4 minus 8d cube minus 7d square plus 11d plus 6 into y is equal to 0, and 4d raised to 4 minus 4d cube minus 23d square plus 12d plus 36 into y is equal to 0. My request is to please, this is high probability questions, they can ask this time in the examination. Solution is there, check in description, please, and or for the playlist, you need to solve it or practice it, okay? I explained in a very, very easy way. The next question, see, here it is d cube y by dx cube plus 2d square y by dx square plus dy by dx is equal to e raised to minus x. Okay. See this question. What I can do first, I write in d form. D cube y by dx cube is d cube plus 2d square plus d is equal to e raised to minus x. Again, we need to find the complementary factor. We need to find the auxiliary equation. We write d as m cube plus 2m square plus m is equal to 0. So m into m square plus 2m plus 1 is equal to, very simple. So we have 3 roots. M cube means, d cube means 3 roots should be there. Be careful. 3 and m square plus 2m plus 1 means m plus 1 the whole square is equal to 0. So m is equal to 0 comma minus 1 comma minus 1. These are the roots. So the roots we can write CF, very important to get a mark. C1 CF for 0 it is C1 e raised to 0 is C1 plus. If the roots are repeated, then it will be C2 plus C3x into e raised to minus x. Underline the CF. Please, that's why I am telling you, please refer the theory from a playlist. If you are new to this channel, please refer it. Even if you don't have the basic knowledge, don't know anything, you will clearly understand how it works. Otherwise, very difficult. Please do it, because my teaching way is different. If you understand the way I taught over there, even if you solve only one problem enough, you can solve any question like this. That's all. Now let's find yp. So we have yp is equal to e raised to minus x divided by d cube plus 2d square plus d. Again, let's go to theory now. Type number 1. If the numerator is of the form of e raised to x upon f of d, is type number 1. In type number 1, we replace denominator or dy. What is a here? E raised to minus 1x. A is 1. So replace d by what? Or denominator a by d by minus 1. So we have e raised to minus x divided by minus 1 plus 2 minus 1. Correct? See, minus 1 whole cube minus 1 plus 2 into minus 1 square plus 1 only plus minus 1. 2, this cancels. Now it is 0. Now in type number 1, go to the theory and see what I get. In type number 1, if after replacing, if the denominator is 0, what type? If the denominator is 0, then what to do? Replace the numerator, multiply the numerator by x and differentiate the denominator. Differentiate d cube is 3d square plus 4d plus 1. Again replace d by what? Minus 1. See what we get. Again x e raised to minus x divided by 3 minus 4 plus 1. Again 3 minus 4, 0. Again denominator 0. Again if denominator 0, again what to do? Again multiply numerator by x. And again differentiate denominator. Again from d cube plus 2d square plus d, I got 3d square plus 4d plus 1. Simple differentiation. Again differentiation of d cube is 60. D square is 2d, 6 plus 4. 1 is 0. Again replace d by minus 1. So the final answer is x square e raised to minus x divided by 6 into minus 6. See, 6 into minus 1 is minus 6 plus 4 minus 2. That's the particular integral. So the solution is CF plus PR. So the solution you can write it as, so write the complete solution. Solution is y is equal to CF plus PR. So solution will be C1 plus C2 plus C3x into e raised to minus x square e raised to minus x divided by 2. Okay, by writing such, you will get a full marks desired. That's the solution. 6 marks question. Understood how to find? That's okay. See, the next question is here. Right here itself. D square y by dx square. Yeah, d square y by dx square minus 6 dy by dx minus 6 dy by dx plus 25y equals e raised to 2x plus sin x. This is a problem we have. So what is that? D square by dx square minus 6 dy by dx plus 25y is equal to e raised to 2x plus sin x. So we let's find the CF here. So we have d cube minus 6. It is, oh sorry, it is d square y. Okay, d square minus 60 plus 25 into y equals e raised to 2x plus sin x. This will be m square minus 6m plus 25 is equal to 0. So there are two roots. So it's better use the calculator here. I hope you know it. So we go to mod, then we go to equation, then 3 x square b plus c. We put a constants here. A is 1 minus is equal to minus 6 is equal to 25 is equal to, so 3 plus or minus 4i. M is equal to 3 plus or minus 4i. That implies the complementary factor is equal to, if the imaginary conjugate form, we write as C1 cos of 4x plus C2 sin of 4x whole into e raised to 3x. That's it. And please do underline it if you want to get the step markings. Okay. So we have CF. Now YP. YP is a particular integral is equal to e raised to 2x plus sin x whole divided by d square minus 60 plus 25. Always I keep on telling you, when there is plus or minus sign in numerator, always separate, because each individual has its own distinct particular integral. Okay, so it will be e raised to 2x divided by d square minus 60 plus 25 plus sin x by d square minus 60 plus 25. Fine. Again, this is what? Type number 1. Why? Because e raised to ax upon f of d. E raised to ax upon f of d. Type 1. This is what? Type 1. Okay. Alright. This is type 1. And sin ax 1x, sin 1x, sin ax upon f of d. This is what? Type 2. So what we do in type 1? We discussed here, right? Type number 1, if numerator is e raised to x upon f of d, replace all denominator d by a. A is 1, it is here 2, so replace all d by 2. And here in type 2, lend your ears to me. Please, my request is, if you want to get full marks, please go refer the playlist and refer the videos over there, where I have given all the theories of type 1, type 2, type 3. Theory of type 2 says, if the numerator is sin or cos x upon f of d, always replace in the denominator only d square. Listen carefully, lend your ears. Only d square, don't touch the d's, don't touch the d's. Getting it? Replace only d square by minus a square. By minus a square. Getting it? So that means here a is what? Sin 1x. So minus 1 square is minus 1. Again, don't take d and 1l. So only d square, don't touch the d. See what I am doing it here. So that implies yp is equal to e raised to 2x divided by c. Replace d by 2. 2 square 4 minus 6 to the 12 plus 25. Am I right? 4 minus 12. Yeah. And here sin x square. What I told, replace only d square by minus a square, minus bracket 1 square. If it was sin 2x, then minus 4. In place of d square, put minus 1. So minus 1 minus 6d plus 25. In place of d square, we are putting what? Minus 1. So we get here as e raised to 2x divided by 4 minus 12 is minus 8 plus 25 is 17. Am I right? Okay, correct now. Yeah, perfect. 13 plus 17. Next, here rewrite this as plus sin x by, this is done. Solving differential equation remaining already is, this work is done. Now see here, 25, always denominator take positive term first. What I am telling you, 25 minus 24, so 24 minus 60. Again yp is equal to, see in type number 2, this first one work is what type 1. In type number 2, the denominator needs to be always a d square term. If there is no d square term, then rationalize. Because in type number 2, we replace always d square minus s square, so denominator need to have a d square. So here plus sin x by 24 minus 16, so no d term, d square term. So what you do, rationalize. What is the rationalizing factor of 20 a minus b? A plus b. So this will be 24 plus 60 by 24 plus 60, that is equal to e raised to 2x by 17 as it is, plus 24, I will open the bracket here, 24 sin x into 6d sin x plus 6d sin x whole divided by, this will be 24 square minus 24 square minus 36d square. Am I right? 24 a plus b minus b, 36 d square. Again replace, I got d square here. Again replace d square by minus 1, same thing. So we will solve this using calculator on here. So this is become, this will be yp is equal to e raised to 2x by 17, and this will be plus 24 sin x. And remember one more thing in theory, if there is d in the numerator, always differentiate. If d in the denominator, always integrate. So 6 into d sin x, 6 as it is, d sin x, d means dy by dx, dy by dx sin x is differential sin x cos x. So this will become plus 6 cos x. Understood? Upon this will be 24 square is 24, 24 square is equal to 576. So this will be 576, right, directly here 576, this will be 576, minus 36 into minus plus 36, plus 36, 576 plus 36 is equal to 612. So yp is equal to now e raised to 2x by 17 and 24, let's simplify this further, 24 divided by 612, because let's match the answer to the answer key or the answer sheet of the examiners, so that they give full marks, full 67 marks. So this is 2 by 51, 2 by 51 sin x, and 6 divided by 612 is equal to 1 by 102 plus cos x divided by 102. That's all. Okay. Therefore, solution y is equal to c1 cos of 4x plus c2 sin of 4x whole into e raised to 3x plus e raised to 2x by 17 plus 2 sin x by 51 plus cos x by 102. Yeah, that's the, I think I mixed something here. 6 cos x, right? D into, yeah, 6 cos x plus 6 cos x by 102. That's the answer. So we have the solution here. That's all. Okay, I hope you got it clear. Fine, it's done now. Let's solve the next question now. So next question I'll solve here only. Let's say, let me solve it here. Okay. So next problem is, see, solve. It says d cube y by dx cube, sorry, d square y, it is d square only, okay, d square y by dx square plus 3 dy by dx plus 2y equals x square plus 3x plus 1. This is the question now. So let's solve it. Now again we have d square plus 3d plus 2 into y is equal to x square plus 3x plus 1. Now the CF will be m square plus 3m plus 2 is equal to 0. So let's better use the calculator here. Okay, this is very simple only, but we'll use calculator. So mod equation 3, 1 equals 3 equals 2 equals to minus 1 and minus 2. So we have m is equal to minus 1 comma minus 2. So CF is equal to C1 e raised to minus x plus C2 e raised to minus 2x. You are going to get marks for this CF. So please don't forget to underline. Okay. Now yp is equal to x square plus 3x plus 1 divided by d square plus 3d plus 2. Now in my theory and in previous solutions, the most easiest way of solving this is division, most easiest way. So how to divide? So numerator is from big to small, that is, this is correct as it is, x square plus 3x plus 1, and denominator from small to big. Getting it? What? Numerator descending order like x square, 3x, 1, so on. Denominator ascending order in terms of constants and d, constant d square, d cube, so on. So this will be 2 plus 3d plus d square. Now simply divide it. So I divide here only. This is x square plus 3x plus 1 whole divided by 2 plus 3d plus d square. Am I right? Okay. So now see simple logic. Very simple logic here. Understand first term by first term. X square by 2. First, see, I need to cancel the first term. 6 divided by 2, 2 3 is 6. What do you do? 6, 2, 2 3 is 6. Cancels, right? Same way. See, I want to remove x square. So what is the concept here? To remove x square, first term by first term. So what happens? X square by 2. So 2 into x square by 2 x square. Now keep on multiplying everything. 3d into, you can do the rough face also backside. Okay. 3 into 3d into, see what I have, 2 into x square by 2 x square only, then 3d into x square by 2. 3d into x square by 2 will be 3 into, what's that? D means differentiation. As I told you, difference in x square is 2x by 2, it is 3x. So plus 3x, again d square into x square by 2. So d square into x square by 2 will be again differentiate 2 times. So first differentiation is 2x by 2 ones are, and if x is 1, so on. And that's all. So this whole thing becomes 0. And that's it. So there is nothing left here. So solution is yp is equal to, very simple solution, x square by 2. Therefore solution y is equal to c1 e raised to minus x plus c2 e raised to minus 2x plus x square by 2. That's all. This is a solution. Very easy one. So apart from this, I request you to please refer the other videos here. The links are given in description, or just visit the playlist and you will find all the 4 to 5 videos on the theory and different types, type 1, type 2, type 3. If you solve this problem now, I guarantee you enough, you can solve any problem given in differential equation, I bet you. Okay, so please do that. So the next very high scoring area is variation of parameters. Compulsory there will be a question on it. So I'll solve some questions here. I'll give some questions. They're very important. Practice it. For this, you need to know some integration. So even if you don't know, please try to solve these problems. Check, see how much ever you can understand it. Okay. So the first problem is solve by variation of parameters dy by d square by d square plus y is equal to secant x. And the second is d square into y is equal to tan x. These questions have the higher probability of asking in the examination. This time you can also practice it. The solution is given. Please find the link in the description below. So one more problem based upon this is solve by variation of parameters. That is, see, the problem here is solve by variation of parameters d square by dx square minus 2 dy by dx plus 2y is equal to e raised to x into tan x. a very important problem in the variation of parameters. Now first we write a d form, so d square minus 2d plus 2 into y equals e raised to x into tan x. So next we need to find the CF, so we find the roots here. We write auxiliary equation m square plus 2m into plus 2 is equal to 0. So let's make use of the calculator here. We have home, then we go to the equation mode, then we have polynomial. Okay, 1 equals minus 2 equals 2 is equal to 1 plus or minus I. We have m is equal to 1 plus or minus I here. Therefore, the complementary factor will be c1 cos of x plus c2 sin of x whole into e raised to this real 1x. So let's open a bracket. So we have CF is equal to c1 e raised to x into cos x plus c2 e raised to x into sin x. Now, we discussed the method of variation parameters in earlier problems also. The solution is given as y is equal to ay1 plus by2. We don't find any pi and all here, so we find the solution as totally ay1 plus by2. Okay, the solution totally depends upon the complementary factor. So here y1 is e raised to x cos x and y2 is e raised to x sin x. Okay, now you find a very important factor called as Wronskian, that is w. W is equal to determinant y1 y2 dash minus y2 y1 dash. So we will find here now. So we have w is equal to, what is y1? It's e raised to x into cos x into y2 dash. Differential of e raised to x sin x will be e raised to x into cos x product rule plus sin x into e raised to x. Then minus we have y2 into y1 dash. What is y2? E raised to x into sin x into again differential of this e raised to x cos x will be e raised to x into derivative of cos x minus sin x product rule plus cos x into e raised to x, and that will be w is equal to e raised to x e raised to x into e raised to x is e raised to x into cos square x plus e raised to 2x into sin x cos x minus, again see minus into minus is plus, e raised to 2x sin square x minus e raised to 2x sin x into cos x. Okay, I hope you got it till here. So now here this term cancels, so w is equal to e raised to 2x. Why? Because e raised to 2x into bracket cos square plus sin square is 1, therefore w is equal to e raised to 2x. So please do underline the w. Now the formula, see we need to find a and b to get a solution. To find a and b we need w. So the formula for a is always minus integration of phi of x into y2 whole divided by w dx. Okay, so let's put it here. Minus, what is phi of x? The right hand side, e raised to x into tan x into, what's y2 here? Y2 is e raised to x into sin x over w is e raised to 2x. Now see, e raised to x into e raised to x is e raised to 2x, because e raised to a into e raised to b is e raised to a plus b, and this whole cancels. So what remains? A is equal to minus tan x into sin x dx. So how do we integrate this? So whenever there is tan x, we write this as sin x by cos x into cos x dx. Into sin x dx. Now, as you know, sin x into sin x is what? It's sin square x. So we have here minus integration of sin square x upon cos x dx, and that can be written as, see what is sin square x? Our main aim in solving the integration problem is to separate so that I can get standard forms of integration. So sin square x is nothing but 1 minus cos square x by cos x, right? Now we can separate, so it implies a equals minus 1 by cos x. See, when I separate it, I do it directly 1 by cos x. See, minus into 1 by cos. What is 1 by cos? Secant. So secant x dx, minus into minus plus, open bracket, cos square by cos is cos x dx, plus I will take k1, constant of integration. Now a well-known integral. Integration of secant x is always log secant x plus tan x. What's that? Integration of secant x is log secant x plus tan x. So we have minus log secant x plus tan x, and integration of cos x is, as you know, very simple integration, sin x plus k1. So we have found A here. Again, do please underline it. Okay. Next, after finding A, we will find B. B will be, I think, simple. So integration of phi of x into y1 by w dx. So B will be equal to, what is phi of x again? E raised to x tan x, e raised to x into tan x into into y1. What's y1 here? It's e raised to x into cos x. E raised to x into cos x dx whole divided by e raised to 2x. Now again same process, e raised to x, this cancels. We have b is equal to, again we write, when we have tan x term, we write it as sin x by cos x into cos x, and this will be very easy integration because cos cancel, and integration sin x is nothing but minus cos x plus k2. So we have both the values of a and b here. Now do nothing, simply the solution is, that implies solution is y is equal to a y1 plus b by 2. So what is a? Bracket minus log of secant x plus tan x plus sin x plus k1 into a y1. What's y1? E raised to x cos x, e raised to x cos x plus b into y2. What is b? Minus cos x plus k2 into, what's y2? E raised to x sin x. That's the solution. That's all. Please underline all the solutions. Okay, I hope you clearly understood this. That's the solution. Done? See, another very interesting problem here which I discussed in the previous papers of 21MAT11. Okay, let's solve it here. The problem given is solve by the variation of parameters, discover by dx square minus 2 divided by dx plus y is equal to e raised to x by x. So first, as usual, we write in d form, d square minus 2d plus 1 into y equals e raised to x by x. Now the CF, m square minus 2m plus 1 is equal to 0. This will be m minus 1 the whole square is equal to 0. Very easy thing. So m is equal to 1 comma 1. Right? So we have found our roots here now. The CF will be, see here in variation of parameters, be careful about the roots and the CF. Because the entire solution depends on the CF. The CF goes wrong, then the whole solution is waste. So CF is equal to now C1 plus C2x into e raised to x for repeated terms. Okay. So again we rewrite this as, open a bracket, C1 e raised to x plus C2x e raised to x. Therefore solution y is written as ay1 plus b y2. Here y1 is e raised to x and y2 is x e raised to x. Fine. Next what? We find Wronskian w, that is y1 y2 dash minus y2 y1 dash, and that will be e raised to x as it is into y2 dash is differential of x e raised to x, that is product tool, x as it is, derivative e raised to x e raised to x plus e raised to x as it is, derivative x is 1 only, minus y2 is x e raised to x as it is into differentiation of e raised to x is e raised to x only. Okay, so that will be x e raised to 2x, open a bracket, e raised to x into e raised to x is e raised to 2x plus again e raised to 2x minus x e raised to 2x. This cancels, we have w is equal to e raised to 2x. Okay, this is my w. Underline it in the examination. The next is to complete a solution we need a and b. For that we find w. The a formula is minus integration of phi of x into y2 whole over w dx. That will be a is equal to minus integration of, what is phi of x? The RHS, that is e raised to x by x. What's y2? y2 is x e raised to x upon w is e raised to 2x, what I found out. And this is going to be very simple integration. Okay, I'll add dx here. See here x cancels, e raised to x into e raised to x, e raised to 2x upon e raised to x cancels. What remains is 1. we have a is equal to integration of 1 dx, and integration of 1 is x plus c, or I will take this constant as say k1. Okay, we found a here. Now let's find b. B is equal to again integration of phi of x into y1 divided by w dx. That is equal to integration of, what is phi of x? E raised to x over x into, what's y1 here? It's e raised to x over e raised to 2x upon w dx. Again cancels, what remains? 1 by x. So b is equal to integration of 1 by x dx. Again a very simple integration. So b is equal to, what's integration 1 by x? Integration of 1 over x is log x. Okay. Plus constant is secant. Therefore the solution would be a is equal to, solution is y is equal to, we have a y1 plus b y2, and a is x plus k1 into, what's y1? It's e raised to x plus b into y2 log x plus k2 into x e raised to x. That's it. This is the solution we obtained. A very simple, clear? I hope it's absolutely clear. Done. See, the problem here is solve x square y double dash minus 4x into y dash plus 6y is equal to cos 2 log x. So if you identify the problem, it's clearly Cauchy's. Why? Because a special equation of the form x cube y triple dash plus x square y double dash plus x into y dash is Cauchy's. Here again x square y double dash x into y dash and y, a differential equation of the form Cauchy's. In Cauchy's, what we do, we first x, we put log of x equals to t. That means x is equal to e raised to t. Okay. Right side everything we make in terms of t. Now LHS always x square means, see, x cube y triple dash means d minus 1 d minus 2, x square y double dash means d minus 1 2 terms, x y dash means dy. That's all. Okay. So x square y double dash means we write it d form as d into d minus 1 minus, I write it like this, into y, and minus 4 into x y dash means dy plus 6 into y is equal to cos of 2. What's that? I told, put log x is equal to t. So right side every term becomes in terms of t. Let's simplify this now. So this will be d square minus d minus 4d plus 6 into y equals cos of 2t. That's d square minus 5d plus 6 into y is equal to cos of 2t. So we'll find the roots here. To find the CF, plus 6 equals 0. So it implies when you use the calculator, you can do directly, or you can use the calculator here. We have 1 equals minus 5 equals 6 equals, we have 1 equals minus 5 equals 6 equals 3 and 2. So we have m is equal to 3 comma 2 or 2 comma 3 other roots. That means the complementary factor will be c1 e raised to, see, both are different roots. So if the roots are different, we write e raised to 2. See, we are used to taking x here always, but right side is t. Be careful, it's what? T here. So it will not e raised to x, it will be c1 e raised to 2t plus c2 e raised to 3t. This is the complementary factor, underline it. Okay, now we find a yp. The particular integral will be yp is equal to, what's that? Cos 2t whole divided by cos 2t over d square minus 5d plus 6. Now, which type is this? D square minus 5d plus 6. Cos, sine or cos upon f of d means type number 2. Sine or cos upon f of d is type number 2. In type number 2, we replace only in the denominator d square by minus a square. Don't touch the d's. Agreed? What is a? 2. A is 2 here. So replace only d square by minus, understand, minus 2 square. It is minus 4. So in place of d square put minus 4. We have it as cos 2t whole divided by minus 4 minus 5d plus 6. Right? So this would become cos 2t divided by 2 minus 5d. Correct? 6, always take positive term first. Why I tell you? 6 minus 4 is 2 minus 5d. Now, type 2 says the denominator should always have a d square term. Always, because we need to replace d square minus a square. That's the concept here. Type 2 always we need to have a d square term. So there is no d square term here. Right? That means what we do, please you can refer my other videos also on this. I have explained the theory and other problems in a much more detailed way. Okay? Now, cos 2t upon 2 minus 5d, the denominator should have d square term. If there is no d square term, then what? Rationalize. That is, we write this as, that implies yp is equal to cos 2t over 2 minus 5d into, what's the rationalizing factor of 2 minus 5d? It's 2 plus 5d divided by 2 plus 5d. And that will be equal to, open the bracket now, 2 cos 2t plus 5d cos 2t whole divided by 4, see a plus b, a square will be square, so 4 minus 25 d square. Again replace simply lastly d square by minus 4. So the final answer here will be yp is equal to 2 cos 2t. So now see, into d means what? See, there is d here, into d. Solving any differential equation means removing all the d's. Into d means differentiate, upon d means integrate. So into the differentiation of cos 2t is minus 2 sin 2t. So this will be minus 5 to the 10 sin 2t. I hope it's clear upon. Now here I replace in place of d square, put what? Minus 4. So I do write directly here. 25 into minus 4 is I think 25 4 is a 100. So plus 100. So 4 plus 100 is 104. That's it. Done. Now I can write it in more simplified way. I'll write it, so that implies yp is equal to, what's that? That implies yp is equal to so 2 by 104. Let's see what happens. 2 divided by 104, 1 by 52. So we have cos 2t by 52 minus 10 divided by 104, 5 minus 5 by 52 sin 2t. Therefore, the solution y is equal to what? Cf plus pi. So we write it now. Cf is c1 e raised to 2t plus c2 e raised to 3t plus, this will be cos of 2t over 52, correct? And minus 5 sin 2t over 52. That's the solution. But since the problem is given in terms of x, the solution also need to be in terms of x. So the exact solution now is, so you have to use appropriately either log x equal to t or x is t. So replace properly. See, e raised to t. X is e raised to t. So e raised to 2t. I need everything in terms of x square. Here only, see, we have this solution right here. We have assumed it here. So from this we have to choose. E raised to 2t. E raised to t. So what is e raised to t? X square. So we have the solution as c1 x square plus c2 x cube. And what is cos 2t? T is log x. So we have plus cos of 2 log x over 52. Okay. Cos of 2 log x over 52. And this will be minus 5 of sine of 2 log x over 52. That's the solution. That's all. Okay, this is how we write it. So lastly, in the solution, we will replace all the t's by x. That's all. I hope it's perfectly clear. Okay. Now see, there is one more problem here from Cauchy's differential equation. X square y double dash, that is d square by dx square minus x y dash minus 3y is equal to x square. So again what you do, you put log of x equals t. That implies x equals e raised to t. Right? Now x square into d square over d x square, or x square y double dash is written as d into d minus 1 into y minus dy xy dash minus 3 into y equals x square. X square. X is e raised to t. So right side whatever the available variables should be in terms of t only. X square e raised to t. That means what? E raised to 2t. Am I right? Okay. Now simplified. So we have d square minus d. Again see d square minus t minus 2d. I can do directly here. See d square minus t and there is minus t here. D square minus 2d minus 3 whole into y equals e raised to 2t. So let's find the CF here. We have m square minus 2m minus 3 equal to 0. That implies the roots are, so let's see the calculator. We have 1 execute minus 2 execute minus 3 execute minus 1 and we have it as 1 minus 2 and minus 3. So root as 3 and minus 1. So m is equal to 3 comma minus 1. So the complementary factor will be C1 e raised to, again right side is t. So e raised to 3t plus C2 e raised to minus t. Okay. So please underline it. Fine. Now we found the CF here. Particular integral yp is equal to e raised to 2t whole divided by d square minus 2d minus 3. Now again this is what type? Type number 1. In type number 1 the numerator is of the form of e raised to ax upon f of t. Okay, that is here see e raised to x upon f of d. What we do? In type number 1 we replace denominator all the d's by a. Which a? See this a. Okay, e raised to at. So here replace all the d by what? 2. So we get e raised to 2t whole divided by 4 minus 3. Am I right? 2 square 4, 2 to the 4 minus 3. Very simple problem. So we had this as minus e raised to 2t by 3. So the solution is y is equal to CF plus pi. So C1 e raised to 3t plus C2 e raised to minus t minus e raised to 2t over 3. That is now the final solution we need in form of x only. See again choose appropriately. E raised to t is x. E raised to 3t is x cube. So C1 into x cube plus again here e raised to t is x. E raised to minus t will be 1 by x. See, use the mathematics. So C2 over x minus again x square by 3. That's it. A very beautiful and simple solution to the problem here. And this carries around 6 marks in the examination. I hope you clearly understood perfectly. Okay. We have one more very interesting problem here. Solve 1 plus x the whole square d square by dx square plus 1 plus x divided by dx plus y is equal to 2 sine log of 1 plus x. So as you see here clearly, it is a form of Legendre's differential equation. That is the form of ax plus b the whole square y double dash plus ax plus b y dash plus y is equal to 5x. Now here, if you see carefully, see ax plus b. This is of the form, what is that? Ax plus b. Okay, see a is 1 here. A is what? 1 here. Okay, now a is 1. So what we do is simply ax plus b. Okay, if it is 1 plus 2x, a is 2 here, 1 plus x is there, ax is 1 here. Now, in Legendre's what we do, in Cauchy's we put simply there is nothing, say simply plain x square, x cube terms are there, we put log x is equal to t. In Legendre's we put what? Log of whatever, 1 plus x is equal to t. That implies 1 plus x equals e raised to t. That's it. Okay, this is used on the right hand side. Now, in Legendre's 1 plus x the whole square, that is a plus b the whole square y double dash written as a square into d minus 2 in, d minus 1 into y. Get it? Square ax plus b the whole square y double dash means a square into d minus 1 into y. That's it. Okay. That means what is a square? 1. It will be d into d minus 1 into y plus this simply dy. A is 1 plus y equals 2 sine of log t. What is that? Log 1 plus x nothing but t. Yes. So let's simplify it here. So we have d square minus d plus y plus 1 into y equals 2 sine t. So now dd cancels, we have d square plus 1 into y equals 2 sine t. That means m square plus 1 is equal to 0. Okay, that implies m is equal to plus or minus I. Therefore, the complementary factor will be, see again right side is t here, so no x because we are used to writing x form. So right side is t, so write everything in terms of t. Later in the solution we will replace by x. We will see that later. First CF is equal to, for this one it will be simply C1 cos of t plus C2 sine of t. Okay. Please underline this. Fine. Now we have the particular integral yp is equal to 2 sine t over d square plus 1. Obviously this is type number 2. Sine or cos x upon f of d is type number 2. In type number 2 we replace in the denominator only d square by minus a square. Here a is sine of 1t. See a is 1 here. Sine of 1t, right? So a is 1. So we replace d square by minus 1 square, minus 1, minus bracket 1 square. Minus should be applied. So in place of what to do? So we have 2 sine t divided by minus 1 plus 1. In place of d square put minus 1, 0. Now when the denominator is 0, what's the concept here? We simply what? Multiply the numerator by here. If the denominator is 0, so that's why please refer the theory video on this in the playlist. Okay, the videos are all available, so please do refer them. It will be very helpful for clear understanding of how these things works. Now in type number 2, when after replacing d square by minus s, if the denominator becomes 0, then multiply the numerator by x and differentiate denominator. Here the variable is t, so multiply by t and differentiation of d square is nothing but 2d. That's all. So 2 cancels here. What remains is t as it is pre-multiplied upon d. See, upon d means what? Into d means differentiate, upon d means integrate. Okay, so integration of sine t dt, that is nothing but how much? We have it as, so yp is equal to t into integration of sine t is minus cos t. So the solution y is equal to what we have? C1 cos of t plus C2 sine of t minus t cos t. Now let's go to the final solution. We replace all the t's by x. What is t? Log 1 plus x. So we have C1 cos of log 1 plus x plus C2 sine of log of 1 plus x minus t. T is again log 1 plus x. Okay, log of, we have to choose appropriately, into cos of log of 1 plus x. That's the solution. That's all. So let's underline this. This is solution for the problem here. So that's how we solve it. I hope you clearly understood, but you need to practice on it. Okay, done. So we have solved enough questions on legendary and Cauchy's differential equations. Please refer the previous questions, and also please don't forget to refer the playlist for some more questions on that, so that you practice them and become perfect. Okay. Now let's move on to the next module, the final module, that is the 5th module. Fine. So that's all for the module 4. Module 3 and module 4 are like, you can score the marks, no problem. Module 4 also, if you are luck, if you get the Claret's method and if you get question like this and one Newton's law of cooling, you can easily score full 20 marks, or at least you can score at least 14 to 15 marks, no doubt. Okay, provided you follow what I say, exactly what I do and what I am doing. Please do that. Okay, this is a long video, so it's not that long because you have so much time left. You can simply give 3 hours of a time to this, around, I don't know how much time to take. One more module is left, around 3 or more hours of your time to this video, and practice the same for 2-3 times. Then obviously every day if you practice little, you will be easily able to clear it, no doubt. Okay, please. So now let's move on to the final and the last and the scoring module, which I'll do it seriously for you. I'll solve the problems. So please You can stop here, go get a calculator which you are using. I think you are using the FX 991 ES Plus. If you are using any older editions or FX 991 MS and all those things, don't use that, please. Because use only FX 991 ES Plus or some other calculator. Okay, don't use the diploma calculators. I think it's FX old edition 991 MX or don't know, or 85 something. Okay, don't use that. Only use FX 991 ES or ES Plus second edition. So please get your pen, your papers and the calculator ready and sit tight. We are going to score full 20 marks in matrices from this video. Fine then. Okay, let's move on. Starting with the module 5, the most easiest module in engineering mathematics 1, and there are many repeat questions which are asked. So this module I will solve it completely. So please pay close attention while I solve it, and I sincerely request you to follow me, take your pen, your notebook and practice along with me. Okay, because my methods are a little different from the other methods and they are easier. If you practice it, then you will be able to solve within the limited constraint of time. Otherwise, please don't tell the paper was lengthy. Okay, I show the most easiest to solve these problems. And remember, again one more thing is that don't attempt matrices first. Okay, first try the first module, then second, then you can attempt third or fourth. You can go with matrices. And if you get full 20 marks in matrices, then easily 150% no one is going to stop you from clearing the 21MAT11, guaranteed. Okay, but you have to follow what I say and practice. That's very, very important. See, ranks looks easier here and there. So first topic, ranks looks easier here and there, subtracting and making zero, but it's not like that. You should follow a correct approach. So stop what you are doing now all these years. Follow my method, it will be easy for you. So the first question is find the rank of the matrix. Okay, the problem is find rank of A is equal to 2, 3, 2, 3, minus 1, minus 1, then 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, and 6, 3, 0, minus 7. Fine. So one more thing, while taking down the problem from the question paper, please verify it twice. If you miss any numerical or any value, then obviously your whole efforts are going to waste. So 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, and 6, 3, 0, 7. So what I'll do, first I'll write A is equal to here. So A is equal to 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, 6, 3, 0, minus 7. So first thing what I'll do is, see the concept here is, if you have been following my videos, earlier videos that I explained very simple way. So the main concept is here, this 2 is like a first husband, he has 3 wives. So all the 3 wives have to go to the first husband only. Similarly, go along the columns, first column first, second column second, third column third. That means first column first husband, 3 wives, second column this minus 1 second husband, 2 wives, then third column 3, 1 wife. And last is a bachelor, first year engineering student. Okay, he's got a bag. Now, after you clear the bag, you may get married. Okay, now, making use of this 2, make all below 0. Simple concept. Make 6, 3 and 1, 0 making use of 2. How? See, 6, how to make 0 making use of 2? See, this down should be 0. Operation is down. Make 6, 0 making use of 2. So, this should be 6. So, simply multiply here by 3. See how I am writing it. When I go like this, no. So, 100% chances of getting the exact answer. You will not go wrong. Okay. See, 6 minus 6, no, so multiply whole row by 3. 3 2s are 6, 3 3s are 9, 3 1s are 3, 3 1s are 3. So what's the operation to make 6 0? R1, R2, R3, R4. So R4 minus 3, R1, and that will be equal to now 2, 3, minus 1 as it is, because the concept is any row or column multiply with the same scalar, the matrix remains same. Then 1 goes step by step, minus 2, minus 4 as I do, 3, I hope you are practicing along with me. 3 minus 2. Now, see, this minus this. I'll show it here too. See, this minus this. Then this minus this. Then this minus this. And this minus this. Be correct about the operations here. Okay, we're going to make this 6, 0. So obviously 6 minus 6, 0. 3 minus 9, minus 6. 3 minus 9, minus 6. 0 minus a minus plus 3. Then minus 7, see here, you're operating minus 7 minus of minus 3. So minus 7 plus 3 is how much? Minus 4. Be very careful here. Done. Now, we need to make 3, 0 making use of again 2. So how can I make 3, 0 making use of 2? Again, I have to make this 3, 0 making use of this 2. First, because below this 2 I have to make all 0. This work done. First, the last wave. Second wave, 3. I have to make 3, 0 making use of 2. What is the LCM? 3 2s are 6. 6 minus 6, 0. So multiply this by 2 and multiply by what? 3. 2 3s are 6. 2 1s are 2. 2 3s are 6. 2 2 minus 2 minus 4. Be careful about the signs. 3 2s are 6. 3 3s are 9. Minus 3 and minus 3. Again, R3 minus 2R3 minus 3R1. Fine. So this will be again now 2, 3, minus 1 as it is. Then minus 1 minus 2 1 it is minus 1, right? Okay, minus 1, then minus 2 minus 4 also as it is. Now see this one example. Now I'll show you everything detail. 6 minus 6, 2 minus 9, 6 minus 3 minus 4 minus 3. Okay, that means 6 minus 6, 0. 2 minus 9 minus 7. 6 minus here. 6 minus bracket minus 3. Minus 3 minus plus. 6 plus 3 is 9. Minus 4 minus 1 plus 3 is minus 1. And 0 minus 6, 3 minus 4 as it is. Now again, we need to make this 1, 0 make use of 2. Again, 1 and 2. 2 minus 2, 0. So multiply whole row by 2. See, so it becomes 2 1s are 2. Minus 2, minus 4, minus 8. So R2, R2, minus R1. Always the below row, okay, not the top row. Fine. So 2, 3, minus 1, minus 1. It's a discipline, it's a step. Row transformation or converting to echelon form is a discipline, is a step. Don't, because I've seen many people, you know, when they hear the term rank, they are excited. Rank means what? CR2, 0, 0. 3 minus 3, 0. No. This step. First, make this and this 0 making use of this. Then make this and this making 0 of this. Then make this 0 making this 0 making of this. It's a process followed. Okay. So now, see, that's what I'm doing. So this all to be 0. Now I have to make 1 0 making use of 2. So multiply 2. So now 2 minus 2 0. See here. Minus 2 minus 3 is what? Minus 5. Correct. Minus 4 minus plus 1. Minus 4. Operation is, I write it here. So that in one example you will get everything here. See, this minus this, this minus this, this minus this, this minus this. Okay. Now 2 minus 2 0, minus 2 minus 3 minus 5 minus 4 minus 7 plus 1 is minus 3. Minus 8 minus 7 plus 1 is minus 7. 0 minus 7, 9 minus 1 as it is, 0 minus 6, 3 minus 4 as it is. Now the first husband is full happy. Done. So below all 3 waves will go to all 0. Now the second husband here is what? Minus 5. Making second column second person. Below it make all 0. Second one is 2 waves. So make minus 6 0 making use of minus 5. How can I make minus 6 0 making use of minus 5? Take the LCM. 6 for the 30. 30 minus 30 0. So 5 6 are 30. 30, 15 minus 20. Again, this was 6. 6 0 0, 6 5 are 30, 6 3 are 18, 6 7 are 40. So minus 42. So the operation here, 5 R4 minus 6 R2. Am I right? That means this will be now again this equal to 2, 3, minus 1 as it is. So again this will be as it is, 0 minus 5 minus 3. See, 0 minus 5 minus 3 minus 7, then 0 minus 7, 9 and minus 1, and lastly again here this minus this, this minus this, this minus this. Practice using this method. You will not miss any rank. 100% full marks. Okay. Now, minus 30 minus plus 30. 0, 0. 15 minus of minus plus 18. Be careful of the sign here. 15. Operation is minus of 6R2. So, minus plus 18. 15 plus 18 is 33. Then, minus 20 minus of minus plus 42 is 22. That's it. Now, next, I need to make minus 70 making use of minus 5. Again, when two odd numbers, simply take LCM. That's it. 7 5 are 35. So, multiply by 5 here, multiply by 7 here. Okay. So, 5 0 0, 5 7 are 35, 5 9 are 45, 5 1 are 5. And here, 7 5 are 35, 7 3 are 21, 7 7 are 49. Okay. So, the operation is 5 R3 minus 7 R2. So, this will be equal to now. See, one more thing you can do here is, try to, scan your eyes properly on the problem. Try to make things smaller. It is in the row transformation, there's a property. If any whole row is divisible by same number, divide it. Make it smaller. See here, you see 33, 22. I can divide this whole by 11. Make it here, divide by 11. So 11 3 is 11 2 is. So this will be again 2, 3, minus 1, 0, minus 5, minus 3, minus 7 as it is. 0, again minus 35, minus or minus plus 35, 0. That's what we need here. We need to make this, making the minus 5 makes 7 0. Okay. Lastly, 45 minus plus 21 is what? 66. Again, minus 5 minus or minus plus 49 is what? 44. Again 0, 0. This is 11 3s are 11 2s are. Okay, done. Now again I can make this see 66, 44. 11 6s are 11 4s are. Okay, again I can rewrite this as is equal to now 2, 3, minus 1, 0, 5, minus 3, minus 7, 0, 0. See here, I'll do here a little. 11 6 are 11 4s are. Again 2 3s are 2 2s are 4. 3 2. This is what I get. So this becomes now, or what I can simply do is I can divide this by 22 best. Correct? No? So what I'll do? I write it. Divide by 22. That makes sense. Correct. Okay. 66 and 44. Okay. Divide by 22. So this becomes 3 2 0 0 3 2. Done. Now see below 2 all avoid 0 3 0. Below 5 second column second person is 5 0. Now below this 3 I have to make the 0. When I go to make that 0, I can see 3 and 3 both are same. So R4 minus R3. So operation is R4 minus R3. So that will imply A is equal to nothing but 2 3 minus 1 0 5 minus 3 minus 7 0 0 3 2 0 0 0 0 because 0 minus 0 0 3 minus 3 0 2 minus 2 0 0. So the whole row here has become 0. So total number of rows is 4, full row 0. The meaning of rank is highest number of non-zero rows. Therefore you can write that implies right here, that implies rank of A, row of A equals what? 3. That's the answer. Finished. That's what you get. Okay. Done. 7 marks. 67 marks water. Guaranteed in a hand. Practice what I do. See, you can practice same problems. No need to go for other problems. The second problem is find a rank of 0 1 minus 3 minus 1 1 0 1 1 3 1 0 2 1 1 minus 2 0. This problem I have already solved it. Please go refer the video. The link you can find in description. As I tell you, for all the modules I have given the questions and the link in the description below. Please do refer that. Okay, if you are serious. Otherwise, again you can leave now. Fine. Now, next one is again one more problem. Find the rank of. This also they are frequently asked the question. So find rank of A is equal to So this is 1 2 3 0 2 4 3 2 3 2 1 3 6 8 7 5. So if you are practicing along with me again with this problem along with me, then 100% need not again practice for the finals. Just glance it and go. It will be retained because my words are designed to enter your brains. That's what I do. Things make simple. Make things simpler. Okay. Now we have the problem here. 1 2 3 0 2 4 3 2 3 2 1 3 and 6 8 7 5. I rewrite it. So A is equal to 1 2 3 0 2 4 3 2 3 2 1 3 6 8 7 5. Again 4 rows. Tell me what? First person, first husband, 3 wives. I have to make all this below 2 3 6 0 making use of 1. 6 and 6. What I do? Simply multiply by 6. 1 6 are 6, 2 6 are 12, 6 3 are 18 and 0. So this will be now R4 minus 6 R1, and that is equal to nothing but 1 2 3 0 2 4 3 2 3 2 1 3 6 minus 6 0. As you understood here, I will not do it again. 6 minus 6 0 8 minus 12 minus 4. Be careful in a calculation, otherwise use calculator. Don't take any risks, because the more you try to go, do it mentally, you become mental and you are not mental. Okay. Now 8 minus 12 minus 4, 7 minus 18 minus 11, 5 minus 0 5. Done. Next, make 3 0 making use of 1 again. So multiply by what? I can multiply by here 2, because sorry 3 right? Okay, 3. Fine. So now multiply by 3. It is 3 1s are 3, 3 2s are 6, 3 3s are 9, 0s are correct. So it will be R3 minus 3 R1. See, one more thing I want to tell, because in colleges and some textbook authors, they say try to make while finding rank, try making the first element 1. See, in each and every problem is not possible, because the question may be different. So here it was, I forgot it. So 2 1, I would have taken 1 here and done it. It will become little easier, but it doesn't make any change here. Okay, here it is C1. So I am simply multiplying by 6, 3 and 2 like that. But that doesn't matter. Okay, you get the same answer. Fine. Now here is already 1. Here it is 2 1. So if I take 1 top and do it, it will be same answer. The answer will not change at all. But little bit what will happen is, if I take 1 here, no 2 here, so everything I have to multiply by 2, 3, 6, 1. Now, again, I don't think there is that much change here. Okay, same only. Fine. So now don't worry about that. Now here see, I have to make 3 0 making use of 1. So multiply by 3 whole thing. So this will be now again that is equal to 1 2 3. So what you can do is, again, this is solid. Take 1 the row, because row transformation there is a rule. You can shift the rows. You can shift this row up, take this row down. That is, make first 1 as here first and try doing it. See the answer. Please do it. Okay, don't leave it. So this is again 2 4 3 2 3 minus 3 0 2 minus 6 minus 4 1 minus 9 minus 8. Correct. 3 minus 0 3 0 minus 4 minus 11 and 5 as it is. Am I done? Correct. Perfect. So what to? Okay. Next, I have to make 2 0 making use of this one. So directly multiply by 2. So 2 1s are 2, 2 2s are 4, 2 3s are 6, 0. So R2 minus 2 R1, and that will be equal to 1 2 3 0 as it is. 2 minus 2 0, 4 minus 4 0, 3 minus 6 minus 3 and 2, and this will be as 0 minus 4 minus 8 3, 0 minus 4 minus 11 and 5. Okay, but there is a problem here. Serious question. If they ask in the examination, you will get stuck here. Why? There is 0. Correct. And remember one very important thing. The main motto of solving this problem is, if you are watching it, lend your ears, listen carefully. Principal diagonal elements can never be equal to 0 because we are using this 0 to make this. If this is 0, then how can I make the below 0? If the husband is dead, what about two wives? Am I right? This element can never be equal to 0. So now again what to do? Very simple, don't worry about it. Again with this 0 again, see with this 0 and now everything is 0 here. First husband, three wives. Now with this element, the concept is what? Row transformation, echelon form. With this element, you have to make this below 0. If this is also not there, his dead husband, then where will the wives go? Simple logic. So simply what you do, shift this to this and this to here. That's all. Yeah, you can shift any two rows. Okay? But remember again, if such situation occurs, if the element is 0 along the principal diagonal, shift, interchange the rows. That's it. Okay, don't panic. Now what I'll do, I'll change the rows. Fine, I'll R2 to R3 and that will give 1, 2, 3, 0, 0, minus 4, minus 8, 3, 0, 0, minus 3, 2 and 0, minus 4, minus 11 and 5. Done. Okay, now below this 4 I have to make 0 and this is already 0, I have to make minus 4, 0, making use of minus 4. So minus and minus obviously minus. So it will be R4 minus R2. So this will be now again 1, 2, 3, 0, 0, minus 4, minus 8, 3, 0, 0, minus 3, 2, 0, 0. Am I right? Minus 4 minus plus plus 0. Now here minus 11 minus a minus. See this is minus 8. Okay. Minus 11 minus bracket minus 8. So minus 11 plus 8 is what? Minus 3. Again 5 minus 3, 2. Done. That's it. Now everything over. Okay, now we need to make minus 3, 0 making use of minus 3. Simple. R4 minus R3 and that implies A is equal to finally 1, 2, 3, 0, 0 minus 4 minus 8, 3, 0, 0 minus 3, 2 and 0, 0, 0, 0, minus 3 minus 0, 2 minus 2, 0. Full row is 0. My work is done. See below this all, no? I made everything 0 and plus this whole row is 0. That means rank is the highest number of non-zero rows. So for this I can write rank of A, this row of A again is equal to 3. That's the solution. Very, very interesting question. That's why this problem has been repeated many times in the examination. So please follow these 3 problems and go perfectly. See, the problem is on rank and the problem here is find the rank of A is equal to 221, 22, 23, 24. Second row 22, 23, 24, 25, 23, 24, 25, 26 and the last row is 24, 25, 26, 27. So how to solve it? See, simple only. So what I'll do now, I'll first reduce it. So what I'll simply do, I will see this is my row 1, row 2, row 3, row 4. So what I'll do row 4 minus row 3 and row 3 minus row 2. So that makes the thing simple here. That becomes now 221, 22, 23, 24 as it is, 22, 23, 24 and 25 as it is. Now 23 minus 22 is 1, 1, 1, 1. Again 1, 1, 1, 1. This is what we have. Okay, let's follow the row transformation step by step. Okay, don't simply see this and subtract and get the answer. They will not give marks. Okay. Now, first step is what? Making use of this 221, I need to make all the below entries 0. Okay. So, making use of 221, I need to make 1 0. So, what I simply do multiply by 221. 221, 221, 221, 221. Right. So, this will be now A is equal to 221, 22, 23, 24 as it is, then 22, 23, 24, 25 as it is. Again, what's the operation here? 222, 221 R4 minus R1. Okay, so let's see what happens here. So we have, let's go step by step. So this will be as it is, 1, 1, 1, 1 as it is. Again, 221 minus 221 is 0. That's what I need. Again, we have 221 minus 22, 199, 199. right? Then we have 221 minus 23, 198. Then we have 221 minus 24, that is 221 minus 24, 197. Done. Similarly, we'll make next is making use of this 221, make this 1 0. So again multiply what? 221. So 221, 221, 221, 221. So we have 221 R3 minus R1. Okay. So that will become now A is equal to, again, fine. I will write here. So A is equal to, again, this will be now 221, 22, then 23, 24 as it is, then 22, 23, 24, 25. Again 221 minus 221 is what? 0. Then we have 221 minus 22 is equal to 199. Again 199. Again 221 minus 23 is equal to 198, and this is obviously 197. These are same, 199 and 198, 197. Okay. Because see, they are, we need to find the rank here, and it's a 6 to 7 marks question by using row transformation method. Don't directly write, again subtract and get the answer. Okay, there will be less marks. Again, next thing, making use of 221, I need to make 22 0. So what shall I do? So what I do is simply, multiply this by 221 and this by 22. That's all. LCM is 221 and 22. So we have 221 into 22 is equal to 4862. This is 4862 right here. Then 23 into 221, 5083, 5083, and this is 24 into 221 is equal to 5304, and lastly 25 into 221, 5525, 5525, and this will be obviously 4862 only, 4862, and next we have 22 into 22 is equal to 484. This is 484. Then we have 22 into 23 is equal to 506, 506, and this will be 24 into 22 is equal to 528, 528. So that implies A equals 221. In a matrix, the forward transformation, the row or column remains as it is. If any scalar is multiplied divided by same number, then this will be now 480. Done. Then 5083 minus 484, 4599, 4599. Then 5304 minus 506, 4798, 4798, and lastly 5525 minus 528, 4997, 4997, and this is 0, 199, 198, 197, 0, 199, 198, and 197. Done. So below this we have made all of them 0. Using making use of this, we made all this 0. Now second column, second, making use of this, you have to make all this 0. Okay, but what I can simply do is, simply directly what I can do, I can here, so after this step what I can do, I can subtract this, because the meaning of rank is it shows some steps. Okay, what? The highest number of non-zero rows. So what I can do here directly is R4 minus R3, and that will imply A is equal to 221, 22, 23, 24, 0, 4, 5, 9, 9, or what you can do, if you want, you can divide by 221. So if you divide by 221, this will become as it is. So this will be 23 as it is, say 23, then 24, 25 as it is. Okay, then next one 23 and 24, okay, 25 as it is, then 0, 199, 198, and 197, and subtract, this will be 0, 0, 0, 0. Okay, apart from this I cannot make anything 0. If you want, you can try to make this 0, but this is not remain. So the rank of A is equal to nothing but How many rows? 1, 2, 3, 4. Full row 0. So rank of A is 3. That's all. Okay. If you want to show, if you want to make, see, second making use of this, I have to make this 0, right? So obviously 22 I divide by this, it remains same. What you can do is, you can show this as 0. Multiply 199 by 23 and 23 199, make this 0 and simplify this. But the rank remains same. So rank of this is nothing but 3. So I discussed this because this question has been discussed in the old scheme question papers. Okay. I hope you understood clear how to find a rank. If you understand, if you don't, again go back, again practice one more time. You will 100% get it, my guarantee. That's all. Okay. Now the next problem is, investigate the values of lambda and mu for x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10. X plus 2y plus lambda z is equal to mu may have no solution, unique solution, infinite solution. See, there are two problems like this. One more is, both I have solved. Okay, so this problem number 2, investigate the values of lambda for x plus y plus z is 6 and x plus 2y plus 3z is equal to 10 and x plus 2y plus lambda z is equal to mu. I will solve it. Very important problem. So when during my classes now, when revising for the final, I solve this problem first, because each and every paper this problem has to repeat. That means this time also I am giving you directly. This time also it will repeat. So 7 marks in your hand. Don't ever think of missing it. Please, very high scoring areas. All this rank, this consistency, everything. This problem I solved, so please find the link in the description below. One more problem is, investigate the values of lambda and mu so that 2x plus 3y plus 5z is equal to 9. 7x plus 3y minus 2z is equal to 8 and 2x plus 3y plus lambda z is equal to mu. May have unique solution, infinite and solution. So this problem also is solved, so please watch it carefully and practice. Plus 3y plus 5z is equal to 9. Okay, and 7x plus 3y minus z is equal to, 2z is equal to 8 and 2x plus 3y plus lambda z is equal to mu. Verified. 2x plus 3y plus 5z is equal to 9. 7x plus 3y minus 2z is equal to 8. 2x plus 3y plus lambda z is equal to mu may have no solution, unique solution and infinite solution. Very important question. Like this, one more questions I have solved for 1BMAT11 that is very important. Please check that. So we have here first A argument B equals 2, 3, 5, 9. 7, 3 minus 2, 8 and 2, 3 lambda mu. So the concept of echelon form is, we make this, making use of this 2, we make below all 0. So this is simple. You can write this as R3 minus R1, because I can make directly 2 minus 2 0. Okay. So we have A argument B equals 2, 3, 5, 9. 7, 3 minus 2, 8. 2 minus 2, 0. 3 minus 3, 0. And this will be lambda minus 5 and mu minus 9. Done. Now you need to make 7, 0 making use of 2. So LCM is 14, multiply by 7 and multiply by 2. 2 7s are 14, 2 3s are 6, 2 2s are 4, 2 is are 16, 7 2s are 14, 7 3s are 21, 7 4s are 35, 7 9s are 63. So this will be now, I write here, so what is that? 2R2 minus 7R1. This will be again 2 3 5 9, 2 3 5 9 as it is. 0, 6 minus 21 is minus 15, minus 4 minus 35 is minus 39 and 16 minus 63 is how much? See, 14 minus 14 0, 6 minus 21 is minus 15, minus 4 minus 35 is minus 39 and 16 minus 63 is minus 47, and this will be 0, 0, right, lambda minus 5 and mu minus 9. Okay. So I think we are done here. Now the next is the conditions. So what they are asking now, see, my main aim was here to make this all 0, correct? I made this all 0. Okay. So this for x, y and z. 3 variables. Now they are asking first no solution. The meaning of no solution means what? It means no solution means rank of A is not equal to rank of A argument B. Then only no solution. This is possible only when I want that both ranks are not equal. Okay, this thing is rank A and this whole thing is rank B, A argument B. So now if lambda is equal to 5 and mu is not equal to 9, in that case, if lambda becomes 5, this whole row becomes 0, then rank of A will be 2 and rank of A argument B will be what? 3. In this case, not possible. Therefore, rank of A will not be equal to rank of A argument B. So, inconsistent and no solution. Now, the second case is what's that? Unique solution. So, unique solution is possible only when there is no solution. Unique solution is possible only when rank of A equals to rank of A argument B equals to n, the number of elements. That is only possible when lambda is not equal to 5 and mu is equal to not equal to 9. Then only implies rank of A is equal to rank of A argument B is equal to 3, that is equal to number of variables n, x, y, z, n. In this case, it is consistent and unique solution. You have to write a 3. Okay, and the last case is what? Infinite solutions. So, infinite solution is possible when rank of A equals to rank of A argument B and that is lesser than n. That is only possible when lambda is equal to 5 and mu is equal to 9. If both are equal, then only rank of A equals to rank of A argument B, that equals to 2 lesser than 3 n. So, infinite solutions. That's all. Okay, fine. This is how we solve it. So, you have to underline this. No solution means lambda is equal to 5, mu not equal to 9. And here lambda is not equal to 5, mu is not equal to 9. And here lambda is equal to 5 and mu is equal to 9. Compulsory, underline it. Okay, so I hope you understood the solutions here. One more time, let's revise that when they ask such questions, we find A argument B, and if the rank of A argument B is equal to the rank of A, and that is equal to the number of the variables, x, y, z means 3 variables basically. They will give 3 variables only, okay, not 4 and 5. Then it's consistent and unique solution. But if the rank of A argument B is equal to rank of A lesser than number, says if the rank is 2 and the variables is 3, then it is unique, it is a consistent but infinite solution, many number solution. If both the ranks are not equal, that is the rank of A argument B is not equal to rank of A, then inconsistent, that is no solution at all. So please practice these 2 problems. Out of both, one may be asked in the examination. Please do it. Okay, now let's move to the next problem on Rayleigh's power method. So please, I am going to solve it now here. Please keep your calculator ready, and as I told you, I need you to only get FX991 ES Plus or FX991 ES Plus second edition. If you have FX991 MS or FX 85 MS, please throw it away. No need. So please get a calculator and get ready. Fine. Now, Rayleigh's power method to find the largest or the highest eigenvalue and the corresponding eigenvector. High scoring area, 150% guaranteed question. You can get full 7 marks here. Okay. Before watching this, I request you to please go to my playlist. You can check for this video. I have solved one question on Rayleigh's power method. It's a classical question. Please do that also. So next one is 6 minus 2, 2 and minus 2, 3 minus 1, 2 minus 1, 3. This same lines, and they given the eigen vectors, initial eigenvectors at 1, 1, 1 transpose. See, they will give the eigenvectors. If they don't give, take it as, basically, it's better to take 1, 1, 1. Okay, you will get fast answers. If you take 1, 0, 0, it may increase. Okay, if they given the question 1, 0, they take it obviously. Now, I want to practice that first question and then solve this question. I'll give the the solution here for that. For 6 minus 2 2 and minus 2 3 minus 1. You can check the solution here after after solving it. Check for the largest eigenvalue eigenvector. Now coming back to the next question, I will solve it here. I'll tell you why I'm solving it. Fine. So first, using Rayleigh's power method, or simply we call it power method. Okay. Find largest eigenvalue eigenvector, eigenvalues and eigenvector for A is equal to 2, or they are given directly for, it's a 3 by 3 matrix, 2 minus 1 0 minus 1 2 minus 1 and 0 minus 1 2, and here they are given taking x naught is equal to 1 0 0 transpose, or sometimes if they don't give transpose they will give dash, both are same. Transpose why they give? Because the eigen vector is the column vector. If you remove the transpose, it will stand. That's all. Finished. Now they are given this question, they are given 1 0 0. Otherwise some question they will give. If they don't give, better take 1 on 1. Okay. Now how to solve it? So first thing, they are given x naught is equal to. So I'll take this as A is equal to. See carefully how I am doing it, and please get your calculator ready and practice along with me. Please synchronize with me, so everything will be written here. Okay, guaranteed. So 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. Take the signs correctly, and initial x naught is equal to, I will take it as, when I remove this transpose, it stands 1 0 0. They given. Okay. Now first thing what you need to do is A into x naught is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into x naught. Now watch carefully, because I am going to show you the fastest method of doing it. If you practice how I do it, you can easily solve this problem in it not take more than 5 minutes to finish the problem. Okay, because I've seen in colleges and all, they take half an hour to solve a problem. I show you the most easiest way, because you have a scientific calculator with you. That is FX 992 S plus. The simulation I'll show it side by side. Please refer it. Okay. So first, always reset the memory. Let's start. I hope you are having calculator with you. Fine. Okay. Fine. On, then shift clear 3 all AC. So all memory clear. Calculator is not yours. Okay. Now you need to enter A and x naught. So I'll take this as simply, I'll take this as, see for your simplicity, I'll take this as A and B. I'll take this as A and this as B initially. Okay. So for that, what I'll do, mode matrix is 6, number 6. Don't press 1 and all, press AC. Now to get to the matrix mode, press, see here above 4 there is matrix written. That means above 4 something small means you have to press shift. So shift 4 matrix. So first dimension 1. Now matrix A, 3 by 3 matrix. So let's enter the dimension here. So what are they? 2 minus 1 0, row wise. 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2. Okay, please verify it, because these fingers can make mistakes. So 2 minus 1 0 and minus 1 2 minus 1 0 minus 1 2. Done. Now stored, press AC. Relax. Next enter this matrix B. Again shift matrix, dimension number 2 matrix B 5. Shift matrix, it's what, dimension matrix B, it's a 3 rows 1 column 3. So 1 equals 0 equals 0 is equal to, everything stored. Now the operations. So once stored, don't follow perfectly. From practice everything gets perfect, otherwise in between you lose. So practice along. Shift, again matrix. What are you doing here? Matrix A into B. So matrix A into again shift matrix B is 4 is equal to, see I am getting 2 minus 1 0. 2 minus 1 0. The real operation starts here. Who is the highest number? 2. Eigenvalue is the highest value. So divide by 2. So divide by take this to outside. Simply here only do. Here only divide by 2 is equal to. So what I get? 1 minus 0.5 and 0. Now this is the highest eigenvalue lambda 1 and highest eigenvector x1. Okay, eigenvalue and eigenvector. But when I press, the moment I press equal to, this whole thing gets stored wherein mat answer, the most important operation to be used here. That means you are not going to enter again, you are going to use the memory mat answer to multiply it. Now again press AC, I'll show you. Again shift matrix mat A into, we are going to do now what? Mat answer into, so I'll write here. So again this will be now A into x1 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into, see 1 minus 0.5 and 0. Okay, so then what are we going to do now? Shift matrix A into shift mat answer is 6, number 6 is equal to, I am getting 2.5. So you can do directly. So highest number is 2.5 here. Okay, so what I will do is I will divide by 2.5. So when I divide by 2.5 here, see, so divide by 2.5 here, so is equal to, so what we do, divide by 2.5 is equal to, so when I divide I get 2.5 outside and inside I do directly here 1 minus 0.8 and 0.2. Okay, so now again this is the new eigenvalue and lambda 2 and x2. So again what you are going to do is again simply multiply A into x2. So A into x2 will be again 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into, see, 1 minus 0.8 and 2. Okay, now again shift matrix A into shift matrix answer 6 is equal to, so we are getting again 2 minus 2.8 minus 2.8. Okay, the highest number again is 2.8, so divide by 2.8, so write 2.8 and divide here, divide by 2.8 is equal to 1 minus 1 and 0.4285. This is what you get. Again this is the new eigenvalue and new eigenvector x3. Fine. Again A into x3 will be 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 minus 1 0.4285, and this will be again shift matrix, what's that? We have A into shift matrix answer 6 is equal to, so how much I am getting? 3.428. Now see here what happens. I am getting the answer as, I write for you, I am getting the answer here as, for you to show what happens here. 3 minus 3.428 and 1.8571. So I told you divide by the highest value. So what do you think now? You will think, who is the highest value? Minus 3 is the highest value. No, I am telling highest number irrespective of sign, because inside eigenvector can be positive, negative. Eigenvalue always take it positive. So who is the highest number here irrespective of sign? 3.42 is the highest number. Please understand it here. Okay, if you had taken 111, then you had got in 4 to 5 iterations. But here, since they given in examination 100, I am getting little lengthy. Okay, so now 3 point, who is the highest number now? 3.428. Now, so divide by 3.428. I hope you got a concept here clear. Is equal to 0.8751 minus 1 and 0.5417. Now this is the new eigenvalue lambda 4 and new eigenvector x4. Perfect. That's all. Now again we will do it. A into x4. A into x4 is equal to 2 minus 1 0, minus 1 2 minus 1 0 minus 1 2 into the math answer is 0.875 minus 1 and 0.5417. Again this is equal to same thing, shift matrix A into shift matrix answer 6 is equal to now here again 2.7504, please verify it, minus 3.417 and 2.806. Again highest number irrespective of sign is 3.417, so divide by, I take here 3.417 and inside will be minus because eigenvalue is always positive, eigenvector can be negative, so divided by 3.417 is equal to, it is 0.8045, 0.8045 minus 1 and 0.6097. So now this will be my new eigenvalue, that is lambda 5 and x5. So one more time, A into x5 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.8045 minus 1 0.6097. See, so easy it becomes. Okay. Now this will be again shift matrix A into shift matrix answer, that is equal to again 2.6099 minus 3.414 and 2.2196. Highest number irrespective of sign is 3.414. 3.414. So divide by 3.414 is equal to 0.7544. I tell you where to stop, 0.6501. So my new eigenvalue and the corresponding eigenvector lambda 6 and x6. A little lengthy problem. Okay. A into x6 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7544 minus 1 0. If you do it, practice it, it will be easy for you. Again shift matrix A into shift matrix answer 6 is equal to again 3.415, 3.415. So divide by 3.415 is equal to 0.7405, 0.7405 minus 1, 0.6736. I will do it one more time. See, where you need to stop means the answer should approximately match. Okay, only 3 digits match. Here it's not matching again. I do one more time. So this is my new eigenvalue and new eigenvector x7. Okay. Next A into x7 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7405 minus 1 0.6706 6736. Okay, again this will be shift matrix A into shift matrix answer 6 is equal to 3.414 divided by 3.414 is equal to, so 3.4 is approximately nearing now, is equal to 0.7267 minus 1 and 0.6875. It's nearing, right? So but little bit nearing. So let's do one more time, lambda 8 and this is x8. Usually this problem is given like that, so I'm solving it here. But generally in the question, all question paper, they are given 1 1 1, but they have taken it as 1 0 0. Okay, so taking 1 1 1, it becomes very easy. So what I'll do for see, I'm doing this now, so don't panic. After getting the answer, I will solve this for your sake. I'll solve this again using 1 1 1 as given in textbook and other question papers. Fine, then let's see what happens. So here, so first series again, this much I get correct sentence. Again you see shift matrix A into shift matrix answer 6 is equal to 3, it is 3, again same thing. So I write here like this, into 0.7267 and minus 1 0.6875. Okay, and that is equal to 3.414 divided by 3.414 is equal to approximately nearing now. So this is coming 3. See, eigenvalue is coming same, approximately 3.414 and 0.7187 minus 1 and 0.6957. So let's stop it here because it's approximately near C. See these values. These values. See this almost same. See this 7172 minus 1 minus 1. This approximately 7. So same approximately. So I stop it here and I write therefore the eigenvalue is, that implies therefore eigenvalue is lambda is equal to 3.414 and largest eigenvector will be x is equal to, you can write if I'm not putting transpose, then write column wise, otherwise you write 0.72 say comma minus 1 comma 0.7. That's the answer. 0.72 I can approximate it, okay, no issue. 0.78 itself means 0.72 minus 1 and 0.6957 0.7. That's the answer. Finish. Now for your sake, okay, because I don't have to get confused, in the exam they gave 100, so I got up to 8 iteration. Now what I'll do, as in the textbooks and previous other question papers, in your 18 scheme they have given this 100. If we take 111, what will happen? I'll show you how fast it happens. Okay, so I'll rub it and show you. Okay, now we solved that problem, right? Eigenvalue, eigenvector. I'll show the same here so that you don't get confused. Now see here, the same problem. Using Rayleigh's form method, find the largest eigenvalue and the eigenvector for 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, taking x naught is equal to 1 1 and 1. Okay, earlier it was 1 0 0. Okay, again, so we have now a into x naught is equal to, right here, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 1 1. That's equal to, now again the first step, take the calculator, mode, that is shift clear, 3 all equal to AC. Now again go to mode, matrix AC, shift matrix dimension, matrix A, 3 by 3, 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2 equals to minus 1 equals to 0 equals to it's minus 1 equals to 2. Please verify it. Okay, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 AC, done. Now the second shift matrix dimension, matrix B, 3 is 1 column, so 1 equals to 1 equals to 1 equals to, done. Now I have to multiply again shift. So first, okay, I have to multiply now shift matrix A into shift matrix B, shift matrix B is equal to, so I get 1 0 1. See this simple, 1 0 1. So again you can divide by 1 here, highest number is 1 1, leave it. I stored in math answer. So 1 outside, so 1 0 1. So now here again let's further the process. This is the new eigenvalue, new eigenvector. Again a into x1, a into x1 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 0 1. Okay, so again this will be equal to, now again shift matrix I divide by 1, so that is stored in the answer as we did earlier. Shift matrix A into shift matrix answer 6 is equal to 2 minus 2. So you get 2 minus 2. So again what I do, 2 is highest number, so all are same, I divide by 2, fine, 2. So 2 outside, 1 minus 1 1. Again this is the next eigenvalue and eigenvector x2. So next one, a into x2 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 minus 1 1. Again same thing, shift matrix A into shift matrix answer 6 is equal to, now see here 3 minus 4 3, that's what I'm talking about. 4 highest number is what? You will tell 3, but no, irrespective of sign, eigenvalue, 4 is the highest number here. So what I do? Divide by 4 is equal to, always positive outside and inside, this will be 0.75, 0. See this 75 I am getting little early. Here in the previous, while taking 100, I was getting, I think, in the 5th iteration somewhat. Okay. Now this is the new eigenvalue, that is lambda 3 and x3. Now again, a into x3 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.75 minus 1 0.75. Again shift matrix, a into shift matrix, answer 6. 6 is equal to 3.5 is the highest number. It's coming minus 3.5, 3.5 highest. So divide by 3.5 is equal to 0.7145 minus 1 0.7142. Again lambda 4, I am getting the answer fast here, x4. So a into x4, so a into x4 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7145 minus 1 0.7142, and that will be equal to, again now shift matrix A into shift matrix, answer 6 is equal to, so again minus 3.428, so divide by 3.428 is equal to 3.428, and this is 0.7084 minus 1 and 0.7084 as it is. So again new set of eigenvalues, that is lambda 5 and x5. Okay, eigenvector, again a into x5 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7084 minus 1 0.7084. So that will be equal to, again shift matrix A into shift we're getting matrix, answer 6 is equal to, see 3.417 divided by 3.417 is equal to 0.7073 minus 1 0.7073. It's approximately nearing now. So let's do one more iteration. So a into x6 is equal to, again 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 and 0.7073 minus 1 0.7073. It will be again shift matrix A into shift matrix, answer 6 is equal to 3.414 divided by 3.414. So divide by 3.414 is equal to 0.7073 0.7073 minus 1 and 0.7073. So see the values are same here, correct? See this value, this approximately same. So you can stop here now. Therefore here the largest eigenvalue lambda is equal to 3.414. I think previous also same answer, verified. And largest eigen vector x0, x is equal to 0.7073 minus 1 0.7073. I think exact approximately same. Again I think if that previous problem if you do 2 more iterations it will be the same exact answer, but it doesn't matter, it will get correct answer. Okay, so that's what I showed you how it happens. So earlier I took 100, I got a little longer iteration. If it make 111, I am getting this iteration. So both out they may ask in examination. So please don't miss this problem at any cost. It's very easy. I showed you how to use a calculator. So if you use it properly, you will not lose it 100%. Okay, so that's the on Rayleigh method. So that's the Gauss-Seidel method. So this first problem 20x plus y. Here also there are 2 questions. I will solve one for you here. Okay. The problem is solved by Gauss-Seidel method. 20x plus y minus 2z is equal to 17. 3x plus 2y 20y minus z is equal to minus 18, and 2x minus 3y plus 20z is equal to 25. So this problem you can see the solution here. I solved it. So please solve it yourself and practice it. So second question I solve for you, solved by Gauss-Seidel method. Okay, let's solve this question. That is x plus y plus 54z is equal to 110. 27x plus 6y minus z is equal to 85, and 6x plus 15y plus 2z is equal to 72. I'll solve it for you. Okay, so let's see the solution, how to get it. See, this is a very important question which I can discuss in VTU papers. Okay, so the problem here is solve by Gauss-Seidel iterative method. X plus y plus 54 z is equal to 110, 20x 27x plus 6y minus z is equal to 85, and 6x plus 15y plus 2z is equal to 72. So see, the condition for Gauss-Seidel method is all the elements around the principal diagonal of the given equations should be greater than the other elements. But here it's not. See, x plus 1y, 1 is, see 1 here, 54 plus 55, see 1 is lesser. Here see 6. 6 should be greater than 27 minus 1, no. Last 2 should be greater than 15 plus 6, no. So what I'll do, I'll arrange it according to fit the Gauss-Seidel condition. So what's the condition? The first element should be greater than sum of this. So I can take the second row here. So I rewrite this as 27x plus 6y minus z is equal to 85. See, 27 greater than 6 minus 1. Next, what I'll take, second element, I'll take this 6x plus 15y plus 2z is equal to 72. See, 15 is greater than 6 plus 2, 8. Lastly, first, x plus y plus 54z is equal to 110. Now, okay, 54 greater than this thing. So all these elements are greater than the other elements. This. That is the condition of Gauss-Seidel. So now from this, I'll make the equation that implies, see, from x is equal to 1 by 27. See, 27x is equal to 85 minus 6y plus z. So x is equal to 1 by 27, 85 minus 6y plus c. Y is equal to, similarly, see, 15y is equal to, right? So y is equal to 1 by 15. It's very simple way to make the equation. So 15y is 72 minus 6x minus 2z. So y is equal to 1 by 15, 72 minus 6x minus 2z. Be careful about the signs here, plus and minus. And lastly, z is equal to here 1 by 54, 110 minus x minus y. That's it. Now this is the main set of equations you need to use while solving the whole iteration. Usually it will be around 4 to 5 iterations. Okay. Now see here, they are not given initial values of x, y, z. So when they are not given, take initial x is equal to 0, y is equal to 0, and z is equal to 0. So using that, I'll solve first iteration now. What's first iteration? X is equal to 1 by 27, 85 minus 0 minus 0, because x is y is 0, z is 0. So let's use the calculator here. So 85 divided by 27, 85 divided by 27 is equal to 3.14815. Minimum take 5 different places to get the exact answer. Okay. So y is equal to, now second, 1 by again 15. What's the y formula? 1 by 15, 72 minus 6 into, right, 6 into. So what value of x I found, that will become the value for the next variable. So I found x is equal to 3.14815. So here 72 minus 6x will become 3.14815 minus 0, because that is 0. We are not found z yet. So again this will be 72 minus this will be 6 in, this will be 6 into answer, stored answer here, this value is equal to, divided by 15 is equal to, I am getting 3.54074. So next z is equal to, what is that formula? 1 by 54, 110 minus x minus y. So new x is 3.14815 and new y is 3. I hope you are getting it clear now. 4. Okay. So that will be now 110 minus 3.14815 minus answer is equal to, divided by 54. So it's 1.91317. Okay. So the second iteration now. Similarly, so x is equal to 1 by 27 into 85. What's the formula? 85 minus 6 into y. So 85 minus 6 into, what's new y? 3.54074 plus new z is 1.91317. So that will be now 85 minus 6 into 3.54074 plus 1.91317 is equal to, divided by 27 is equal to 2.432175. Similarly, y is equal to now 1 by 54, 1 by 15, sorry, 1 by 15, right? 1 by 15 from the formula into 72 minus 6 into, what is new x? 2.432175 minus 2 into z. What is z? Z is new z is 1.91317 is equal to, so that will be 72 minus 6 into 2.432175 bracket close minus bracket 2 into 1 point, make proper use of brackets here, 1.91317 bracket close is equal to, divided by 15 equal to 3.5720, 3.57204, and lastly here z is equal to 1 by 54, right? 54 and 110 minus, now the new x was 2.432175 minus new y is 3.57204. So that will be equal to 110 minus 2.432175 minus answer is equal to, divided by 54. It will be 1.92, okay, fine. Now the third iteration will be again x is equal to, this becomes the new values for the next variables, x is equal to 1 by 27, 85 minus 6 into, what is new y? 3.57204, correct, plus z, what is new z? 1.92585. So again this will be 85 minus bracket 6 into 3.57204 plus 1.9285 is equal to, divided by 27 is equal to 2.424569. Now y is equal to 1 by 15, 72 minus 6 into new x is 2.42569 minus 2 into new z is 1.9. I am finding for y, right? Okay, new z 1.9285 is equal to now, so 72 minus 6 into 2.42, please practice along with me, 42569 close and verify answers. 2 into 1.9285 is equal to, divided by 15 is equal to 3.5729. Then z is equal to, again 1 by 54, z is 110 minus x minus y, 2.42569 minus y is 3.5729 equals 110 minus 2.42569 minus 3.5729 is equal to, divided by 54 equal to, okay, this is, sorry, 110 minus 2.42569 minus 3.5729 is equal to, divided by 54 is equal to 1.9259. So fourth iteration will be again x is equal to, so the value should match approximately. It's nearing but not matching. So I'll do one more time. At minimum 4 to 5 iterations required to get the full 7 marks. Okay. So I'll show you how to verify it also. So fourth iteration is x is equal to 1 by 27 and 85 minus 6 into y. What is y? New y was 3.5729 plus z. The new z is 1.92595. Okay, so it will be 85 minus bracket 6 into 3.5729 plus bracket 1.92595. Correct now? 1.92595 is equal to, divided by 27 is equal to 2.4255. 2.4255. And y is equal to, nearing right, 2.42. Yes, I think now this is the last iteration. 1 by 15 and 72 minus 6x minus 2z. So 6 into new x is 2.4255 minus 2z. So minus 2 into new z is 1.92595. And that will be equal to 72 minus bracket 6, put a bracket 2. Otherwise you will get wrong answers. 4255 minus bracket 2 into 1.92595 is equal to, divided by 15 is equal to 3.57 3.57301. Okay, and lastly z is equal to 1 by 54. 1 by 1 over 54. 110 minus x minus y. So 110 minus x is 2.4255 minus 3.57301. Okay, last one. So 110 minus 2.4255 minus 3.57301 equals to, divided by 54 is equal to 1.92595. I think, see the values here. They are approximately same. Correct? See, we are getting this as 2. And it's 2.4, 3.57, 3.57. Yeah, so you can stop here. When the values are approximately same, you can stop. So minimum 4 to 5 iterations required, okay, to get a full marks. Don't end in 2, 3 iterations. Minimum do 4 to 5. That's compulsory condition. So where to stop, I'll show here also. Verified. See, take the calculator, go to mode, go to equation. X was at 3, no? So take number 2. Ax plus by plus cz plus dl. Put the values. 1 equals to 1 equals to 54 equals to 110 equals to 27 equals to 6 equals to minus 1 equals to 85 equals to 6 equals to 15 equals to 2 equals to 72 equals to. Now see, I will verify 1. It is 154 27 6 minus 1 6 15 2 and values are 110 okay, plus equal to, see, 2.42. So I can write, therefore we can stop here. See, same answer, exact answer I am getting. We can stop. Therefore x is equal to 2.4255. Y is equals to 3.5730. 100% correct answer. 3. After this you do 100,000 million times, you get the same answers. 3.57301 and z is equal to 1.92595. That's it. That's the solution. Easy, right? So please underline it. This is how we get it. It is Gauss-Seidel method. Very simple method, but needs practice and verify the answer to make it accurate. That's all. This is how we solve the Gauss-Seidel method. So same problem, please practice it along with me using calculator. I am 100% sure that you will get it perfect. You can solve any problem, but remember the condition what I showed. This should be greater than this 2, second row, again third row. So if the condition is satisfied, find x, y, z and find the values. I hope you clearly understood. That's it. Compulsory question. Next is test for consistency and solve. Consistency of linear equation. I solve this problem here. The first problem is test for consistency. The first one is, see the question is given. I take this as say A is equal to, or I write a question here first. Test for consistency. The question is x plus y plus z is equal to 6, x minus y plus 2z is equal to 5, and 3x plus y plus z is equal to 8. So watch carefully, don't make any mistake. So for testing the consistency also we find the augment matrix. So we have A augment B equals 1, 1, 1, 6, 1, minus 1, 2 and 5, 3, 1, 1 and 8. Okay. After finding the augment matrix, we apply the row transformation, elementary row transformation. Okay, that's what we do in the rank as we solved in previous problems. So simple, what? Making use of this 1, we make this 3 and 1, 0. So multiply this whole by 3. So 3, 3, 3. See, the concept of finding rank or the elementary row transformation is very important, as it will it occurs in the question, which can fetch easily some 14 marks. Okay, so now making use of this 1, I make this 3, 0 and 1, 0. First 3. So multiply by 3, 3 minus 3, 0. So 3, 3, 3, 3, 6 are 18. So what's that? R3 minus 3 R1. So that will be equal to now 1, 1, 1, 6 as it is. 1 minus 1, then I have 1 minus 1 and this is 2. And 5 as it is. 0. Minus 2, see what 3 minus 3 0, 1 minus 3 minus 2, 1 minus 3 minus 2 and 8 minus 18 minus 10, correct? 8 minus 18 minus 10. Now again what can I do? I want to make this 1 0 making it this one. So again R2 minus R1. So very simple problem. So that will be, this has been asked in the examination 4 to 5 times. Again 1 1 1 6, 1 minus 1 0, minus 1 minus 1 minus 2, 2 minus 1 1. Am I right? Minus 1, see 1 minus 1 0, minus 1 minus 1 minus 2, 2 minus 1 1, 5 minus 6 is minus 1. So I can also reduce this stuff. See this last row, because any row or column in a matrix according to row transformation can be divided by scalar, by the same scalar. Okay, so I can divide by 2 now. If you divide by 2, what I get? 2 1s are 2, 2 1s are 2, 2 5s are 10. That makes simple. Okay, now what we will do is making use of okay, or what I'll do, I'll keep as it is, because this is minus 2, right? Again you have to multiply, so let's keep as it is. Fine. So this is what I have now. Now what we can do here is, see I had minus 1 2, correct, minus 2 minus 2, I'll keep as it is, because the next concept is what? I need to make minus 2 0 making use of this minus 2. It will be easy, getting it? So I need to make first column first, second column second. By making use of minus 2, I need to make minus 2 0. So what's that? R3 minus R2. So that implies we have 1 1 1 6, 0 minus 2 1 and minus 1 0, minus 2 minus minus 2 0, minus 2 minus minus 1 minus 3 and 10 minus 1 is nothing but how much? Sorry, I think this is minus 10, right? Okay, I forgot here, minus 10. Okay, so minus 10 minus 1 plus 10 is minus 9. This is what we get here. Okay, so we have done the row transformation here. Now as you know, this is for x, y and z. Now see, the test for consistency, the conditions are, if rank of A argument B is equal to rank of A equal to number of the variables. Here it is x, y, z, then it's consistent and unique solution. Let's check here. So here rank of A argument B is equal to what? See, what's the rank? It's nothing but 3. Correct? No? Full all row exist. Also rank of A equals to what? See, rank of A is this whole part. Which part? This part is rank of A. This whole is A argument B. This, only this is A. Okay, that is rank of A is equal to nothing but again 3 only. So that implies rank of A argument B is equal to rank of A is equal to 3, that is equal to n, that is 3. Number of variables x, y, z. Therefore, consistent and unique solution. Very important. You have to write it. Consistent and unique solution. So same as a Gauss elimination, unique solution means, so the solution is, as I told, is for x, y and z. So if last row, see, minus 3z is equal to minus 9. So minus 3z is equal to minus 9. So z is equal to what? 3. Then put here, second row, minus 2y plus z is equal to minus 1. So minus 2y is equal to minus 1 minus z, minus 3. So minus 4. That implies y is equal to 2. Correct? No? So minus 2y is equal to minus 4, y is equal to 2. Now the first row is see x plus y plus z is equal to 6. So we have x plus y plus z is equal to 6. So x is equal to 6 minus y minus z. 6 minus 2 minus 3, that is equal to 1. Therefore, the system is consistent and it has unique solution. The solutions are x is equal to 1, y is equal to 2 and z is equal to 3. That's the final answer. Please write it and underline it. That's all. This is how it is solved. Okay, fine. Now, easy question. There is one more question here. It says, let's say here, it is a test for consistency and solve x plus 2y plus 3z is equal to 14 and 4x plus 5y plus 7z is equal to 35 and 3x plus 3y plus 4z is equal to 21. So take the question properly. It's x plus 2y plus 3z is 14, 4x plus 5y plus 7x is equal to 35, 7z is equal to 35 and 3x plus 3y plus 4z is equal to 21. One more very important repeat question. They may repeat this question this time. Okay, you can expect this question. Fine. So first we write A argument B equals 1, 2, 3, 14, 4, 5, 7, 35, 3, 3, 4 and 21. Now, okay, this first element 1, no issue. I need to make this 4 and 3, 0 making use of 1, so multiply by 3 here. So 3, 2 is 6, 9, 42. R3 minus 3, R1. And that will be again now, correct? Now 3 in the 3, 3 to the 6, 3, 3 is the 9, 3, 4 is the 12, 42. 1, 2, 3 and 14 as it is. 4, 5, 7, 35 as it is. 0, minus 3, 3 minus 3, 0, 3 minus 6, minus 3, 4 minus 9, minus 5, 21 minus 42 is minus 21. Done. Agreed? Next, I need to make 4, 0 making use of 1. It is 1, 4 is of 4. 4, 4 to the 8, 4, 3 is the 12, 4, 14 the 56. Okay, so this will be now R2 minus 4 R1. This will be 1, 2, 3, 14, 0, minus 3, 7 minus 12 is minus 5 and 35 minus 56 will be, I think it's minus 21, correct? No? Yeah, minus 20. Clearly. So this is minus 5 and this is minus 21 and this is 0, minus 3, minus 5, minus 21 as it is. Now if you see, both the rows are same. So what I'll do, R3 minus R2. So we have that implies A argument B is equal to 1, 2, 3, 14, 0, minus 3, minus 5, minus 21, 0, minus 3, minus 5, sorry, 0. And when I subtract this, we get 0, 0 and 0. Full row is 0. Now as I discussed earlier also, this whole, is A argument B. Fine. And only this part is for A. That means here rank of A argument B is equal to what? 2. Also rank of A is equal to what? 2 only. That implies rank of A argument B equals to rank of A equals to 2, that is lesser than 3, that is, and why? Because number of variable x, y, z 3. Therefore, it's what? Consistent if the rank is, if both ranks are same. Consistent unique solution. If the rank is lesser, both are same and lesser the number of elements, then consistent and infinite solution. If the ranks are not equal, then obviously inconsistent. Okay, so consistent and infinite solution. Please underline it. Now we will find the infinite solutions here. See, there is one free variable. I cannot, because x, y, z, as this is, this is x, y, and z. I cannot find this. So I simply assume let z is equal to k. A free variable, let z is equal to say k. Because infinite solution, millions, trillions, how much you want? Z is equal to k. Taking z is equal to k, I find x and y in terms of z. That's the solutions. So I take z is equal to k now. Put in second row. That implies we have minus 3y minus 5z is equal to minus 21. Correct? So that implies minus 3y is equal to minus 21 plus 5z. That is minus 21 plus 5k. So that also implies now therefore y is equal to divided by 3, minus 21 by minus 3 is 7, and 5 minus 5 by 3k. This is what we get for y. Lastly, put in the first row, we have x plus 2y plus 3z is equal to 14. X is equal to 14 minus 2y minus 3z, that is equal to 14 minus 2 into what's y? 7 minus 5 by 3k minus z is again k, because the taken z is k here. So let's take the LCM here. That will be equal to, LCM is 3. Is 3 14s are 42 minus 3 6 6 7s are 42. Correct? No, because see, LCM is 3. 2 into 3 6 6 7 are 42 plus 10k minus 9k, and this side is calculate. This will be, this is 42 minus 42 cancels. So 10 minus 9k is k by 3. That's all. Therefore, that implies infinite solutions are x is equal to k by 3, comma y is equal to 7 minus 5k by 3, and z is equal to k. So these are the all infinite solutions which we obtain. Both problems are very, very important. Okay, they can ask in the examination. So out of this, mostly one will be asked. So very, very high scoring area and high probability question for consistency. Okay, so I hope you clearly understood it. If you are solving along with me, then definitely you have got it till now. That's all. Okay, so now let's move to the next problem. Now the last part remaining is Gauss elimination and the Gauss-Jordan method. A very, very high scoring area in linear algebra or matrices. So we'll finish with that now. There are apply Gauss elimination method and Gauss-Jordan method. I given some 4 problems. I'll be solving 2 for you now here. Rest all you can try yourself. So before moving ahead, listen carefully. As the final touch or the finishing touch to completely prepare you and make you fully confident, I'll be publishing the set of model question papers designed by me. Okay, these are strategically designed question papers. So I want you to solve this properly, and when you solve this properly, something interesting will happen. That is, your fear reduces, your confidence will increase, and that is exactly the shift what we need now. So all those papers I will be uploading before the examination or a week early on my YouTube channel or my Facebook or Instagram account or pages. So please stay updated, okay, and stay subscribed. So moving on to this problem now, apply Gauss elimination method. Gauss elimination, see both are same. Gauss elimination, Gauss-Jordan. So Gauss elimination, I'll solve one question here. The problem here which we'll solve is, let's say this problem, x plus y plus z is equal to 9, x minus y plus 2z is equal to x minus 2y, sorry, x plus y plus z is equal to 9, and this will be x minus 2y plus 3z is equal to 8, and 2x plus y minus z is equal to 3. Okay, x plus y plus z is equal to 9, x minus 2y plus 3z is equal to 8, and 2x plus y minus z is equal to 3. Let's solve this. So as we solved, previously some problems on consistency, is the same method. We first find argument matrix. We have A argument B equals 1 1 1 9, 1 minus 2 3 8, 2 1 minus 1 and 3. So the simple concept is we make below this first column first person 1, below this 1 we make 1 and 2 0. So first we'll make 2 then 1. Okay, multiply by 2, 2 minus 2 0, 1 2 is 2, 2 is 2, 2 is 2 is 18. This is R3 minus 2R1. So that will give 1 1 1 9 as it is, 1 minus 2 3 and 8 as it is, 2 minus 2 0, 1 minus 2 minus 1, minus 1 minus 2 minus 3, and 3 minus 18 is minus 15. Next thing is I will make this 1 0 making this 1. So direct 1 minus 1 0, R2 minus R1. So that will be now 1 1 1 9, 0 minus 1 0, minus 2 minus 1 is minus 3, and 3 minus 1 is 2, and 8 minus 9 is minus 1, 0 minus 1 minus 3 and minus 15 as it is. Done. Lastly we need to make, see, first column over below this 2 0, second column minus 3, below this minus 3 I need to make minus 1 0. So again simple. So how can I make minus 1 0 making use of 3? Minus 3 minus 1 plus 3 0, multiply by 3, minus 3 minus 9 and minus 45. Am I right? That is 3R3 minus R2. So that will be now 1 1 1 9, 0 minus 3 2 and minus 1 0. See, minus 3 minus 1 minus plus 3 0. Then we have minus 9 minus 2 minus 11, and minus 45 minus 1 minus plus 1 is minus 44. That's it. As you know, the values here are for this for x, this for y, and this for z. Now we have made all this below 0 by using the row transformation method. Very simple. So start from down. 0x plus 0y minus 11z is equal to, so minus 11. So this method is called as Gauss elimination. Okay, making denominator this below the principal diagonal all 0 is called as what? Gauss elimination. Okay, now let's find the value of x, y, z. So we have from below minus 11, that is minus 44. So z is equal to 11 4 is 44. Then put in the second row, we have minus 3y, see 0x plus 2z is equal to minus 1, minus 3y is equal to minus 1 minus 2z, so minus 1 minus, it is 2 4 is 8, am I right? Because that is 4. So y is equal to minus 9, that is minus 9, so y is equal to 3. And lastly, x plus y plus z is equal to 9. So x is equal to 9 minus y minus z. So 9 minus 3 minus 4, 9 minus 3 6, that is 2. That is x is equal to 2. Therefore, by Gauss elimination, you can write x is equal to 2, y is equal to 3, and z is equal to 4. That's it. That's all. Such a simple solution. Underline it for the examiner to give you the full 6 to 7 marks. As is just that. Now if you want to verify again, you can use a calculator. I am using here again FX 991 ES plus second edition here. So on mode, go to equation 5, then it is what x, y, z, no. So go to second number, A, B, C, D, second. So put values 1 equal to 1 equal to 1 equals to 9 equals to 1 equals to minus 2 equals to 3 equals to 8 equals to 2 equals to 1 equals to minus 1 equals to 3 equals to, so it is 2, x is 2, perfect, y is 3, and z is 4. That's the answer. Done. Okay, so let's move ahead with, don't you know, again one more is left, Gauss-Jordan method. I'll solve an example. Again the PDF is given in the description for this all important questions, so please check it. So I solved this Gauss one question. There is one more question. I want you to practice it. Okay, I'll give the solution here. So you just verify the solution. So next one is apply Gauss-Jordan. Gauss-Jordan. Again, after Gauss elimination comes Gauss-Jordan. Okay, we'll see that. So let's solve this question. Okay, this question. 2x plus y plus 3z is equal to 1. Then 4x plus 4y plus 7z is equal to 1, and 2x plus 5y plus 9z is equal to 3. Okay. So this is a problem now. It says 2x plus 5y, 2x plus y plus 3z is equal to 1, 4x plus 4y plus 7z is equal to 1, and 2x plus 5y plus 9z is equal to 3. Okay, so verify the question correctly. 2, 1, 3, 1, 4, 4, 7, 1, and 2, 5, 9, 3, 5. The same steps here. We first find A argument B, that is 2, 1, 3, 1, 4, 4, 7, 1, 2, 5, 9, 3. Okay. 2, 1, 3, 1, 4, 4, 7, 1, 2, 5, 9. Okay, easy problem. And obviously the question papers of the VTU will be very easy. Okay. Only where you lack is discipline and practice. If you are disciplined and practice, then obviously no one is going to stop you from clearing this subject. Fine. Believe me. Now, again, this is a direct question. So what I can do is I can make this below this 2, I have to make 4 and 2, 0. So directly I can write R3 minus R1. So that will be equal to now 2, 1, 3, 1, 4, do step by step. Okay. 2 minus 2, 0. Directly 5 minus 1, 4. 9 minus 3, 6, 3 minus 1, 2. Again I need to make this 4, 0, making it 2, multiply by 2. 2 to the 4, 2 to the 2, 2 to the 6, and 2 to the 2. R2 minus 2, R1. And that will be equal to now 2, 1, 3, 1 as it is. 4 minus 4, 0. 4 minus 2, 2. 7 minus 6, 1. And 1 minus 2, minus 1. Am I right? Okay. Then 0. What I can do here is, I know I told you, right? We can, what you can do is, if the whole row is divisible by scalar, you can divide it. Make it smaller. I can divide this by 2. 2 to the 4, 2, 3 the 6, 2 and the 2. Okay. Now it becomes easy. Again, this work is over. Below 2 I made 0. Now second column, second 2. Below this 2 I have to make 2, 0. So directly R3 minus R2. So you can write A argument B now is equal to 2, 1, 3, 1, 0, 2, 1, minus 1, 0, 2 minus 2, 0, 2 and C. 2 minus 2, 0, 3 minus 1, 2, 1 minus 1 plus 1, 2. Done. Up till here, we call it gas elimination. Sorry. Below, from below, all this eliminated, we call it what? Gas elimination or Gauss elimination. Okay. Now, Gauss-Jordan means same technique, same circus. Making use of this, make this 2, 0, make this. Same way to do ulta, inward. Making use of 2, I have to make 1 and 3, 0. Making 2, I have to make 1, 0. That means, apart from this, you have to make this also 0, 1, 3 and 1 also 0. Applying the row transformation technique oppositely. Okay, let's solve that. Fine. After here's Gauss elimination. Now let's go to Gauss-Jordan. So how we do it? See, first I need to make this 3, 0 making use of this one. Sorry, this 3 and 1 I have to make 0 making use of 2. Getting it? So I'll write it once again here. That is equal to now 2, 1, 3, 1, 0, 2, 1, minus 1, then 0, 0. So again let's divide it. Make it simple. Okay, 1 and 1. 2 and the 2, 2 and the 2. Try to make things simple here. It will be easy for you. Now, what I told, making use of this one, I need to make this go ulta. Like how? Making use of this 2, I made this 4 and 2 0. Then making use of 4, I made 5 0. Here ulta. Making use of this 1, I have to make this 1 and 3 0. So how? Multiply by 3. 0 0 3 3. So what's that? R1 minus, see this should be 0. Okay, this and this. R1 minus 3 R3. And that will be equal to now 2 minus 0 2. 1 minus 0 1. 3 minus 3 0. 1 minus 3 minus 2. Alright? See 1 minus 3 minus 2. 3 minus 0. Okay, rest all as it is. 0 2 1 minus 1. 0 0 1 1 as it is. Now tell me what? Again, this is very simple. Making use of this one, again make this one 0. So obviously this will be R2 minus R3. And that will be equal to 2. See, I have to make this 0, right? 2 1 0 minus 2 as it is. 0 minus 0 0. 2 minus 0 0. 1 minus 1 2 minus 0 2. 1 minus 1 0. Then minus 1 is minus 2. Correct? Done. See, I made this 0. Now I made 1 minus 1 minus 1 minus 2 0. That's it. And this will be as it is. 0 0 1. Lastly, I need to make this 1 0 making use of this 2. So what? See, I need to make this 1 0 making use of this 2. So multiply by 2 here. 2 to the 4 2 0 minus 4. So this will be how much? 2 R1 minus R2, because there is 2 here. 2 minus 2 0. So this will be now nothing but it implies A augment B is equal to 4 minus 0 4. 2 minus 2 0 0. Then see, 4 minus 0 4. 2 minus 2 0. 0 minus 0 minus 4 minus 1 minus plus minus 2. Correct? So minus 4 minus 1 minus 2 will be minus 4 plus 2. So minus 2. And this will be 0 2 0 minus 2 0 0 1 and 1. That's all. Now here we have made this also 0 and this also 0. This is called what? Together we call it what? Gauss-Jordan. So directly all the principal diagonal will associate with the solution here. So this is x, this is y, and this is z. So directly you can write 4x is equal to what? 2. So it implies 4x is equal to minus 2. So x is equal to minus 1 by 2. Am I right? X is equal to how much? Minus 1 by 2. Then 2y is equal to minus 2. That implies y is equal to minus 1. X, y. And lastly, see, z is equal to 1. That's all. So all the principal diagonal elements gives the answer from the constants. So 4x is equal to minus 2, so x is equal to minus 1 by 2. So y is equal to minus 2y is equal to minus 2, so y is equal to minus 1 and z is equal to 1. So the answer here is by Gauss-Jordan, x is equal to minus 0.5, y is equal to minus 1 and z is equal to 1. That's the solution. That's all. Very, very easy. Let's verify if our solution is correct or not. Again mode, go to equation 5, 2, we have 2 equals to 1 is equal to 3 is equal to 1 is equal to 4 is equal to 4 is equal to 7 is equal to 1 is equal to 2 is equal to 5 is equal to 9 is equal to 3 is equal to, so we get, yeah, perfect. X is minus 1 by 2, that is minus 0.5, y is minus 1 and z is equal to 1. 100% right. This is the way to verify using calculator and to get the full 7 marks guaranteed. That's all. So that's all. Okay, so I hope I have taken much of your time. I think it's more than 6 hours. That's the end of the big video here, big movie here. But to clear this paper 21MAT11 once for all, you need to watch the video repeatedly and solve the practice along with me, because mathematics depends on practice, perseverance and patience. The more the pen moves, the more you become confident. Okay, so please practice the given videos here. Again, the PDF is shared in the description. You can find all the links over there. Please do refer my playlist for the other questions also and practice them. So it's very easy to clear. If you practice, you'll be able to clear it. Okay, and again, don't believe in passing marks. If you write for passing marks, you are going to fail. Do each and everything properly here. I have shown everything properly. Even the last module, no? Solve every question 2 to 3 times. Then you will 100% will get 20 marks full. Okay, so I have done my work. So in spite of my serious health conditions, I am suffering from cancer, but although I am having pain, when I published my video on 18MAT11, the moment I published, I got lot of messages and comments to do it for 21MAT11 also, and there is some difference between 18MAT11 and 21MAT11. So I took my time and did this. There is time for examination. So it depends everything upon your practice. How much you practice, that much you'll get the results. Okay, so that's for all. So hope you do exactly what I say and clear this paper once for all. So once again, best of luck for the exam. Okay, so whatever the results, please do comment in the section, and please stay updated for the upcoming model question paper on my Facebook and Instagram pages and the YouTube channel. So that's all, friends. Best of luck again. Bye.